Okay. Love you too. Yep, that'll do. There we go. Merry Christmas, everyone. Hope you're having a good holiday. How is everyone this morning or today, depending on what time it is, this evening? Time to be here for the entire 7 to 8 hours. I'll probably be here for the entire 7 to 8 hours too. We'll see. I know it's a surprise. Oh, let's see. I'm getting pinged on Discord. Uh, let's see. Oh, I think I'm getting pinged on Discord by Tristan, aren't I? I am getting pinged on Discord by Tristan. I can mute my speakers. I don't think that screwed with my sound, did it? It shouldn't have, but let me know if I have ruined my sound by doing that. I do have some terrifying puzzles in the queue for today, so we'll see how many we make it through. Uh, I think I've spoiled that the next puzzle is a grkles puzzle, so that may be the last puzzle we do for today. We'll see. Uh, but I wanted to start today with this puzzle because I stumbled upon this in the archive, uh, and it's actually a puzzle with exactly the same rules as a puzzle I had set before that I had liked, so I wanted to solve it. And so uh, so here are the rules for this puzzle. So these are Renban. The purple lines are Renban. This is by OddlyEven, by the way, whose puzzles I had not done before, but when I went through the archive, I found a ton of puzzles by OddlyEven that looked really appealing to me. So this will be the first, but there are more OddlyEven puzzles in the queue. So these are Renban, which means they contain consecutive digits in any order. So this could be, for example, 7, 5, 6, 4, 3, 2. That would be a perfectly fine way to fill this. I can't repeat, but as long as it would be possible to put these digits in n order, that is fine. Archiving your puzzles is a great way to actually get people to do them. Although I think that the archive is sort of, in a way, an unrewarding way to publish your puzzles because usually people do them and then they don't go back and actually rate them. So you really have no idea how many people are doing your puzzle. I try and go back and rate them, but I'm also terrible at it. Like, for example, this puzzle I will probably completely forget to go back and rate after I solve, for example. Uh, so I think if you put your puzzles in the archive, it will get a lot of people to do them, even if you don't realize that a lot of people are doing them. So that's what these Renbans are. So these green lines look like German whispers, but they are not German whispers. Uh, these are what I have called Nabner lines, but what OddlyEven calls Anti-Renban lines. These are lines that contain, again, non-repeating digits. Hey, T, welcome, welcome. Uh, but on these lines, you're not allowed to have any consecutive digits on them at all. For example, I could fill in a 3, a 7, a 9, and a 1, and that would be a perfectly fine way to fill in this Nabner line. We also have these black dots, which means that there's a negative constraint. Okay, I'm glad I read this. So this is not the same, in fact, as the puzzle that I did with these rules. This black dot means that these two digits have a ratio of 1 to 2, and all black dots are given. So that is very interesting. So with that, let's get started. And the place I want to get started is by noting that if I have 5 digits from the digits 1 through 9 that have no repeats, then those digits must be 1, 3, 5, 7, 9. That is, these digits are all odd. Now, this is a length 6 Renban, and so it will always contain the digits 4, 5, and 6. And ditto, this is a length 6 Renban, so it will always contain the digits 4, 5, and 6. Which is quite interesting because it's going to let us remove lots of places where there's a 9. Okay. So here's a Sudoku-y thing. These two together, that's one column and one box. They cover these two Renbans. And both of these two Renbans have a digit 4, a digit 5, and a digit 6, which means that in this column, there must be a 4, 5, and a 6 on the Renban, and in this box, there must be a 4, 5, and 6 on the Renban. So this can't be a 5, and these can't be 5s. And so this is a 5, and we have a digit. Digit dance. Okay, so there's no 5 over here. That's a really nice, elegant start to finding that. So this 5 means there's not a 5 here, which means there is a 5 up here, which means there's not a 5 down here, which means there is a 5 over here. Okay, so we've got that digit there. And so now we know that there is a 5 by Sudoku on this Renban, which is really interesting. Let's see. Naverio is suggesting that there's actually more I could learn from this this coloring that I did. I have said before, I really dislike set, but I really do like this kind of region counting. So Naverio is suggesting that I ask the question about evens. So there are 8 total evens in these sets. So there have to be 4 total evens on here. Ah, yeah, okay, great. I see it now. Okay, that is an excellent catch, Naverio. I would not have gotten there, although I was distracted by this 5. But this is a really good point, which is as follows. We know there are 4 evens in this column. These aren't even, so the 4 evens show up on these Renban here. Okay. Each of these Renban, because it contains 6 consecutive digits, contains exactly 3 even digits. So in total, between all of these cells, there are 6 even digits. But what that means is, if I take away the 4 even digits that show up there, there are 2 even digits in these cells in this box. That digit's odd, so I can throw it in. So there are 2 even digits in these cells. And so what that means, and this is Naverio's point, You are Naverio, right? I'm pretty sure I remember that right. But if I have said your screen name is Naverio 6 times and it turns out I am wrong, I will feel bad. But these two cells now have to be even in order to fill out the evens for this box. Okay. And so these are from 2, 4, 6, 8. But there's a fairly limited range in what they can be. Because remember, there is a negative constraint on black dots in this puzzle. So I have to repeat that to myself several times. But that means this can't, for example, be a 2-4 pair or whatever. Now, yes, excellent, even better. So chat points out, I've already said, and I should listen to myself sometimes, there's a 4 and a 6 in this box already on purple, because again, remember, we needed 2 4s and 6s. So these can't be 4 or 6. So they are, in fact, exactly 2, 8. So yes, so again, there are 2 4 5 6s in the Renban lines. So one of those 4 5 6s is in this column. The other one is forced into this box. Okay. Now, 4 can't go next to 2 or 8. That is an excellent point, Barbie. So 4 disappears from this because 4 would be crop keyed with one of those. So one of these cells is now a 4. So we're... Now the other thing I want to notice is about there being a 5 on this Renban over here has to be joined with a 4 or a 6. And probably is not joined by a 4 and a 6. But that means there's not both of 4 and 6 here. So there's a 4 or 6 here for sure, in addition to there being a 5 here, which is interesting to note. Yep, Max also notes, and this is a good spot, you can't put a 4 next to either of these blue squares. Okay, so this is going not badly so far. Let's see, what else can we do now? So there's lots of evens over here. So here's one thing I'm going to notice. This cell can't be a 4 or a 2 or an 8. Why can't this cell be a 4? Because... Oh, maybe I'm wrong. No, this cell can't be a 4. This cell can't be a 4 because I need to still put 2 and 8 in this box, and 2 and 8 can't go next to 4. So this digit is either... I guess that's not super useful. It's either exactly 6 or it's... Oh, and it's not odd either. Okay, so this digit is exactly 6. Wow, that is awesome. Okay, this is the craziest naked single I have seen in a long time. Okay. So, what are the candidates for this cell? So, it sees all odd digits. So this cell's even. Likewise, this cell's even for the same reason. It sees all the odd digits. But it can't possibly be a 4, because if it was a 4, I would be unable to put 2 and 8 in this box, because it would lock 2 and 8 out of all of those cells, and I'd need to put both of them there, which I cannot do. So that is a 4. And now that tells me that these are the 2 and 8. Coming up over here, because I've got to put them somewhere. And so this digit, whatever digit it is the same as this digit. So I can go ahead and, I suppose, color these odd, assuming that we're going to keep coloring. I don't know if the coloring is going to continue to be useful or not, but I will note that this digit is also odd and is the same as this digit. Those are the same. They'll get a yellow flash. Now, Naverio points out that now this Renban is fixed because it has a 5 on it. but does not have a 6 on it. So this must be 3, 4, 5 exactly. So there's not a 4 up here. So this 4 is over here. So there's no 4 up there. So there is a 4 up here. And so the only place a 4 can go on this entire Renban now is exactly here. This is just gorgeous so far. I am blown away already by this puzzle. Okay. So the 4 can't go here. Oops. Because it's next to a 2, 8. So this digit's odd for sure. Let's see. So Barbie is looking at what this black dot can be. So this can't be a 2, a 3, a 4, or a 6, or an 8. So this has to be a 1, and that's a 2. Gorgeous. So let's see. So, hey, Carl. Good evening. Good evening. We're off to a great start already on this this puzzle. So this odd digit goes up here. Whatever yellow is, it goes up there somewhere. I'm not quite sure where as of yet. Let's see. So these are 3 non-consecutive digits from... Yeah, that's not quite enough. Yep, the Max is right. The 2 here knocks 4 out as a candidate from there. Let's see. Oh, Listesh, welcome, Listesh. 2 in box 9. Definitely on here. So 2 is on this. So that means that this Renban also needs to have a 3 because it now needs to get to 3. The 3 is not here. So there's a 3 in one of these 2 cells. So that's not a 3. That's not a 3. So now that means one of these 2 is a 3, which actually, if you think about it carefully, I think lops 3 entirely off of this Renban. Because I have to put... Wait. I was going to say I have to put a 9 and a 1 somewhere, but I could put a 9 or a 1 here. So I don't think there has to be a 9 on one of these Renban, does there? Because I was originally thinking there had to be a 9 on one of these Renban. But is that true? I'm not 100% convinced. I'll come back to thinking about that question if I don't immediately see something else. So we've got a 2 here, a 3 here. Okay, so the 6-cell Renban can't have a 3. Yeah, so I agree this... okay. It's not true for the reason I was thinking, but it is true for a way easier reason, which is we've locked 3 off of this Renban now, and once you've locked 3 off of a length 6 Renban, it only can be 4, 5, 6, 7, 8, 9. So Renban, I actually know this. Renban is the Japanese word for serial number. And now, when I first heard that, I thought, okay, that doesn't really make any sense. What does this have to do with serial numbers? But at some point it clicked. I think when I was watching Mindhunters of all things, and they were explaining why someone's called a serial killer, that serial means in order. So it's called a serial number because the numbers have to go in order. That is the upshot of this. Okay, so these aren't 4 or 5. There's definitely a 6. No, I don't know. There's definitely a 6 there yet. I don't think. Let's see. We know the 5's down here. So these are from 6, 7, 8, 9. Oh, well, they're not 8 because there's already an 8 in the box. Oh, so they are 6, 7, 9. Exactly. Because we've ruled out everything but 6, 7, and 9 from here. So those aren't 6, 7, and 9. Those are 4, 5, and 8. So the fact that these are 6, 7, and 9 tells me that's not a 7 and 9, and that's not a 7 and a 9. Which now tells me that's a 1, so that's a 3, that's a 1. These aren't 1 or 3. So those are a 7, 9 pair. Let's see here. Okay, so what's left in this box now? I can just clear out all of those. Let's see. So 1, 2, 3, 4, 5. So I think these are 3 and 5 to finish this off. So those are both odd, although, again, I think probably the coloring is gratuitous, but I'm going to keep at it for just a smidge longer. This can't be the 6 because it would be next to a 3 and it would require a dot. Let's see. So that's odd as well. Let's see. 6, 7, 9. So these are 4, 5, 8. So I should be able to write in what these are. These should be 1, 2, 6. Okay, yep. So those are 1, 2, 6. Using, I think it was Listesh who noticed that there had to be a 2 here, which was a huge step in this. So these cells are 1, 2, 3, 4, 5, 6, 7, 8, 9 is what these are. These cells then are, oh, yep. A couple people, Max and Barbie, noticed that the negative constraint here is actually catching those. Those of you who love negative constraints with black Kropke dots will like the next puzzle, which has a bajillion uses of negative constraints on black dots. 1, 2, 3, 4, 5, 6 go up here. Okay, and so these digits are 1, 2, 3, 4, 5, 6, 7, and 9. Those are odd. Okay. Hey, Alex, Merry Christmas. Negative constraint on Renbans in column 7. Oh, excellent point, Eric. This can't be an 8 because one of these digits is a 4. And so if this was an 8, it would put a 4 next to the 8, which it can't. So that's the 5. So that's odd. These aren't 5. So they are a 4, 8 pair. I can just get rid of the corner marks. So these are a 4, 8 pair. Let's see. Let's see. I can fill in. Yeah, I can fill in these candidates. It's probably going to tell me what this black dot is. So these could be 1, 2, 3, 4, 5, 6, 7, 8. Okay. These can't be a 1, so that's a 1. Okay, so all of this nonsense is even. No. These are even. 1 is not even. 1 is odd. And I'm going to note 2 has to now be in one of these two cells because 2 can't go on the Nabner line with 1. Okay. Okay. That is good. Row 5, column 5 is 8 because of the negative constraint. I don't understand. Oh, yep. Okay, yep. This one. The 1 got a yellow flash and then I didn't see it. We'll say it's that. This is an 8 and a 2. Good. Thank you, Max. Okay, let's see. So I want to write out candidates for these to see if this is forced. Okay, so this is one of 3 and 4, but not both. And then 2 of 6, 7, 8, 9. I guess. Okay, so this is not quite forced as of yet. Okay, so the 2 in this column is on a Renban. So I don't know which one, but one of these Renban is a 2, 3, 4 Renban. And so that means that now I have... so that means... Okay, so one of these is a 2, 3, 4 Renban. Now I have left 5, 6, 7, 8, 9, and I have to find 2 non-consecutive digits to put here, and then a bunch of other things. So this has to be a 5-9 pair. That's the only way this is going to work. And so these are... I'll write this out and it'll be ridiculous. One of them is a 2, 3, 4, and one of them is a 6, 7, 8. Yep, so we get all of that. Let's see, these are both odd. So these are odd. So these are even. So these are, in fact, a 2, 6 pair. Let's see, Yep, and so Listesh is all over this and sees that the 3 has to be in the middle of the 2, 3, 4 Renban. Because otherwise a 2 and a 4 are next to each other, and I can't have that. Let's see, so one of those 2 cells is a 3. I don't know which one yet. Hey, Friar, welcome! Did one of your puzzles yesterday. Sorry I did not get to ping you. But happy holidays! Let's see, this is not a 2, because there's a 2 looking at it. Let's see. There's a 3, 5 pair here. Carl and T point out, so this is a 9 and a 5. I might as well fill in what these are. These are a 3 and a 7. So this is a 9 and a 7, resolved either by that 9 or by this 3, 7 pair. Take your pick. So the 3 and 6 have to be opposite each other. Let's see. Is it possible this is a 6? That would put a 5 there and a 7 there. I think that's okay. Okay, so the... okay. So this is... Listesh has a beautiful point here, which is, look at this black dot and think what's going to happen to this black dot if I make this Renban 2, 3, 4. Well, what's going to happen is this black dot is going to become impossible. So this is not the 2, 3, 4 Renban. So I can knock off 2 and 4 and 3. Oops. So this is the 6, 7, 8 Renban. This is the 2, 3, 4 Renban. So that's a 3, that's a 4, that's a 2. I use the negative constraint to place the 2 here because I can't put a 2 next to a 1. This is a beautiful puzzle. Wow, this is a great start to the day. Now this can't have a 6, 7, or 8 on it. So not being able to have a 6, 7, or 8 on it means that it is either 1, 2, or 2, 4. So this is from 1, 2, 4. It always has a 2 on it, so that's going to be a 6, and that's going to be a 2. That being a 6 makes that a 7 and that a 3. So this is 1, 2, or 2, 4. But it's got a 2. Let's see. Okay, so I know, looking across here, that there has to be a 4 on this line somewhere, because otherwise I force myself to choose 3 non-consecutive digits from 6, 7, 8, 9, which is not going to happen. So one of these, and I'll pencil mark this across boxes, which will bother some people. But I'll yellow them just to reiterate. One of these is a 4. Tristan observing that this looks like a radical sign, which I agree. Perhaps that's a hint that there's a perfect square on it. Hey, Ambrose, welcome. Hey, Louise, welcome. Oh, yes, and Listesh to the rescue again. I don't even have to cross the box because that can't be a 4 because there's already a 4 in the box. Expecting me to look in a box and see that there's already a digit there. Okay, so I'm being told I can resolve... Oh, the 4-8 in box 3 I can resolve. Sorry, I thought it was this 4-8. So these two I can resolve. So that's an 8 and that's a 4. I'm going to lose the coloring because I don't think it's helping. I may regret it, but I think it was necessary at the very beginning, or I think it was helpful at the very beginning. I think it's probably no longer helpful. Okay, so 4, 4, yeah. So one of those is a 4. I guess 4 was even literally placed here by Sudoku, but whatever. We'll still be happy that we used Nabner logic to figure it out. Okay. So let's see. Barbie has said in box 9 there's some negative constraint logic. Yes, the 1, 2 here have to get separated. Yeah, sorry. I think someone said that a long time ago, and I think I kept getting distracted by other things. But the 6 has to play gooseberry with the 1, 2 with the 1, 2, so that the 1 and 2 are not next to each other. Which is, I think, one of those expressions that the first time I heard Simon say it, I was really convinced he was just making it up to try and convince Americans of fake British slang. But I think it turns out that's not actually the case. Okay, 4, 5, 6, 7. Okay, never mind. Let's see. So, yeah, I was just looking at that. So where do 7, 8, and 9 go in this row? And so because of this 6 here, 7, 8, and 9 are all locked off of this Renban. So that means this is the third 7, 8, 9, which is beautiful. Let's see. Oh, and now Carl to the rescue with the point. Literally, 1 is pencil marked nowhere on this row, and I've pencil marked fully every cell except for the Renban. So this Renban is a 1, 2, 3, 4 Renban. And that's nice because this one can't be a 2 or a 3, so it's a 1 or a 4, which immediately tells me this can't be a 2, which tells me this is a 1, 4 pair, which tells me these are a 2, 3 pair, and I know the order for multiple reasons. The first one I saw is that this can't be a 2 because it's next to a 1, 4, but the much easier one is this can't be a 2 because there's a 2 immediately above it. Take your pick as to which of those you find more elegant. So that's a 5, that's a 3. Okay, so there being a 1, 4 pair here makes that a 2. This can still be a 1 or a 4, though. Let's see. Okay, so the 3 in this box is placed. It has to go there. Which places the 3 in this box up here. This is neither a 3 nor a 4, so it's a 5, and that's a 4. So that cleans that all up, lickety-split. Let's see. So these two cells, I know what they are. 1, 2, 3, 4, 5. There are 5 and a 9. Which I don't think I'm going to get any immediate help on. Let's see. Four here, 4 here. So there's a 4 up in one of these two cells. And the 4 is not here because it would be next to a 2. So that's the 4. Our friend the 4. Okay. What else do we have? This can't be a 6 anymore because it's next to a 3, so this is the 6. This has been very smooth so far. Granted, chat has been immensely helpful, for which I am always grateful. Let's see. Okay, so I hear tell about 5s in box 1. So 5 in box 1 cannot be on the Nabner line because there's definitely a 4 on the Nabner line. So 5 is not in any of those places. So 5 is in one of these and 5 is also not in a column with a 5-9 pair. So 5 is placed there. 1 in box 8 is placed by the negative constraint there, which makes that a 2 and that a 1. Let's see. Hey, you're welcome. This is an amazing puzzle. I am incredibly impressed with this puzzle. Amusingly, literally this month, the puzzle I submitted to Cracking the Cryptic is a puzzle that features Anti-Renban lines and Renban lines together. Which is why when I saw this, I was like, oh, I've got to do this, because it's similar to a puzzle that I have made. But this is just a brilliant execution of this. And I really like the negative constraint on black dots in this puzzle. So let's look up here. What can these cells be? So we have a 1, 2, 3, 4, 5, 6, 7, 8, 9 left to place. These can't be 6 or 7. These can't be 1. Yeah, so I knew this was going to be 6, 7, 8, 9. It's not going to... Oh, it could be an 8. Because the 4 doesn't have... Oh, the 4 is placed. So that's a 4. I see a couple of people in chat saying they think that this has to be a 1 or a 2 because there needs to be a 1 or a 2 on here. I think I believe that. I haven't had to pause long enough to actually prove it, but I'm pretty sure I agree that this is going to have to be the 1. I think. Let's see. This can't possibly ever be an 8. Oops. Okay, so I was going to say it can't possibly ever be an 8 because it's next to a 4, 8. So this is not an 8. But then when I accidentally misentered it, it showed me that, in fact, it also can't be an 8 because of that. Okay, so let's say I try and make this a 9. Will that work? If this is a 9, I now have to pick 2 digits here that both have to be larger than 5, but without being consecutive to 9. Yeah, that's not going to work. I'd have to pick 3 digits larger than 5. So this is a 1. Good catch, everyone in chat who suspected that. So that's a 4. Oops, that's a 1. Welcome, Tallcat. Welcome. That's a 4. That's an 8. That's a 4. So that's not a 1. That's not a 1. So one of these is an 8. I don't know which one. 4 in box 8 can't be next to an 8. We have the 4 in box 8. Are we saying we know the 8 goes in? The 8 definitely goes over here in this box. So the 8 goes over here in this box. And so the 8 goes up here in this box, but not next to the 4. And not down here. So that's an 8. So I think someone was getting me at I could place this 8. So that's not an 8. So yeah, so one of these two is an 8, but I don't know which one. Let's see, what is left in this row? 1, 2, 3, 4, 5, 6, 7. It is just 6, 7, 8, 9. Those two aren't 8. So they are 6 or 9. 6, 7, and 9. Column 2 sees up. Ah, yes, column 2 only has a 9 left, so that's probably going to clean this up. So yeah, if I make either of these a 7, the Nabner is going to break, because these have to come from 6, 7, 8, so they're not 7. So that's a 6, that's an 8, that's a 7. These aren't 9 for oh so many reasons. Let's see. Is there a negative constraint somewhere cleaning this up? I don't think there is as of yet. Let's see. These are from 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see. These aren't 1. These aren't 2. These aren't 3. Oh, this one is just almost done. It's not a 3 or a 2 or a 5, so this is a 9, and that's got to be a 7. So that's a 9, that's a 6. That's not a 9. So the 9 in this box is down here, which means these aren't 9. So they are from 1 to 5. I'm eyeing negative constraints here as I do this. These aren't from... Oops, those aren't 1 because there's a 1 in the column. So in fact, the 1 is placed. The 1 is there. I seem to recall someone saying the 1 in box something was placed a while ago, so they may have seen this a while back. I think that might actually be my last one. Yeah, that is my last one. So there must be a digit I've placed in this box that I have not removed because that's too many candidates. Ah, yeah, these aren't 9. So one of these is a 2, and it's not that one because of the negative constraint. So there we go. So that's a 5, that's a 3, that's a 2. That's a 6, that's a 3. That 6 sees over that, that's a 7, and that's a 6. That 7 sees over here, that's a 9, and that's a 7. Let's see. So now we're really narrowing it all down. This can't be an 8 because of the 4 next to it. So let's fill in the rest of this column. Oh, yes, I absolutely say I'm eyeing for negative constraints, really to remind myself that I'm probably not eyeing for negative constraints, and I should be. So Barbie catches this negative constraint. That's going to be a 7, and that's an 8, so that's an 8. It's not an 8. That's not an 8 either. That's not an 8, so that is an 8. This is not a 7 or an 8, so it's a 9, so that's a 7. Let's see. So now we've got very few digits left. 1, 2, 3, 4. I got to really hurt Tristan's brain with a puzzle last night that involved using the negative constraint over and over and over again. I found, and I mostly blame 2toTenth for this, but I found a real deep love of negative constraints on black dots as a way of doing puzzles. Let's see, this is a 5, 6, 7, 8, 9. So is this resolved? Ah, yes, it is resolved because of that 6. So that's a 5, that's a 6. So that's a 9, and that's a 5. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Gorgeous, gorgeous puzzle. Thank you for letting me do that one, OddlyEven. As I alluded to perhaps before you had shown up, when I looked through the archive, I saw a lot of puzzles from you that I wanted to do. So this will probably not be the only one. It might be the only one we get to today, depending on how long this grkles puzzle we have coming up takes. But I will definitely be doing more puzzles by you in the future. But yeah, that was pristine. All right. So next up, I have been asked for a long time to do grkles mod sandwiches puzzle. So I'm going to do grkles mod sandwiches puzzle. So we have to understand what this rule set is. So we have normal Sudoku rules, so I'm happy with that one. These outside clues are a weird kind of sandwich clue. So a regular sandwich clue would tell you the sum of the digits between the 1 and the 9. And so it would record the sum of all of these. Oh, oops. Thank you for pointing that out. Now, hopefully, they're not cut off. So normally, a sandwich clue would give you the sum of the digits between a 1 and a 9. However, in this case, we have modded the total of the sandwich by the length of the clue, including the crust cells. So let's do the example that is included so that we can see this. So, for example, in row 2, if we were to write 1, 6, 4, 5, 9, oh, sorry, it's telling me if the row, it's telling me all the digits. So if the row is 2, 1, 6, 4, 5, 9, 7, 8, 3, if this is the row, I look at the sandwich, which is the digits between 1 and 9, and I say, aha, this is a sandwich of length 5, so I add these digits, 6, 5, and 4, and get 15, and then I divide 15 by 5 and take the remainder. And so in this instance, the remainder would be 0, and so the reported sandwich clue for this arrangement of digits, ignore the row, would be 0. I could have put this in row 3 and it would work. But if I were to, if I were to switch these like that, now this sums to 17. If I divide 17 by 5, then I get a remainder of 2. And so this row would be correctly filled. Okay, so that is how the sandwich clues work. But now there's an extra pair of rules. Each row or column which has been assigned a clue has a different sandwich sum. So I have to remember that I can't repeat sandwich sums, so that's an interesting thing. And for the indicated diagonal, the clue outside the grid is the sum of the crust cells along the diagonal mod the length of the diagonal. So I'm just taking the sums here on this diagonal of the 1s and 9s. And then once I do that, then we'll be in good shape. Oh yes, Tristan will post a link to the puzzle in the chat. I think. Unless Tristan is away from the computer, in which case he will very shortly post a link to the puzzle in the chat. Let's get started. So I just want to double check here and make super sure. Yeah, so this is mod as interpreted by a physicist, as grkles is a physicist, not as interpreted by a pedantic mathematician. So one thing I'm seeing is that when this is an 8, that must mean that there are more than 8 cells in the sandwich, because if the sandwich were length 8 or shorter, I could not have a remainder of 8. So that means these two are 1, 9. So those are my crusts, which we will make purple today. And then all of these are safe. And so hopefully if we take 35 and we mod it by 9, then we get 8, which indeed we do. So good start. I think we maybe understand the rules. Maybe, possibly. Okay. And there are no other 35s because it says, oh, sorry, it does not say that. It says no clued cells or no clued columns or rows have the same sum. So we've got our reward for reading the rules one. So this column, by a similar thing, has to be a length 8 or a length 9 sandwich. But it cannot be a length 9 sandwich because that would give 235 sums include columns. So we know one of these two is a crust and one of these two is a crust because there must be exactly one outie. And so all of these are not crust. They're all safe. Now this 6 is interesting because I can only possibly get a remainder of 6 out of a sandwich of length at least 7. But also, because of these two green cells, the length here has to be at least 7. Or sorry, it has to be at most 7. So those two become crusts. So these are... I feel like we've already gotten to difficulty 3.5 just by having to read the rules, even if nothing actually happens in the actual puzzle. But okay, so now we're looking here mod 7. So 6 mod 7 says the sum of these is... Oh boy. So 35 mod 7 is 0. So the sum of these mod 7 is -1, or 6, I suppose. Wait, no, I said that backwards. The sum of these mod 7 has to be 1, right? Is that right? Did I do that right? Yeah, because mod 7, all of the filling sums to 0. So yeah, so these need to sum to 1 mod 7. No. These sum to 6 mod 7. So these two sum to 1 mod 7. That's the deal. Okay. Let's see. Okay. This 5 clue is also fixed, as Inferio notices. Thank you. Because the only way I can get a 5 is with modding by something that's at least as big as 6, and it's at most 6, so that is bread. These are safe, these are safe. This is 1, 9. And so that's going to resolve now column 1, because now I have both of my crusts down here, and remember this had to be a length 8 sandwich, so these are crusts. So this is not a crust. These are not crust. So these are a 1 and a 9. Okay, and now I should know what this digit is. It's going to hurt my brain, but we're going to figure it out. So we're supposed to get to 7 mod 8. What do I get if I add all of these numbers? I get 35, which mod 8 is 3. So what do I need to take away from 3 to get to 7? Sorry, what do I need to take away? Yeah, what do I need to take away from 3 to get to 7? I need to take away 4 mod 7. Okay, so this digit is 4 mod 7. And luckily, there's only one digit in Sudoku that's 4 mod 7. And Listesh agrees with me, so I am very happy that I did that right. Somehow I keep wanting to negate it one too many times. Also, I am noticing these digits are not 1s or 9s. I don't know if that will be helpful, but I will note it anyway. So this 6 is also forced, because again, it has to come from a sandwich of length at least 7, which can only be that. So these are 1 or 9. And so now I've finished all of the 1s and 9s in these rows. Now this one needs to be of length at least 5, and it can only be of length 5. Uh-oh, not row 2. What did I do? I keep seeing not row 2. Oh, not row 2. Sorry. I just greened. I got overzealous with my greening. Hey, 11 Tickles. Feel free to go back to sleep. I'll be here for a while. Now, does that break my deduction here? That does break my deduction here. Okay. Okay, this 4, though. 2, 3, 4, 5, 6. Nope, that's still fine. Interesting. So I'm supposed to think... Oh! Thank you. Yep. So a couple people pointed out I had failed somehow in my greening to green this this cell. So I also get to purple these 2 now because this needs to be of length 5. And so I can green these 2. And so now I can green the rest of this row. So that's a 1 or a 9. That's a 1 or a 9. I probably should start coloring my crusts because I'm seeing I can do that very nicely. Because this is just set up beautifully for me to color these. So I don't know which is which, but it is often quite helpful to be able to identify cells which see both flavors of crust. And I just want to have that sort of pre-done for later. Oh, this is orange. Okay. Now, it may turn out that there are literally no cells which somehow which... Oh, this is one. This sees both flavors of crust. So that is green, and so that means this is the orange flavor of crust. So that's a 1 or a 9. Let's see. Yep, so now we can look at this row 5, which is what chat has been on about while I have been happily coloring away at my sandwich crusts. This is got to be a 1-9 pair because this has to be length at least 5. So that's black, that's orange. Merry Christmas, Ranksk. Welcome. So that's green. We will learn from the errors of last time. This is now green because it sees... Oh, well, it sees everything in the column, so it's not so exciting. It may turn out that this coloring is... Well, this coloring can't be useless because the coloring is going to be what resolves this 2 clue. Let's see. And I'm told something about orange in box 8. Yep. So that's green. That's orange. So that does all of that. Okay. Row 7, column 6 sees both. I seem to have gotten there. The black shading is 1 because of the little killer. I don't know if this is black yet or not, do I? Okay, so let's read the rules about the diagonal again. The indicated diagonal, the clue outside the grid, is the sum of the crust cells along that diagonal mod the length of the diagonal. Okay, so the length of the diagonal is 9. So yes, so... Okay, so yes, so... we're modding by 9, and so it's telling me the sum of all of these things mod 9 is 2. So I have to fill this now, and so it's going to turn out this is nothing, because if I did make this a crust, it would be black, and then it would be impossible to make this 2 work out, because either I'd make orange ones, in which case the total mod 9 would be 1, Or I would make black ones, in which case the total mod 9 would be 3. So this is not crust. So the diagonal actually not only disambiguates what black is, it also finishes the crusts for us. That is not the right combination. There we go. No, that's not right either. There we go. That combination. Third time's the try. So third time's the try. Wow. Okay. It's going to be a day. We'll just say that. Okay, so then that is my last sandwich. Okay, so now all of these black purples. Oh, yeah, I don't think I can do that. All of these are 1. And all of my orange purples are 9s. And now I'm going to remove all the black highlighting and all of the orange highlighting. Let's see, can I do it like that? Yeah. Orange, black. Just purple those and remove all the green highlighting, because I don't need the green highlighting anymore, and it's distracting. But I will leave the sandwich crust highlighted. And so now we have all of our crusts done. Are people arguing that I did something wrong? I don't think so. I'm just double checking. Okay, so let's see. In this case, this is 6 mod 7. That's not super helpful. These are 4 mod 5. I don't think that's super helpful. This is 2 mod 3, so this is only from 2, 5, or 8. Those are the only options that are 2 mod 3. Let's see. This is 0 mod 4 is the sum here. So it can't sum to 4. It could theoretically sum to 8. Or 12. Can it come to sum to 16? Yeah, it can sum to 16. Let's see. Okay, this is 4 mod 5, 6 mod 7 again. I have another 2, 5, 8 in row 4. Oh, no, it can't sum to 16. Thank you. Because that would require a 9. And I was like, yeah, you can make that. Okay, row 4, column 6. 1, 2, 3, 4, column 6. Yes, this is another 2, 5, 8 for exactly the same reason. And somehow I just did not see that one. Okay, let's see. So there's 2, 2, 5, 8s. Let's see. Yep, so there's... and this one's not 8 because there's a given 8. I can say that. Just barely beat Tristan to the punch on that one. Okay, so what else can I do? Yeah, we don't believe in given digits in this house. Something. Okay, so this needs to sum to 4 mod 5. So these two need to sum to 1 mod 5. So could they sum to 6? Yes. Could they sum to 11? Probably. Okay. Yeah, and again, this is also summing to 4 mod 5. Okay. So you think I should pull out a sheet of paper and write all of the numbers that are what mod what down? Let's see. Okay, so sorry, I cannot show you this, but I'm just going to write down the numbers that are what mod what per Navario's advice. So let's see. So I'm just going to go one at a time. So these are the numbers that are 2 mod 5. So the numbers that are 2 mod 5. Well, it certainly doesn't sum to 2. It doesn't sum to 7. And so it could sum to 12 or 17 or 22. 22 doesn't sound possible. 8, 7... Yeah, 22 is not possible. So these sum to 12 or 17. Is it possible to get to 12 with a 3 out here? Let's see. So hey, grkles. I am to the writing lists of numbers that are something mod something. So it is just possible I could do 2, 4, and 6. Yep, okay. Well, we got all the crusts placed, so I feel pretty good about that. Yep, 2, 4, 6. Let's see. The numbers that are 6 mod 7, that comes up a couple times. Well, 6 certainly isn't right. These things certainly can't sum to 13. So... Yeah, I did that right. Okay, so they could sum to 20, or could they sum to 27? Yeah, 27 seems possible. So the outies here either sum... Oh, wait, I don't think 20 is possible, actually. Because if these were to sum to 20, then the outies here would have to sum to 15. But the only way to make 15 is with 7, 8. And note there's an 8 here. So actually, these two digits sum to 8. So these are 2, 6, or 3, 5. Okay. That doesn't work for this 6. But for this 6, I actually know the sum is 27. Okay, for 4 mod 5, which shows up a few times, the possibilities are... the possibilities, well, it's certainly not going to sum to 4. It could sum to 9 if it's exactly 2, 3, 4. Could sum to 14 or 19. And 24 is too big. This is 5 mod 6. Oh, that's right. Thank you, Listesh. Or sorry, thank you, likewise. I completely had forgotten about that rule. That is, okay. That is huge and important, and I just completely blanked on it. One of the rules of the puzzle is explicitly that no two clued sandwiches have the same sum. And so we said for 6 mod 7, the only possibilities are 20 and 27. This one sums to 20, so this one must sum to 27. Sorry, this one sums to 27. So this one sums to 20, and so these are a 7, 8 pair. Okay, so that fixes that. Was that relevant anywhere else? The 2 mod 5. Was there another 2 mod 5? Let's see. I don't think so. Okay, I'm going to be on the lookout for those. Look at row 6. Yeah, so this is 0 mod 4. Okay, I will skip ahead on my list. I'll look at 0 mod 4. So it's not 4. It could be 8 if this is exactly 2, 6. Let's see. If it wants to be 12, I think it actually can't be 12. Because what are the ways to make 12? Well, I can't use 9, 3 because it's a sandwich puzzle. I can't use 8, 4 because there's an 8 in the box. And And I can't use 5, 7 because there's a 5 in the row. So actually that total can't be 12. And then 16 is too big. So these total to 8. And the only way they total to 8 are 2, 6. So that was an excellent catch, Carl. If you and that gives us tons of things. Because remember, these two sum to 8, and so they can't be 2, 6 anymore. So those are 3, 5. That is a 5. That's not a 5 now. So that was gorgeous. Okay, so that just did lots of stuff for us. So these 3 digits, I can go ahead and just write in what they are. 3, 4, 7 are what those digits are. Oh yeah, and there's a 7, 8 pair there, so that's the 7. And so now this is suddenly very interesting, because I've got to get a sum that's 4 mod 5. I currently have a sum that's 0 mod 5, so this is 4 mod 5, and the only 4 mod 5 digit I'm allowed to put here is a 4. So that's a 4. Okay, and someone's saying row 3 is therefore not 8. Ah, yes. So row 3 now, which is also 0 mod 4, can't be 8 anymore. And so it now has to be 12. And so 12 was, again, 4, 8, or 5, 7. And I don't think I know which one it is yet. But good point, because of the not repeating sums. Column 5. Oh, yeah, column 5 resolves this. So that's a 4. That's a 3. That's not a 4. So that's not an 8. And that's not a 7, so that's not a 5. All good stuff. Now 4, 8 is not possible. Oh, yeah, because that 8 there... Yeah, the 4 and the 8 are looking at that. Okay, yes. Almost got there, but did not get there. Thank you, chat, for seeing that. So that gives me that's a 3, that's a 5. Down there. Okay, so this has got to be a 2 or a 6. Yeah, this is very clever. As to be expected of a grkles setter. So this is a 2, 6 pair to finish off the row. I don't think I know anything about the order yet. Row 2 can't use 8 again. Oh, yes. Okay, yes, that's an excellent point. Ambrose is correct. This sum is 8. So if I made this an 8, this sum would also be 8. So that's a 2. It's a 6. That's a 2. That's a 6. So that gives us more digits. Let's see. Where else do we have stuff floating around that looks appealing? Okay, we can... Let's see, I'm trying to decide which of these I least want to not look at. Okay, so let's look at this one. So what are the candidates for this cell first? Can't be 1, 2, 3, 4, 5, 6. Okay, so this is a 7 or an 8. Those are the only candidates for the cell. And now that this is only a 7 or 8, I can probably force this. Oh yes, please like, comment, and subscribe. So if I look here, I'm trying to get to 2 mod 5. So I'm trying to get to, it looks like, well, I would say it looks like 12 or 17 based on my previous notes, but it can't sum to 12 because we've already used 12. So this has to sum to 17. And so the question is, how do I make these numbers sum to 17, or have I broken the puzzle? But but I think the only way, if I make this a 2, I'm not getting to 17. So I have to make this a 6. And then once this is a 6, I need to make that a 7. And so that resolves that that's an 8 and that's a 7, and resolves that that's a 2. So that that does it. So these two digits are now a 2 and a 3. And I know the order. That's a 3, that's a 2. Welcome, by the way, Apple Reborn. No, that's not what it says. Well, welcome, Apple. No, sorry. Sorry, my being dyslexic is making it very difficult for me to read the screen. Appel. Welcome, Appel. Sorry about butchering your screen name there. So let's fill in the remaining candidates here. So we've got a 2, 3, 4, 5, 6, 7, 8. I really like the way the rule about not repeating things has come into play in this puzzle. That has been a lot of fun. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now this is looking tempting to look at. So this has to be 4 mod 5, which looks like 9, 14, 19. I decided I couldn't get to 23. I don't think I've used 9, 14. Okay, so saying Apple wasn't way off. I felt bad that I had just like butchered a name by misreading the order and making up words. But I was at least in the ballpark. Okay, so this looks to me like it could sum to 9 still, in which case this would be 2, 3, 4. I don't think I can get to 19 because I'd need these two to sum to 17, which they definitely can't. So they either sum to 14 or 9. So if they wanted to sum to 14, I'd need these two to sum to 12. Is that possible? No, it is not possible. Because if I try and make these sum to 12, well, I can't use a 6 in a sum to 12. That's like my favorite Sudoku deduction. If I wanted to make this a 5, I'd have to make this a 7, which I can't. And if I wanted to make this a 3, I would have to make this a 9 that somehow was not a crust, which I super can't do. So this is, in fact, 2, 3, 4. Exactly like that. So those are that. Alrighty. 4, 5, 6, 7, 8. Yammer. I know Yammer. Does that count? Let's see. So 5, 6, 7, 8 for those. That can't be a 6. That can't be a 5. I'm getting news in about a 3 in row 9. Let's see. The 3 in row 9. Oh, sorry. The 3 in row 9 would help if I actually looked at row 9. How on earth did I conclude that was row 9? I don't even know. So one of these two has to be a 3, and this one can't be. So that's the 3. Thank you, Barbie. Let's see. So one of these is a 3. One of these is a 3. And one of this mess is a 3. But that doesn't seem like the low-hanging fruit yet. Okay, so sandwiches are making good progress. This sandwich still looks like a mess, so I'm going to try and avoid it if I can. I might not be able to. I think this is now the one to look at. Oh, let's see. Naverio says I can resolve column 1. So maybe I can resolve column 1 before I have to look at more sandwich stuff. So what's left? 2, 3, 4, 5, 6, 7, 8, 9. No, not 9. We already have a 9. So this is a 6. That's not a 6. That's not a 6. where am I seeing a 5 or a 7? I don't see how I disambiguate these two, but still, it's progress. Let's see. 5 in box 7. Oh, yes. 5 is just placed in box 7 by Sudoku. Thank you. I was looking at it backwards. Or I guess the 5 in this column has to go up here. Which is like either called a pointing pair or a locked candidate. I think I'm learning that those are synonyms. I could be wrong. Chat can tell me if pointing pair and locked candidate aren't synonyms. You can place a 5 in box 7. I have placed a 5 in box 7. So let's write in these candidates. 2, 3, 4, 5, 6, 7, 8. Let's see. That one's not a 6. Yep, that looks to be about what I got. That one's not a 5 anymore because of that 5. Okay. So I think I was coming to this sandwich as my next one. Or was there another one that I had laying around that looked better? No. Okay, so this is a 4 mod 5 sandwich. So it can't be a 9 anymore for multiple reasons, but it can't sum to 9. So this is either summing to 14 or 19. Let's see. 6 and 7 in row 9. So 6 in row 9 is not here. So yeah, 19 is too big given that this is a 3. Okay, I think I'm going to try and do the 14 first and then go back to that. Okay, so these two need to sum to 11. That's the moral of the story. So this can't possibly be a 2. If this is a 6, this would have to be a 5, and it can't be. If this is a 7, this has to be a 4, and it can be. And if this is an 8, this has to be a 3, and it can't be. So that is what happens. That's a 7, that's a 4. Oh, I have a 19 already, too. It couldn't sum to 19 because I need these to sum to 16, but apparently I have a 19 somewhere. Okay, that 2, 8 there makes that a 6. So that is a 7 or an 8. No. That is a 7 or an 8. There we go. So that 7, 8 pair means that this isn't a 7 or an 8. It's a 5 or a 6. What is this? This is 1, 2, 3, 4, 5. No, 5, 6, 7, 8. These are also... Oh, what are these? That's interesting. Because this is now has to be a 2, because the 2 is placed in here just by Sudoku. So that's an 8, that's a 7, that's an 8. I think Barbie saw a smarter way for me to see a hidden pair of 6 7s down here or something, which I did not see. But we got there in the end. So that's a 5. That's a 2. Okay. This is a pair of 7, 8. The 7 there and the 8 there. So this is now fixed. I think it's a 4. Let's see. 4, 5. Let's see. I need a 6 and an 8 up here. I don't think I know the order yet. Let's see. These are a 3, 5, 6, I hope. These are 3. No, not 3. Oh, no, not 3, 5, 6. Why do I have 3s pencil marked over here? Hopefully that was just an error. Okay, we're going to re-pencil mark this because I no longer believe myself. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I have no idea how I pencil marked 3s over here. I should not have. But we have it fixed now, hopefully. this is now 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these are 3 and 4. Okay, so this column, 2, 3, 8, 3, 4, and 8. Okay, so this isn't a 3 or a 4, so it's an 8, and that's a 6, and that's a 5, and that's an 8, and that's now a 3, and that's a 4. Oh, I just wrote it in the wrong place. Okay, that makes sense as to how that happened. 4, 5. Okay, so we got a... Nope, not 6. Take 2. We've got a 7 there. I can usually find the missing digit out of a row in at most 2 tries, most of the time. Occasionally 3. So let's see. Here we need to have a 3 and a 6, which I can't resolve yet, I don't think. Here we need to have a 2 and an 8, which I don't think I can resolve yet. So now, the one sandwich we have not used yet is this one. So this says that mod 6, the sum of these digits, has to be 5. Okay. So now I'm going to try and do this subtraction thing I did before and confuse myself. Okay, so in total, all of these digits, mod 6, sum to 35, which mod 6 is 5. So that means these have to be divisible by 6. Okay, so that worked out better than one could have hoped. So that's 1 mod 6. So these two need to sum to 5 mod 6. So they could be, if this is a 3, this has to be a 2. If this is a 6, this has to be a 6. So that can't be a 6. So that's a 3, that's a 6, it's a 5, that's a 6. Yeah, I think this actually works either way. So that's not going to get resolved just yet. But that 3 has made that a 4, and that a 3. That 4 has made that an 8, and that a 4. That's been a 2, and that's an 8. And now we should hopefully be finishing up. 2, 6, 5, 2, 5, 6. Ta-da! Nice puzzle, and not quite as brutal as I had anticipated originally when I started. I'm going to take a very short break, and I will be back in 5 minutes or so, and we can get started with the next puzzle. welcome back. I guess I'm really welcoming myself back because you didn't go anywhere. But anyway, we're back now with another puzzle, this one by BremSter. Oh, sorry, it's because I keep kicking my desk. I am intending to make my camera less shaky by getting a nicer desk at some point. But I will do my best to not shake the desk that it is sitting on. Sorry about that, Elvira. But welcome. All right, so here we have an XV, unless this deserves kicking. Yes, so here we have an XV puzzle. So this is normal Sudoku rules, but the V's here are 2 digits that sum to 5. The X's are digits that sum to 10, like the Roman numerals is what you're supposed to think of. Although if you never thought about Roman numerals, you just have to remember that X is 10 and V is 5. And that this is not a less than sign, even though it looks like a less than sign. And then we have our friends white dots, which we've actually not seen very often in these puzzles so far across my holiday streams. The white dots separate 2 digits that are 1 apart. So one way to think about it is that there's a little itty bitty Renban between these two. I think that's the nicest way to think about white dots. And then black dots mean that there's a ratio of 1 to 2. Yeah, so this is a gorgeous looking puzzle. So let's get started. Hopefully, usually BremSter puzzles are very clever, very pleasant to solve, and usually not too difficult. We'll see if that holds with this one. So the first thing to do is to fill in 1, 2, 3, 4 for all of the V's. That is always how I go about this. And I think I'm going to have to color. Maybe I'm not. We'll see. But I'm going to. I'm going to color that these digits are low. So here I'm coloring as blue, and blue is the correct color for low. Digits that are 1, 2, 3, 4 get the color blue. It's also very possible I should be coloring for odd and even. Maybe? I'm not sure yet. I may regret this choice. That is the moral of the story. I think I'm going to immediately realize that I should be coloring for odd and even instead once I see Barbie's comment. Because I think Barbie's comment is the correct one. So there are 3 digits that can never go on a black dot, which is very interesting because there are 3 places in this box that are not on a black dot. So these are immediately a 5, 7, and a 9. Okay. And so now I'm going to switch tack completely, and I'm going to color that these digits are odd. And so that means these digits are even, certainly. Now, this can't possibly be a 9, because then I'd have to put 8 on both sides, so that's not going to work. Let's see. Do either of these rule themselves out somehow? I don't think there's anything wrong with saying I'm going to put a 4 on either side of this. So definitely, here's a thing I can say. One of these is a 6. Whether this is a 5 or a 7, one of them's a 6, which means one of these is a 3, which means this isn't a 3, so that's not a 2. This isn't a 3, so that's not a 2. Now, I also know that if I have to go the whole way, that is, if I have to make 3 different Kropke dots, one of them has to be a 1-2 pair. And neither of these can be the 1-2 pair. And that's because really there's 2 different chains of Kropke dots. There's the short chain, which is 3 and 6, and then there's the long chain, which is 1, 2, 4, 8. And if I want to make 3 total pairs, I have to pick adjacent things on the chains, and so one of them is 3, 6. But then the only way to split up 1, 2, 4, and 8 is as 1, 2, and 4, 8. If I try and pick a 2, 4 in the middle, I isolate a 1 and an 8, and then they fall apart. So this has to be the 1, 2, because neither of these digits can possibly ever be 1 or 2. So this is a 1, 2 pair. So that's not a 4. This isn't a 1. Okay, so this is interesting. So now this 1, 2 pair is looking at this x. So this x is now either a 3, 7 or a 4, 6. Can I rule one of those out? Let's see. If this is a 1... No. It's going to complement with that one, though. But that's okay. See, now I kind of want to go back to high-low coloring again, because I'm seeing now I have 3 lows in the column, and that's the 4th low, so this digit has to be high. So I'm going to make my coloring based on that. So I have a virtual 1, 2, 3, 4 quadruple. That is to say, 1 and 2 are already here. This is 1 of 3 and 4. The other 3 and 4 is here, so this digit here is at least 5. And so that does put pressure on this dot, because this dot can't be a 3 anymore. So that dot can't be a 7. Oh, yeah, I wasn't thinking about the fact that BremSter was in Australia, so this is like the worst possible time. Sorry, BremSter. Okay. So... yeah, and so this certainly can't be 9, because this can only be 4, 6, or 7. So this could be a 5, if that's a 4, a 5 if that's a 6, a 6 if that's a 7 if that's a 6, and 8 if that's a 7. Let's see, okay. Intriguing. Top of column 5 is an 8-9 pair. Ah, yes, that is an excellent point by Barbie. Where does 9 go in column 5? Well, I've just ruled it out of everywhere except here. So this is an 8-9 pair. That is a beautiful spot. So that's not an 8. It does not tell me anything more about this, but that's cool. Okay. So one of these is a 3. Let's see. If this was the 3, yeah, that would do something. Okay. Okay, so Naverio is claiming this has to be the 9. Let's see if we can understand why that is the case. Because where else am I putting a 9 in row 1? Well, I'm certainly not putting a 9 on a white dot if I make this an 8. So the thing we have to convince ourselves is if I make this an 8, it becomes impossible to place a 9. So if I make this an 8, I can't put a 9 on a white dot because 9 can only go on a white dot with an 8. And so I also certainly am not putting a 9 on a black dot. So I agree. Yes, this has to be the 9. That is a nice spot. That was not clear to me. Yes. So now it is pointed out to me by Apple Tree that the 5 in row 1 can only be in one of these two places. Welcome, Pause. Merry Christmas. Happy to have you here. So we've got a 5 here, which means... so we've got a 5 here. So one of these is a 4 or a 6, which means the other side of that x is also a 4 or a 6, which means neither of these are ever 4. Okay, this is really beautiful setting. So we can say that. So we know the 4-6 pair goes on one of these. We don't know which one. And so, yeah, so one of these is then forced to be a 2 or a 3 based on whether the 4 is on this side or the 4 is on this side. Okay, across. Oh, yeah. Okay, so now Andrew, by the way, welcome, Andrew. I'm not sure if I've seen you here before, but Andrew has a parity point, which is that every white dot, I'm going to just erase this coloring, by the way, until I decide which coloring I want, if any. But across row 5, every white dot contains 1 odd and 1 even. So in total, across those, I have highlighted 4 odds and 4 evens. But there are in total 5 odds and 4 evens, so this digit has to be odd. So it's a 1 and that's a 2, which makes that a 3. Which gives us more digits. Okay, so that being a 3 looks down here and says that this isn't a 3-7 anymore. So this is a 4-6. And so that's not a 6, it's a 5 or a 7. Okay, that is neat. So we've got more stuff going on. So yeah, and so remember, one of these is a 3-6. And one of them is a 4-8. But we don't know which way up the 4-8 is. At least as of yet, I do not know. Maybe you know. Hey, Andrew. There are 2 Andrews today. Very exciting. So we can play high-low games with row 9, because this is low, that's low. Every X has a low digit, so these are all high. So that's actually playing the game the other way. So we get to play both odd-even logic and high-low logic here. So these are from 5, 6, 7, 8, 9. And of course, they're not 6 because there's already a 6 in the box. So since the dot cannot be 4-3 anymore. Oh, okay, yes. So Naverio is looking at row 5 and thinking, could this possibly be 4 linking to 3? And the answer is it can't be 4 linking to 3, because if it was 4 linking to 3, then what would happen, then I would need to place a 2 somewhere in this row, which is going to provide a huge problem because there's nowhere to place a 2. So this can't be the 4 anymore. This is a 1 or a 2. And so that's a 3 or a 4. Also, here's another fun fact. There's already a 1 in this row, so this isn't a 1 either. So it's a 2 or a 2, and this is a 3 or a 3. Let's see. Okay, now I'm being encouraged to read what Barbie said, but what Barbie said... Oh, Barbie says, where's 2 in row 5? Let's see. No, that's not row 5. Oh, we have placed 2 in row 5 now. So this is... Oh, this just has to be a 3 now. So that's the 3, that's the 6. This is a 4-8 pair. Let's see. Is it obvious which way this goes? Now, this could go 6-5-4, or this could go 6-7-8. I think both of those are still legitimate as far as I can see. Now, the 2 and 3 are pushed into this pair because I have 2s and 3s both getting pushed into this box in this row, but they can't go there because there's already a 2 and 3 in the column. So this is a 2-3 pair, which means that this X here can only be either 1, 9 or 2, 8. Well, this certainly can't be 1 or 2. And in fact, actually, the only digit this can possibly be that could go on a white dot with one of those digits is a 9. So that's a 9, that's an 8, that's a 4, that's a 5, that's a 1. And so these aren't 5 anymore. Okay, so we're making good progress. Okay, so these are a 4-5 pair and a 6-7 pair. I don't yet think I know the order, although I know neither of these is a 4. And the 4 goes with a 5, so neither of these is a 5. The 4 goes with a 5 because I have to have these things working. Hey, BremSter, welcome. Glad you could make it. Sorry I did not think of not doing this at a time when it was in the middle of the night for you. So apologies, but I'm very much enjoying the puzzle, and there will be a VOD if you want to go back and watch the original piece. Okay, so 1 in this row can't go here, so the 1's over here somewhere. In fact, the 1 has to be here in one of those two cells. If I go ahead and write in what these digits are, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that one's not a 9 either. It's not the 1, so this is a 7 or an 8. Interesting. Okay, this one's not a 1 either. Same reason. Okay. So, okay, I may have over pencil marked this, but to make up for that, I'm going to pencil mark this row. 1, 2, 3, 4, 5, 6, 8. Okay. So can I do stuff with this row? Because I was productive looking at stuff at the top row. Oh, here's the thing. This isn't a 5. This is a 7. Just because that. That makes my life much easier. Because this is a 7, that's a 6, that's a 4. These aren't 7 anymore. I'm sure chat will be happy to tell me that I could have seen that a while ago, which I'm certain is true. So now where is the 3 in this row? Well, now the 3 in this row can't be on an X. So the 3 is in one of these two places, where it's joined by a 6. So one of these two cells is a 6. One of these two cells is a 4. So we're going to get a 4, 6 on one of these X's. And that means that neither of these is 4 either. And so neither of these is 1. So we have our same pattern, but for a very different reason, which I adore. For a very different reason, but the same conclusion, we can't have a 4 in either of these cells, just like we couldn't have a 4 in either of these cells. Okay, so... well, this can't be an 8 because it's got an 8 above it. That is my profound statement of the day. This can't be a 6, so this is either a 4 or an 8. Those are the only possibilities for this cell based on that dot. Let's see, this being an 8 means, again, this can't be a 6 because the 6 has to go with a 3. So this is either, no, sorry, it's either a 4, it's not a 7, so it could be an 8, or it could be a 9. Okay, so this cell here is a 6 or a 2. And this cell here is a 6. or a 1 or a 2. Okay. So, pointed out by Naverio, there's an X-wing on 1s in columns 1 and 9. The only place 1 can go in column 1 is in those two cells. The only place a 1 can go in column 9 is in those two cells. And so if you haven't seen how this works before, I'll go ahead and highlight this. So the only places 1 can go in these two columns are there and there. But that means that I either have to place them like that or like this. And in particular, that means there's never a 1 anywhere in these cells, and there's never a 1 anywhere in these cells. Because no matter how I arrange this, I end up I end up needing to use a 1 in one of these two cells. And so the punchline of all of this is that this cell's not a 1, so this cell's not a 9, so this cell's not an 8. Oops. And so that actually lets me disambiguate everything going on down here. So the basic way that works is that information about restrictions in the columns gives you information about the rows. So this isn't a 2 anymore. So that's not a 3 anymore. And so I don't think I know which side yet, but I do know that one of these is a 1 linking to a 2, linking to an 8, linking to a 9. And one of these is a 3 linking to a 6, linking to a 4, linking to a 5. Okay. I do love when people do that with my puzzles, BremSter. When someone finds something in one of my puzzles that I didn't intend. Sorry, I shook the camera again. Apologies. Something in my puzzles that I didn't intend. And I'm like, oh, wow, that's really cool. There was an... Yeah, I did. I used it to eliminate 1 from this cell, which got me a whole bunch of stuff, didn't it? Wasn't that the whole point? Did you have something else in mind other than eliminating 1 from this cell? But I eliminated 1 from this cell and 9 from this cell, and so now we've got our 5-9 pair here, and so I can write down what these digits are, which is probably a good idea. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these aren't 8. These aren't 3. Let's see. Let me read the comment again. Okay. So the follow-up of that is because one of these is a 1 in each column and row. Wait, I'm reprocessing this. Oh, yes. One of these is a 1. Okay, got it. So one of these is a 1 in each column. So again, one of these two is a 1. So one of these two is a 2. Likewise, one of these two is a 1. So one of these two is a 2. And so in the columns, I again have to have a 2 here. I guess this isn't even really necessarily an X-wing, but one of those two is a 1. So one of these two is a 2. So the whole point is this isn't a 2. So this is a 3 and that's a 2. I think that was the desired conclusion. Now, we also have the same thing going on with 4s, where because one of these is a 1, one of these is a 4 in each column / row. And so that's going to eliminate a 4 from there. Oops. And a 4 from there. So we get some more joy out of that. now I hear tell of a 2-4 pair. Ah, yes, there's just an outright 2-4 pair here, Ranks points out. So that knocks out 2 from both of those. So that is a plus. And something about a 4 in box 2. That sounds exciting. So yeah, so the 4 in box 2, because of the X-wing, the 4 can't go here. So the 4 has to go here or here. But the 4 can't go up here. I'll remind you why in a second. I'm going to write the 4 in here. This can't be a 4 because these two X's, one of them is a 4-6. So that puts a 4 down here, which is excellent. So let's see. I'm hearing these are a 1-3 pair, but I'm not sure I see why there can't be a 2 here. So if there were a 2, it would go 2, 4, 6, 5. Ah, it's because I can't possibly put a 3-7 on one of these X's. I think that's the point. So if I wanted to put a 3-7 on one of these dots, what would I do? Well, I can't put the 3 here because 3 doesn't black dot any of these digits. But I can't put a 3 here because 7 doesn't black dot any of these digits. So yeah, the question I should have asked for a long time is where does 3 go in this row? And so 3 has to either go in one of these two places, but it doesn't. And so 3 now has to go in one of these two places. But we also know that 1 has to go in one of these two places by our previous observation that I can't put a 1. Wait, do I know I have to put a... Yes, by our X-wing on 1's argument. We know one of these two has to be a 1. So that means I need both a 1 and a 3 in these two cells. Tricksy. And so that means this is not a 3. That's a 2-4 pair. So there's another 2-4 pair. Where was the asymmetry in... Oh, the asymmetry is between the X's and V's. There. Okay. So that is very nice. Okay, so the 2 in this box is not in one of those cells. Okay, neither of these dots can possibly be a 2. If this is a 2, I have to put a 1 or a 3 on the white dot, and I definitely can't do that because there's a 1-3 pair in the row, which is way simpler than the convoluted explanation you were about to get about why you can't put a 2 on one of these dots. And so this is the 2. So appreciate that I saw that before you had to listen to my complicated explanation, which resolves box 8. So that is now an 8, and that is now a 2, which is exciting. So what's left in this box? We need a 1, a 5, a 7, and a 6. The 6 doesn't go up here, and the 1 doesn't go up there, so that's a 5-7 pair. So these aren't 5 or 7, they're a 1-6 pair. And it's resolved by that 6 down there, so that's a 1, that's a 6. Like that. And so what are the digits they look at? They look at a 4 and an 8. I don't know in what order yet. And so those go with a 6 and a 4. No, a 6 and a 2. 6 and a 2. Okay. And now that gives me some pairs here. So there's a 4-8 pair, so that's not an 8 anymore. Here's a 2, 6 pair, so neither of these is a 6. Here's a 2, 6 pair, so none of these are 6s. Now that's going to impact the white Kropke dot a bit, because in this row, remember, this is the row where everything is Kropke'd except the 1. So we have a 2, 3 on white Kropke dots, we have a 4, 5 on white Kropke dots, and we have a 6, 7 on white Kropke dots. So as soon as these can't be 6, these can't be 7 anymore. So we've got a 5, 6 pair and a 4, 7 pair in the row to sort of indicate that. Let's see. So all kinds of things happening. And yes, BremSter, this is a very cool puzzle. I am enjoying it. Sorry, I'm adjusting my desk slightly. There we go. I didn't destroy the camera or anything. No, I did not. Okay. So, 1, 2, 3, 4, 5, 6, 7. That's not a 3. That's not a 6. That's not a 6. One of those is a 6, but I don't know which one. Let's see. What else can we do for joy? Let's look at the rest of this row. Maybe? That doesn't sound promising, I've got to admit. Yeah, we'll replace the desk with one that less shakes, because I am not a very still creature by nature. It is not how zetas tend to work. I am now being perplexed. I want to fill in pencil marks, but I'm a little concerned that I'm going to like really over pencil mark this, but I've never worried about that before, so let's just go at it. 5, 7, 9. Okay, that's not a 3. I can at least go that far. That's not a 3 either. Could be a 3, unfortunately. The 3 in the row goes one of those two places. Yeah, that's going to just have scadzillion options. So I'm not going to try and pencil mark that. That's also going to have scadzillions of options. So I'm not going to pencil mark that. Okay, what am I missing? Yeah, the 3 and the 2 are both pushed into this area. So let's think about this. So one version is that this is a 3, this is a 6, that's a 4, and this is a 2. The other version is that this is a 1, this is a 2, this is a 4. And so in this version, this would end up being a 3. Yeah, so if this is a 1, this goes 1, 4, 2, 8, and then that has to be a 3. But it doesn't work the same way over here, because over on this side, if this is a 1, we have a 1, 4, 2, 8. But now this can't be a 3. And so this would end up being the 3, I suppose. So yeah, so I'm going to pencil mark this somewhat weirdly. I don't know that this is useful, but in that box, one of those two is a 3, and in this box, one of those two is a 3. let's see, row 4, column 2 cannot be a 5. If it was, Naverio says, you would have no place for 4s in those boxes. Yes. Okay, so there's 2 places for 4s in this box. But if I make that a 5, then this becomes a 6 and that becomes a 7. Because remember, the 6 and 7 are friends in this puzzle. So that actually forces that neither of these can be a 5, which is beautiful. That is a great spot, Naverio, and great constructing. So that gives us a 4-8 pair across the row, which tells us those aren't 8. So that gives us some 5-6 pairs down the columns. Yeah, that was a great spot. You all spoil me when I am solving with you. Let's see. So now I can go ahead and fill in these 2 digits. Or sorry, these are from 7, 8, 9 now, right? 1, 2, 3, 4, 5, 6. Yep, these are from 7, 8, 9. So that definitely has an 8 on it, because there's no way to make this dot with only a 7 and a 9. So that's not an 8. And likewise over here, these are from 7, 8, 9. And again, one of these has to be an 8. And so that's not an 8. And so now I've got a 7, 9 pair in the row. So that's not a 7. This is a lot to this puzzle, actually, for a puzzle that has so many clues, especially so many V's. There's a lot of different steps to this puzzle, at least the way we have been doing it. Okay, so this row now, because of this new 7, 9 pair that we've gotten, is now 1, 2, 3, 4, 5, 6, 8. Okay, that was more options than I was expecting, but it shouldn't have been more options than I was expecting, because I should be able to count, but I didn't. Okay. Yep, so the same thing happens in column 9. We got the 7, 9 pair, which we were excited about. At least I was excited. Let's see, are we getting 7, 8, 9 triples or anything like that? I don't think so. Yes, I can't have a 6 in column 8 or in column 2 because of the 2, 6 pair. That is a good catch. So one of these 2 is a 6. Let's see. 7 or an 8. 7 or an 8. Time for more tea. That will help. Same logic on column 3 and 8. There's a 4, 8 pair, so that's not an 8. There's a 4, 8 pair, so okay, that doesn't do me anything there, but that's now down to 1. Oops. Now down to 1, 5, or 6. Okay, so Carl is observing that row 3, column 2 can't be a 1 or an 8. Okay, so let's see. So the claim is that this breaks the V and X. So let's remember the options. This is either 4, 6, 3, 2, or 8, 2, 1, 4. So I don't think it immediately breaks from one of those. Let's see. We definitely need to use a 2, and we definitely need to use a 4 in order to make all of this work. Let's see. Where else are things happening? Let's see. I really liked this logic down here in these boxes. That was very clever. Okay. So that's beautiful. Okay, so ranks nails it. So one of these is an 8, 2, 1. Whichever one it is, I don't know which one, but whichever one it is, it rules out both 1 and 8 from its cell. And so one of the two yellow cells is a 5. And so that's going to give me digits, because that's now got to be a 6. This now can't be a 5 or a 6, so it's a 1. So these are now a 5-8 pair. So that's going to do lots of stuff. So that's going to place the 1 here. Yeah, that was a beautiful construction and beautiful spot, Ransk. So yeah, that's going to just blow open everything, I think. So that's a 1. This 6 rules a 6 out of there. Let's see. That's a 7 or a 9. That's a 7, 8, 9. 7 or 9. That's a 7, 8, 9. Okay, and so now the claim is that we've now disambiguated row 1. Oh, yes. We have disambiguated row 1 because I placed... Oh, I guess both the 1 and the 6 here I should have looked at are disambiguating whichever one you want to look at. So this is a 2, that's a 1, that's a 4, that's an 8, that's a 7, that's a 5, that's a 4, 6, 3, 2. So yes, that did quite a lot of work. So that 8 has made that a 5, made that an 8. So this is not a 3 anymore. This is just a 5, 7, 9 triple. This is not a 5. That's not a 5 anymore. This is a 3, 7. Oops, I highlighted. How did I highlight down there? I don't know. These aren't 5 anymore. Okay, and so now the bottom corners are getting fixed by that. So that's 4, 1, 2, 8, 9. That's not a 9. That's a 9. That's a 5. That's a 4. That's a 6. That's a 3. That's a 2. Just whoosh across everything. Okay, so let's fill in the rest of this. Okay, so let's fill in this column. Oh, no, we're not going to fill in the column. We're going to fill in that this 8 gave me, that's a 4, so that's an 8. This being a 4 tells me that's a 7, so that's a 6. No. Yeah, so that's a 4, so that's a 5, that's a 6. That's a 5, that's a 9, that's an 8. That's a 7, that's an 8. So that's a 9. No, I don't know if it's a 7 or a 9 as of yet. So it's not an 8, though. I know that much. So that 7 looks up and sees that that's not a 7. That 9 looks up and sees that that's not a 9. Let's see, that 7 looks up and sees that that's a 9. There we go. So that's a 7. That's a 3. That's a 5. That's a 9. That's a 7. That is a 9. I was right, apparently. For the completely wrong reasons, but never mind. I was right. That's what matters, right? So now we can look down here. These aren't 3 anymore. And we can write in the options for the column, which are a 1 and a 9. And so now this is going to unfold everything because that 9 sees that's 1, that's a 9, it's a 3, that's a 1. Let's see, 1, 2. Let's see, we need a 3, which is going to have to go there. No, we don't need a 3. That was a lie. We need a 6, which is going to have to go here, and a 7, which is going to have to go there. 2, 3, 2, 3, 4, and a 5. Very nice puzzle. Very satisfying to solve. Alrighty. I am again going to take just a quick break before the next one, but I will be right back. So don't go anywhere. Be back in just a moment. Alrighty, welcome back. Although again, I guess I'm welcoming myself back. Alright, so next up we have something that's going to be something. I think overall my favorite constructor is 2totenth, and so I've done almost all of 2totenth's puzzles. But it has been pointed out before that I have not done the puzzle Carousel. Now, this puzzle is meant to be capital H hard, and in fairness to twototenth, I believe his comment was that he did not, strictly speaking, recommend this puzzle. But I feel weird for there to be like one puzzle by twototenth that I haven't done. Plus, I'm planning to stream forever today anyway, so I figured this was a good chance to knock this off of my to-do list. And I know I'll have many audience members who will be happy to tell me how you're supposed to do this puzzle. So let's try it and see if we can survive. Okay, so there are a few standard rules here. I'm just skimming real quickly to make sure there's not an anti-night constraint. I don't think there's an anti-night constraint, but I'm a little far away from my screen, so if there is, well, we're going to have more fun. So these killer cages just tell you the sum of these digits is 15. The sum of these digits is 15. The sum of these digits is 10. So if you liked the last puzzle, you can imagine there's an X here between these two. The diagonal clues, these are called little killer clues. And they're called little killer clues because they're, I don't know, littler versions of killer cages, which are called killer cages because people thought killer puzzles were difficult or something. The etymology here is incredibly confusing and oddly violent for a game about putting numbers into a grid. But what this is saying is that the sum of all of these digits is 57, which is also known as a lot. The sum of these digits is 20. Okay. Is there a magic square in box 5? I don't think so. So anyway, lots of opportunities for this. Yes, technically possible that there is a Latin, or sorry, not a Latin square. There's not going to be a Latin square in box 9. Very possible that there will be a magic square here. Who knows? Also of note, I didn't actually say what these blue lines mean. The blue lines are diagonals, which are effectively extra regions. So this diagonal contains all of the digits 1 through 9 once each, and the same is true of this diagonal. Yes, Sam, to answer your question, F-Puzzles does consume sometimes a ridiculous amount of processing power. However, Ranks, who may be in the chat, has a little thing you can install that will completely fix that, and then it won't do it anymore. So there we go. And so now we're forced, I suppose, to get started. The first thing I note, and I think Barbie also is noting this, is that these two cells sum to 10. Sure, you can have a bet cell. Let's bet on that cell. You can come back in 4 hours and see if you won the bet. Let's see. So a thing that is often helpful on these puzzles is to highlight all of the cells that are on a little killer clue. So we can highlight those, and those, and these, and these, and these. Oh, and these two. I missed that one. Does that look like anything to anyone? It doesn't really look like anything to me, but it looks like I maybe want to also throw in the diagonal here and here. Okay, so the thing I notice is that we've covered almost everything in boxes 1, 3, 7, and 9. Okay, so I'm kind of inclined to only think for a second about one of these colors and not both. So I think I want to try and think just about yellow for a minute, and I'm not going to think about this yellow line either. I'm going to just forget about that one, and I'm going to think about this yellow line. And our bet cell, I'm going to stop. Oops. Ah! That's not what I wanted to do. There we go. Sorry, apologies if I just did something absolutely insane with the camera. I accidentally hit a button that made things full screen when I was trying to enable the pen tool. I'm going to circle the bet cell just so that we can remember what it is, but I'm going to stop coloring it because I suspect there's going to be a lot of color floating around for whatever reason. Okay, so the total sum here. Oh, hey, twototenth, welcome, welcome. So the total sum of all the yellow, let's do this, and I'm going to type this in chat just so that you can have it in front of you where you can see it and so that I can refer to it. As I try and figure out how to set up my chair so that I can do this, because I'm not usually typing. Total yellow is 22 plus 27 plus 45. And what is 22 plus 27 plus 45, you ask? That is a very good question. So I believe that is 94, if I did that correctly. I think it's 94. Yep. Now, on the other hand, if I were to add in these cells, which I'm going to make blue, then now it would sum to 45 times... oh, no, crap. Now it would be... I didn't notice these two things were hanging out. So I'm going to also put a flash through these to indicate we have to think about these. So now I want to note that I can calculate yellow plus blue. Yellow plus blue minus purple is just 3 times 45. And 3 times 45 is 135. And so the reason why this is interesting, well, actually, I have no idea if it's at all interesting, but the reason why I'm hoping this is interesting is that this means that blue minus pink is, let's see, so it is 135 minus 94. Which is 41. Okay. So the value of these cells minus the value in the pink cells is 41. Now, that seems high, but let's see. Okay, so the maximum that blue could be is what? The maximum that blue can be is 3 times 17, because I could put an 8-9 pair in each of these cells. And so the maximum for blue, oops, sorry, trying to type this in chat again. The blue max is 3 times 17, which is 51. Thank you, Imfurio, for keeping up with this and for double checking my math, because I do not want to do that. The circle is the bet cell, so people are guessing what value this cell is going to have. I attempted to choose a cell that would be decided very late in the puzzle, and seem to have done that absolutely terribly, because I think we're going to know what this cell is down to 2 candidates very shortly. Hey, Calzone, welcome. So two things are going on that are interesting. First of all, chat is pointing out that actually the diagonal breaks if I make all of these 8-9 pairs, which is interesting. So 51 is actually not the maximum for blue. Blue's maximum is lower than that. So that's interesting. But something else I'm noticing is I want to think about what the minimum that pink can be is. So the minimum that pink can be at first seems to be 4, because there's no reason in regular Sudoku why I couldn't make all of these digits a 1. Oops. But there is a reason I can't make all of them 1 now, which is that then I've locked 1 completely out of box 5. So at the very least, I need to make one of them a 2. Will that fix it for me? Yeah, so yes, that would fix it for me. That would give me a place to put a 1. Okay, so the minimum for yellow is 5. Okay. So now, if you believed everything I had said so far, you would be very disappointed, as admittedly I was, when you looked at this and saw that if you took the maximum for blue, which is 51, and subtracted the minimum for yellow, then you would get 46. Whereas blue minus pink is 41. But hopefully we can fix that with chat's observation. I'm trying to figure out how to make my ROM rest go back. There we go. With chat's observation / the setter's observation, that I can't actually make all of these 8-9 pairs. And so the reason why is I can only have 2 9s and 2 8s across these, because if I put 3 9s, I lop all of them off the diagonal. So actually, the actual minimum for blue is actually 2 times 24, so 2 times 7 plus 8 plus 9, which is 48. So I did that right? Okay, so blue is at minimum 48. And then yellow is at minimum 5. And so 48 minus 5 is still not 41. So there's 2 degrees of freedom that need to be disappeared somewhere that I have not yet seen, I think, if I'm doing this right. 48 would lock 8 off of the diagonal. Didn't I use 2 7s, 2 8s, and 2 9s? So I'm doing something like, let's see, we're going to use the keyboard one of these today. See how that goes. I was thinking something like, something like 7, 8, 7, 9, 8, 9. So I could put an 8 in one of those two cells. Now, it doesn't tell us literally nothing. But that being off by 2 is concerning. So I must be missing something, and I'm not sure if the thing I'm missing has to do with the effect of these pink cells, or if it has to do with the effect of combining this with the other diagonal at the same time, which is a terrifying, terrifying thought, that I'm going to have to do all of this again for the other diagonal and then put them together. But let's see. But I don't see anything wrong with what I have here in terms of obvious stuff. Oh, okay. No, it I think it is going to require the other diagonal, because notice what's happened. By looking at this diagonal, we've pushed these 2 digits up. So this diagonal is too small, and so we've pushed these digits up. When I do this for this other diagonal... Oh, no, never mind. Sorry, I was getting excited because I was thinking we were going to push these digits down. Actually, that is interesting, because now these digits... Okay, yeah, we're going to have to do this for the other diagonal. There's no way around it. So, buckle up. So we've got... Oh, sorry to hear you're not feeling well, Ranks. I hope you feel better soon. So now we're going to have to look at this for the other direction. Okay, so we're going to use lots of colors. But this is... So I think if I draw this in, I think I can explain why I think looking at these two simultaneously is going to be helpful, if painful. Hopefully I still have Infurio standing by to do the calculators. Okay, so got a bunch of green cells now. And now, just like before, the green cells are just short of getting where we want to go. So we've got... let's see. Okay, so now... green is a total of 57 plus 45 plus 54, which is a lot. So 57 plus 45 is... let's see, 156? I'm hearing 156. I'm willing to believe 156. Let's see. I'm hearing 156 from multiple places. So green totals 156. But green plus orange minus black totals what? It still totals 45 times 3. Exactly the same as it did the other way, which is 135. Helpful if painful. That is a good goal to aspire to. Okay, so So yes, so green plus orange minus black is 135, and so I can use those two to say that orange minus black is what? Orange minus black is 156 minus 135, which is 21. Okay, so orange minus black is 21. Okay, so I'm going to write these down. You have them in chat, but I'm going to write these down again. So the things I had before were blue minus pink is 41. And now we also have orange minus black is 21. Okay. And I think, actually, for purposes of this discussion, I think I can unhighlight yellow and unhighlight green, because I don't think this is really about the yellow and the green. Oh, am I shaking the camera? Oh, whenever I'm writing, I shake the camera. Sorry about that. I will try to minimize the writing. Sorry about that. Oh, it's black minus orange. Ah, yes, black minus orange, sorry. Well, we'll get a new desk soon. Black minus orange is 21. Thank you. That was going to be a disaster. Okay. The 1s and 2s are just placeholders because I was trying to figure out how the maximums and minimums played with each other here. Yeah, so the... sorry, let's see. I can probably write this on a book. Okay, so the... Then I won't have to always have a handy number theory textbook. That way you won't shake the desk when you write. That is helpful life advice that we can all live by. Yeah, the purple digits were just me trying to figure out what the maximum / minimums were for these things. Okay, so let's repeat. The minimum blue was 2 times 7, 8, 9, which totaled 48. And so now we need to actually figure out, I think, the maximum... Sorry. That was the maximum blue, not the minimum blue, sorry. So now what do we want with orange? Because the whole orange minus black is 21 thing doesn't actually... Okay, so it's black minus orange. I need to, keep repeating that it's black minus orange and not orange minus black. You're far from the first person to comment on it, Elvira, so I have been intending to do it for a bit since I figured out this. Oh, congrats, Riff Clown. Great to have a debut. Okay, so I'm trying to figure out, why was it asymmetric? Why was it blue minus pink, but it's black minus orange? Oh, because it's negative. Okay, gotcha. Okay, I'm with you now. Okay. So yes, so now, when I go to try and have black minus orange, what's the biggest black minus orange could be? So the absolute biggest... Yeah, so black could do the same thing, but with high numbers. So black could do, and this is again, this is again just hypothecation. Black could do this. With 9, 9, 9, and then place a 9 there. So black max is theoretically the black max is again theoretically going to be 27 plus 8 is 35. And the orange min is ostensibly going to be 2 of each, 1, 2, and 3. For the same reason that I could not repeat for the same reason I could not do 9, 9, 8, or whatever in orange. For the same reason I couldn't have 3 9s in orange. Sorry. For the same reason I couldn't have 3 9s in blue. I can't have 3 1s, 3 2s, or 3 3s in orange. So the orange min is 2 times 1, 2, 3, which is 12. But, as is being pointed out in chat, and as is the reason why we did this, we have a problem. And here is the part where this gets interesting / complicated. Okay. Oops, sorry, I did not mean to shake the mic. So if I want to minimize orange, I need to take these digits to be small. But if I want to maximize the blue stuff, or if I want to maximize blue minus pink, I have to take these digits to be small. And so they're going to screw with each other in an interesting way. And so we have to somehow tease out how these two things interact with each other. Okay, so let's summarize again. So I have not written on here my pink min. So the pink min is ostensibly 5. And the so the pink min is ostensibly 5, and the blue max is ostensibly I already have that. That's ostensibly 48. Okay. So here's the problem. So if I look at the blue max minus the pink min, that will give me 43. Okay. 43 is 2 more than 41. 41 being what I actually need blue minus pink to be. So there's a little bit of wiggle room. The wiggle room accounts for a total of 2, so I'm allowed to put up to 2 more in pink, or up to 2 less in blue. So I could, for example, make this a 4, but if I make this a 4, I've eaten every degree of freedom and have to do everything else exactly like the minimum in blue. When I do the same for black, I take the black max minus the orange min, and so the black max minus the orange min is 35 minus 21, which is, 35 minus 12, which is 23. And again, I see that there's 2 degrees of freedom on black. Or sorry, on black and orange. Okay. So we have to figure out some way to concisely express what's going on here that lets us nail down the fact that these 2 things interact in this really unpleasant way, involving what these are doing to this. So here's one observation. Yeah, so the... Woohoo! Yeah, so the... So yeah, I think Inferio is right that we should actually be aiming now, instead of looking at blue minus pink and black minus orange, we should actually be looking at, and I see that T also suggests this, blue plus black minus blue plus black minus pink plus orange. Which is supposed to be 62. Okay, so blue plus black minus pink plus orange is 62. And so now I'm going to redo all of this, but I'm going to merge blue and black into one color. So these are now going to be green. And these, oops, not that, are going to be yellow. No, did I have a yellow? No, I never had a yellow. No, I did not have a yellow. Okay, so these can be yellow. Oh. Okay, and so now our statement is that we're supposed to have green minus yellow is 62. So green minus yellow is 62. And that has to be, hopefully, a way to eat up all of our degrees of freedom. So now we have to do all of our calculations again with these colors. So, oops. Okay, so yeah, so green minus yellow is 62. That is the point. And I think we can separately handle green and yellow without any interaction between them, hopefully, fingers crossed. And if we can do that, then hopefully it'll work out to have to work out how we want it to. When my loving husband has brought me tea to support me through this endeavor of solving this puzzle, which I very much appreciate. Let's see. Okay, so so how are we supposed to... I really wish I'd solved, by the way, I wish I'd solved read between the lines before watching Simon do it, but I had it in my queue. It would have been like the first puzzle or one of the first puzzles I had done yesterday, but Simon beat me to it. Uh, let's see. The tall cat puzzle that really got me was Doppel. That involved lots of minimizing and maximizing and aha moments and all of these sorts of things. Okay, so now I have to keep repeating myself. Green is the one I want to make big. How big can I make green? If I just want to make these digits sum to a number that's as large as possible, what can I do? Well, see, I do puzzles on stream that I don't think I'm smart enough for, and then chat does them for me. And then people tell me what a nice solve it was afterwards. Is the stream cutting in and out? Let's see. I think I can see. It does not tell me I'm dropping frames, so I don't think it is, based on what my OBS is telling me, but I don't promise that it's not. Okay, so it's these here. Okay, so I could make those and those each 8, 9 pairs. But then that would force 8 and 9 to be on the diagonal in this box, which is a disaster. Because I certainly don't want either of these things to be 8 or 9. My hope that these would be separate and not entangled is really not going well, because I now think it does matter, because I want to only keep small digits in yellow and only big digits in green. But I am not yet. It's because I'm. So any digit that shows up on both of these two sets appears in yellow. So if, for example, I put a 9 in these two, I then have to put a 9 in yellow. And that seems like a problem. I don't think I can possibly put a 9 in yellow. Because if you look at our previous version of this, when we had this all colored up before, we only actually had 2 degrees of freedom over making these things the bare minimum they could be, which means we could never get any digit bigger than 5 into these cells. And because we can't get any digit bigger than 5 into these cells, that means I can't repeat a digit bigger than 5 in here. So these are at absolute maximum 6, 7, 8, 9. Yep. So exactly as Infurio says, because of the way this worked out before, and I kind of wish I had 2 side-by-side versions of this, where I had one colored the one way and one colored the other. But because of the way our degrees of freedom worked out before, we exactly cannot have a 6, 7, 8, or 9 here. So these are actually, we know they're from 1, 2, 3, 4. Okay. By the exact same logic, these have to be from 1, 2, 3, 4, because, again, we only had 2 degrees of freedom over making those the maximum, and so we can't force there to be a 1, 2, 3, 4 in green. That will break green. Okay. So, part of the way there. So these greens are now those. So now Welcome back, Naverio. So I'm now thinking about, is there a reason why these can't be 8, 9? And I don't think there's a reason these can't be 8, 9. So I think... So to answer your question likewise, I think so, but we're now counting degrees of freedom on a different thing. So I haven't yet reached the point where I can actually count the degrees of freedom. But I don't think I can do better than making that an 8 and that a 9, and then this a 7, 8 pair, and this a 7, 9 pair. I think that's going to be the maximum that I can make a green. And so if I try and do the same thing to minimize this, I'll put a 1 here, a 2 here. I'll put a 2, 3 pair here. I'll put a 1, 3 pair here. I think this is now the maximum and the minimum, and so let's see how this works out. So 6, 7, 8, 9 is 30. Yeah, okay. So the point is, I can have it... I just want these to be 6, 7, 8, 9 triples. Okay. So... And whatever way I make these 7, 8, 9 triples definitely maximizes this. I think that is a good way to think about this. Okay, so let's count. So this is saying green is, with this, the green max, provided we've really maximized this. Yeah, and these can also be in any order, as was pointed out. It doesn't change the math where they put them. So this says that green max, couldn't they be 8, 9, 9? Let's see, if this was an 8, 9, 9. Don't think this is right. I think it's possible that what chat is saying is correct, that maybe I actually could have I actually maybe could do better here. And if Inferio's correct statement is correct, I have to do better than this, because at the moment, green totals 78. I'll let chat confirm that. And yellow totals 22. And 78 minus 22 is 50-something, which is not 62. So this is definitely not the right arrangement. Because green minus yellow has to total 62, and currently green minus yellow is too small. So we have to do better in this combination. Okay, so I think the way to do this is to ask ourselves, how many 9s can I possibly put in green? And the answer is, I can't possibly put 3 9s in green. Right? Can I possibly put 3 9s in green? Oh, maybe that's okay. Maybe I can put 3 9s in green. Okay, I think I can do 3 9s and 3 8s. I think I could do that. I can't put 4 9s, no matter how I try. But I can put 3 9s and 3 8s. So I think this is actually it. I think it's... I think it's that arrangement. What's the difference there? Let's see. So 30 plus 27 is 57 plus 24 is 91. Let's see. Sorry, I can't do this in my head. Let's see. So this is saying green max is, okay, so that is 30 plus 24 plus 27. Let's see. So that would be 92. And the green min, should have done that one first. This is going to be easier. The green min is 10 plus 10 is 20. Did I add the first one wrong? It's because green is at 92. Green is 82 as currently sits. And so then the green min is 20. It's 10 plus 10. Okay. And so, sorry, the yellow min is 20. Sorry, only going a little crazy here. And so here's the beautiful, beautiful part. Oh, wait. I did this wrong? I really added both of these wrong, didn't I? Yes, okay, sorry. 81 and 19. Okay, so in this arrangement, I think we have indisputably maximized green. So I'm going to type this in the chat again. So we've indisputably maximized green. So green max is... Sorry about the camera as I type. I'm going to really minimize this. The green max is 81. That's the sum. Oops. No, Google, go away. The green max is 81. The yellow min is 62. Sorry. Yellow min is not 62. The yellow min is 19. Hey, Playmaker, welcome. And so we finally achieved the desired result that 81 minus 19 is 62, which is what the actual difference between green and yellow has to be. Which means we actually have to do this, albeit we could do it in the other order. So let me translate this to honest pencil marks. So those are all 1, 2. These are all 8, 9. These are all 8, 9. These are all 1, 2. And so if we don't do this, we don't hit our target of 62. So we've got a bunch of 1, 2s and 8, 9s. Hooray. All right. Box 5, we have a 3, 7 pair vertically. Okay, so so Listesh is telling me I know somehow which way the 3, 7, and 4, 6 go in box 5. I don't see, how do I know which way the 3, 7, and 4, 6 go? Yes, these yellows are a 1, 2, 3, 4 quad. Well, vertically they add up to 15, but 3 and 7 and 5 and 4 and 6 and 5 both add up to 15. Oh, 15 needs a 4 or a 6? Okay. So magic of 15 cages. I'm told a 15 and 3 without a 5 needs a 4 or a 6. Okay. That is the piece I did not know. So these are a 3-7. These are a 4-6. Okay. I will believe that. Okay. Do we want to bring back some of our actual diagonals now? I'm not sure. So each of these has to have a 1-2, a 4-6, and an 8-9. So there is a 1 or 2, and I'm going to mark this in a ridiculous way. There is a 1 or a 2 in this cage, and there is an 8 or a 9 in this cage. So we have a virtual 1, 2, 8, 9 quadruple between these cells. And so these are all from the rest, and ditto down here. Okay. Trying to decide now which place I'm supposed to look. So likewise that. So, I guess I could have seen this in a much easier way. I definitely have a 1, 2, 8, 9 quadruple just in this column and in this column. So that was maybe a really horrendous way to see the conclusion that I wanted to see. I will just get rid of that. Okay, so do I want to look at one of these? So this is a little killer clue we have not used at all yet for any purpose. So I'm presuming we're not going to get to use that for a little bit. This 22 is really long. I wonder if we can do something with this now. Okay, so this is going to be Poiple. So what's the absolute minimum that I can make this? So 4 and 3 would be 7. Note these two are different. So that's 10. Oh yeah, we can get... Unfortunately, we can get as low as like 16 on this, I think. So that's not going to do it. Oh, I bet I have to look at these together. Yeah, that's what I'm supposed to do. I'm supposed to look at these together now. Okay, so currently, purple sums to 49. But if I remove these, purple sums to 29. And if I remove these, purple will sum to 23, right? Because I'm removing 2 2s and 2 1s. So now purple sums to 23. That is the conclusion here. Is that somehow useful? Because I know purple contains a 1 and a 2. Oh, is it true that purple can't contain any 6, 7, 8, 9s? Because if that's true, then these have to be the other... or sorry, I guess 7, 8, 9... No 8s and 9s in purple. Yeah, okay, so it's definitely true there are no 8s and 9s in purple. The reason for that is because there's an 8 or 9 on this diagonal, and there's an 8 or 9 off this diagonal here. Oh, okay. Thank you, 2toTenth, for asking me the right question, which is, where am I going to put 3 and 4 on the main diagonal? And the answer is somewhere, and it's in one of these boxes. So my minimum here isn't actually 10 and 10, like it at first looks like, because that would involve making these 1, 2, 3, 4, and 1, 2, 3, 4, which I can't do. So I can make these 1, 2, 3, 4. So I can put 2 1s in these. I can put 1, 2. So I'm going to write this down. 2 1s, 1, 2, 1, 3, 2 4s, and 2 5s. And so if I make that total is 2, 4, 7, 15, 25. Well, that didn't work. That still lets me... Wait, no, that's supposed to be the minimum. Oh, it's 3 and 4. Okay, sorry, I'm flipping this backwards, and then I can't use 2 4s. That's the thing I can't do. So I can't use 2 4s. So the minimum is 1 1 2 2 3 4 5 5, which is 10 14 17 23. There we go. So that is what's in purple, is 2 1s, 2 2s, 1 3 1 4, and 2 5s. Okay, so that is helpful. And so there's always a 1 and a 2 in here. Okay, and I don't think I know anything smart about where that 1 and 2 is, or anything like that. Yeah, that's what I said. 2 1s, 2 2s, a 3, a 4, and 2 5s, right? Oh, also always a 5. Thank you. And even just by Sudoku, I knew there was always going to have to be a 5. Okay, so that means... Ah, yeah, okay, yeah. I could have seen that just from the diagonal without doing any math at all. Because I still have 4, 6, 7, 8, 9s to put on the diagonal, and I have to put them there and there and there and there. Okay, so because we could have seen that just from the diagonal, we're going to be smart this time and see it from the diagonal in blue. So what's in blue? Okay, so that was purple. Here's blue. So blue needs to have 2 8s and 2 9s. Blue needs to have 1 7 and 1 6. Sorry, I'm now getting confused for myself. Okay, and then... Yeah. And then 2 5s and 2 4s? Wait. Yeah. And then 2 5s. Oh, wait, no, that's it. That is purple. 2 9s, 2 8s, a 7, a 6, and 2 5s. That is all of purple. And it needs to be 2 5s because, again, this 5 sees all the spots that aren't in blue in both of these boxes. Okay. So so that means that these are 5, 6, 7, 8, 9. Oops, wrong mode. And I can't put a 5 in the 10 cage. And so this is a 1, 2, 3, or 4. Okay. So this diagonal... okay, so that does not tell me anything, right? This diagonal is the one that still needs an extra... Yeah, this one still needs 4 low digits. There has to be another low digit on this diagonal, but it didn't tell me where it went because I put that there, which is a shame. I was hoping it would tell me where it went. This 20 little killer clue I am noticing is here for the first time. It's telling me these two cells sum up to at least 11, but that's not super helpful that I can see. Oh, let's see. Ranks is telling me these are a max of 5 and 3. Oh, yeah, because 5 and 4 are in different boxes. So, yeah, so these are a max of 5 and 3. So these need to sum to at least 12. And they come from, ostensibly, 3, 4, 5, 6, 7, 8, 9. Oh, sorry. 3, 4, 5, 6, 7, 8. But they need to sum to at least 12. And by the way, this is because just by looking at the 1, 2, 8, 9 eliminations. But it can't be a 3 because I can't get there. So that can't be a 3 either. It can't be a 4 because I can't get there. So these are from 5, 6, 7. It can't be 4 and 5 because the 4 and 5 are in different boxes. Because purple itself contains 2 1s, 2 2s, and 2 5s. So those have to be in separate boxes, which only leaves one spot for a 3 or 4 in each of the boxes. Okay. So... oh, both boxes have a 5. Oh, dang it. Okay, so let's go back and let's redo this calculation with the right numbers. So the maximum here is 9. So these still need to sum to at least 11. So they still can't be 3 because they have to sum to at least 11. But these could be, say, 4 and 7, and that would be fine. Okay. Is there any hope in looking at this diagonal? Can also rule out 1 from being in the sum. Okay, so yeah, so that's the other direction. 7 and 6 is the maximum these can be, which would be 13, which means that these can't involve a 1 anymore. So the 1 is definitely up in one of these two cells. That's something. Oh, no, dang it. Nope, you're right. Listesh catches me. 7 plus 7 is fine, which means this could be a 5 and a 1. It is starting to look a little like a carousel, I have to admit. Yeah, it can absolutely be double 7. I was hoping that that would break this box or something, but it definitely does not break this box. I'm looking at spots where 1s and 2s can go. So 1s and 2s can go there. Oh, no, 1 and 2 can go that. Never mind. Okay, that's not going to be helpful. The 23 clue looks exciting with all of the pencil mark digits. Okay, so we should probably use more colors. That will probably help. It can't really hurt. That is my official theory. Okay, so these two things can be 3, 4, 5, 6, 7. I won't complain if you're helpful for what it's worth. These things, yeah, this can be, again, huge. These aren't, the cells on the 23, 3 cells on the 23 diagonal aren't 1, 2, 8, 9. Do I know this isn't 1, 2, 8, 9? I know it's not 8, 9. Oh, yeah, that's right. 1, 2 is in... No. How do I know this isn't 1 or 2? I can see it can't be 8, 9. Oh, it's because it sees these two, and these two are different. Right, right. Thank you. Yeah, so maybe I should start coloring the 1s and 2s and 8s and 9s. Yeah, so it's not going to take a lot to persuade me. So we're going to color the 1, 2s. There's going to be a light 1, 2 and a dark 1, 2. And I should have suspected I would have to do this because this is a 2-10th puzzle. So there. So yeah, so this now sees both flavors of 1, 2. So it's not 1, 2, 8, 9. So this is from 3, 4, 5, 6, 7. Okay. Let's see. 2-10th says, look at the positioning of the 5s, or positioning 4 5s. Okay, so that's got to be a hint that I'm supposed to do this. So these things, there are exactly... Sorry. Okay, so the 5s in boxes 1, 3, 7, and 9 are covered by this pattern, which encompasses 4 rows and 4 columns. And if you are worried about it, we can remove these so you don't have to worry about double counting. And so that means there has to be a 5 in one of these purple or blue cells. And so there can't be a 5 here or here. And likewise, there's not a 5 anywhere in here. And likewise, there's not a 5 anywhere in here. And so we actually get lots of things about 5s. So the 5s in this box actually now can't go in any of these places. So the 5 goes in one of these 2 places, and by the same token, the 5 goes in one of these 2 places, one of these 2 places, and one of these 2 places, which is going to remove a candidate 5 from here, remove a candidate 5 from here, remove a candidate 5 from here, remove 1 from here, and remove 1 from here. it's going to remove a candidate 5 from there, from there. Okay. So by doing something that ranks can tell you the name of, involving like covering sets and containing sets or something, we now have put 5s in many fewer places. Let's see. I'm hearing that there's some better things I can do in columns 3 and 7. Okay. So I did miss one there at least. Row 8, column 9. Oh, poor row 8, column 9. It got left out. So someone points out that I have an X-wing on 5s here in the columns, which I agree. Although I'm not sure I see how that gets me any eliminations that we didn't get before. Yeah, I think this is a way that would have been much, much better to do the same thing that we did before, but I don't think it helps. I think it gets us the exact same deductions, right? Row 3, column 7. Row 3, column 7. Oh, right. This just can't be a 5 because it's on the diagonal. It was never a 5 because there's a given 5 that looks at it. But I completely agree, Calzone. That was a much more sane way to see the thing I spelled out, but I think it gets us the same place. Uh, okay. So, and these 5s aren't entangled at all, unfortunately. I was hoping that I could say one of these had to be a 5, because if I could say one of those had to be a 5, that would be interesting. But sadly, I don't think that it is. Let's see. So yeah, we've got a whole bunch of unrelated X-wings on 5s, I think. These are actually quasi-related, but I don't think in a way that's useful that I can see. Yeah, so these are all, so that is worth pointing out. These are all 3, 4, 6, 7, and they are a 3, 4, 6, 7 quadruple. So Barbie pointed this out. So these all see both flavors of 1, 2, both flavors of 8 and 9, and they can't be 5. So these are all 3, 4, 6, 7. And also they all see each other, so they're all different, which is pretty huge. Okay, so is there any way I know whether this is a 3 or a 3 4 or a 6 7? I fear not, but I would be perfectly oh no, am I supposed to use the Fistamafel ring? I mean, we are getting very close to having pencil marked and knowing the exact contents of the Fistamafel ring. That is a good point. Uh, oops, that was not a good highlighting. Okay, so boy, do I not want to have to color this. So the thing that people are alluding to in chat, and I do not know if this is going to be useful yet or not, but the thing that's being alluded to is the fact that these 16 cells that form up what's called the Fistamafel ring always contain the same digits exactly as these cells do. I kind of doubt it's going to be useful because it's an X Sudoku, but it's very possible that it is. So it tells me, for example, that I need I need to put that many things. Yeah, it looks, I mean, it looks cute. I mean, it definitely is adorable the way that it's sort of sketching itself in out of nowhere. Uh, I can remove the corner fives from outer pink. That is correct. So these are not fives. Okay, so boy, this 23 diagonal is unimpressive looking. Now, I do know these can't be 5 anymore, so that's at least something. But it's not a lot. It's technically something. Uh, As Ranks points out, following Eric's hint that I should try and think about where fives go, I very carefully thought the entire point of this was to rule 5 out of these two things on the 23 diagonal, which Eric points out is, which Ranks points out is ruled out by the given 5. So that's spectacular. So should I be thinking about what dark gray 8-9 and light gray 1-2 add to? Because they don't add to 10. So here's how I know that. Because dark gray 1-2 and light gray 8-9 are in this cage. And if they added to 10, I'd need a 5 in the cage, which I can't have. So it is light gray 1-2 and light gray 8-9. These add to 10. I don't know if that's helpful, but I'm writing it down. Light gray 1-2 and light gray 8-9 add to 10. So yeah, one of these is a 1-8, and this makes sense because in the cage I'm going to need a 1-8 with a 4. Sorry, a 1-8 with a 6, and a 2-9 with a 4. But that at least gives me some interaction between these clues. Oh, let's see. Playmaker says that actually tells us something. Row 3 and 7, column 5. But then Playmaker seems to retract the that actually tells us something. Okay, let's see. Whose bet is still alive for the bet cell? We've still got 4 possibilities. We can see if anyone is going to get the bet cell right. My hope 5 minutes into this puzzle was that I would know 10 minutes into the puzzle that this cell was an 8 or a 9, and that has not transpired. Okay. There's no way that some cell here secretly sees a bunch of stuff. Okay. So light gray 8-9 is in one of these two places. Because light gray 8-9 sees this cell and sees this cell. And remember, this is a quadruple. Dark gray 8-9 is in one of these two cells. Which is a little disappointing. So here's an interesting point that Barbie makes. if I look at this line, I now know a little more than I did before. And by a little more, I mean a very, very little more. These two sum to 3. So the rest of this needs to sum to 19. These two sum to, again, at least 7. So these need to sum to at least, or at most 9. Which means there is a repeat among these 4 purple digits, for what that's worth. Yeah, the light gray 1, 2 is down here somewhere. Does that help me somehow? Okay, so here's the thing I know. I know one of these two is the dark gray 8, 9. Are there any cells that are seen by both of those that it is useful to note can't be dark gray 8, 9? And I think the answer is no. But this is a first. I'm going to have to take a short bathroom break in the middle of this puzzle, but I will be right back. But I don't think I've had to do this in the middle of a solve before, but we'll get there. We'll get to a digit, baby. And we're back. Did chat solve it while I was gone? Let's see. Liz is telling me I added something wrong. But I don't remember what puzzle we're doing anymore. So let's see. I'll have to look again. Let's see. I think it had to do with this diagonal. Either row 8, column 1, or row 9, column 2 is light gray 8, 9. Yep, agree. The light gray 8, 9 definitely gets pushed into one of these two. Let's see. Calzone says, for whatever it may be worth, there's exactly 1, 5 on the 22 and 27 diagonals. That's true. See, this 3, 4, 6, 7 seems suspicious to me. I don't know if there's any way I can use it. But the fact that I know that this is one of each of 3, 4, 6, and 7 just makes me suspicious. Yeah, light gray. Okay, so that's a good question. So that is an excellent point, Rensk. So light gray, let's see, light gray 1, 2 plus light gray 8, 9 is equal to 10. So if this is light gray, so is this. And if this is dark gray, so is this. Does that affect anything that is interesting? Okay, and I'm also being encouraged to think about the colored 1, 2, 8, 9s in the corner boxes. So but I really like Rank's point, but I can't quite make sense of it yet. So let's see. So if I think about where can light gray 1, 2s live, uh, light gray 1, 2s, let's see, cannot live in these places. I can't live there, can't live there, can't live there, definitely not there. Okay, so I think I've ruled out all the places I can do a simple elimination on light gray 1, 2. And we are encouraged to think about them in the corner box. So it's definitely one of these two. Column 4. Oh, yes, the rest of this column. Yep. We're one bio break into this solve so far. We'll see if we make it to the second. Okay, so negative diagonal. Yes, the negative diagonal is immediately ruled out. Okay, good. Okay, we are highlighting cells that cannot be light gray 1, 2. But Tall Cat is going to save us because he has solved the puzzle, and so assuredly remembers the next step. Greens and blues. Yeah, the blues certainly aren't. Okay, I'm hoping that something will appear if I squint at this long enough. By which I really mean if you squint at this long enough, you will tell me. Can't be in row 1, column 7. Well, that's interesting. Why can't it be in row 1, column 7? Because I think if we could learn it's not in row 1, column 7, I think that would actually be very useful. Look at the diagonal in box 1. Let's see. That would put one here. Put one here. I don't see it. Yeah, so Playmaker brings up a good point, which is that we know that these yellows are a set of the digits 1, 2, 3, 4, the 4 yellows that are in these corner boxes, but I do not immediately see, or even with less immediately, can it be in row 1, column 9? Okay, so what happens if this is the gray 1, 2. Oh, Lord. That was not getting seen by me. Okay, this can't actually be the gray 1, 2. And the reason why this can't be the gray 1, 2 is that if this is the gray 1, 2, look what happens in this box. We have forced the gray 1, 2 to go here, which then forces the gray 1, 2 to go here, and now we've put the gray 1, 2 on the diagonal twice. So that's not good. So this is not the gray 1, 2. So the actual location of the gray 1, 2 is one of these two. Okay, so one of those two. Let's see, row 9, column 1. So if I try and put a light gray 1, 2 here, what happens? It then pins a light gray 1, 2 here, which then places a light gray 1, 2 here. Yep. So yes, it does exactly. So this, similarly, cannot be a light gray 1, 2. So I can't put a light gray 1, 2 here or here. So my light gray 1, 2 in this box is here or here, and in this box is here or here. Okay, and so what that means is exactly one of these two is a light gray 1, 2. And exactly one of these is a light gray 1, 2. And sadly, both of those look at cells that are not useful, I think. There. Okay, so what about dark gray 1, 2s? What happens with dark gray 1, 2s? Are they going to get forced into the same cells? Because that would be sweet. So dark gray 1, 2s. Oh, I'm looking in the wrong place. Dark gray 1, 2s. Let's look up in this box. So they can ostensibly go here or here. Oh, okay. So I think I see where this is going to go. Or here. But this is going to get eliminated by the same logic I'm going to get. Because I think if this is a dark gray 1, 2, then it's going to... So I think the conclusion is going to be that these are both going to have to be the gray 1, 2s. That's what I think we're going to prove. Because if we can get the same deduction that this can't be dark gray, this can't be the dark gray 1, 2, then we're going to know the dark gray 1, 2 has to be here, here, and here, or here. And so I'm going to need to put a 1, 2 pair there and there, which is, I think, what's going to happen. But let's see if we can follow this through. So if this was dark gray 1, 2, it's going to push down here. And be... Yeah, and be there. And then that's going to push it over here. It's going to rule it out of there, rule it out of there. Oh, yeah, and it's not those, so it would push it there. Yep, okay. So, yes, same logic applies. Dark gray can't go here. Dark gray 1, 2 can't go there. And I'm going to bet dark gray 1, 2 can't go here either. Because if I put dark gray 1, 2 here, then it's going to get pushed to here, which is then going to come up here and push it to, yep, to exactly there. Okay, so one of these two is a light gray 1, 2. One of these two is a light gray 1, 2. And so in particular, the only places light gray 1, 2 can go on the diagonal are here and here, and the only places dark gray 1, 2 can go on the diagonal are here and here. So these are a 1, 2 pair. That is the point of the story. So these are a light gray, dark gray 1, 2 pair. I don't know whether they're light gray or dark gray yet, but hey, it's something. So this is an 8 or a 9 now. Let's see. Light gray, so T is saying light gray has to be row 2, column 8, or row 7, column 1. Row 2, column 8, or row 7, column 1. Sorry, row 7, column 1. Yeah, so presumably I can do the same thing for 8s and 9s, is I think what Playmaker is suggesting. I was really just scanning here, trying to make use of Rank's earlier hope that I would be able to identify whether this is a light gray pair or a dark gray pair. Look at box 1 and box 9 at the diagonals. Yeah, so this, well, no, this the diagonals here don't have 1s and 2s on them. So and then box 9 and the diagonals. So I know this 1, 2 is here. It's in one of those two cells. And so this 1, 2, oh, I know this 1, 2 is there too. No, I don't. I know this 1, 2 is there or there, but I don't know which. But this 1, 2, yeah, I know it's in one of these two cells, but I don't know which. I'm not sure I see how this is helping. The 15 clue in box 8. And it has to have both 1 and 2. I'm not seeing this connection. I know there's a light gray 1, 2 in here somewhere, but I don't think I have any idea where it goes. Let's try and do the same thing with 8, 9s, and then we can come back and look at all of this again. So let's real quick look at 8, 9s. Okay, so the 8, 9, the dark 8, 9 is forced into one of these cells. Oh wait, is this already different than what we did before? Stream began about 4 hours ago, Glum. Okay, so yeah, the one of these two is the dark gray 8, 9. Is something similar. Okay, so but this doesn't look at all like the other one somehow. But I very well could be... yeah, okay, so I'm looking at the wrong box. Oh, am I supposed to be looking at this box over here? Yeah, probably I'm supposed to be looking at this box. And saying, okay, so the 8, 9 is in one of these three places. So the dark gray 8, 9 is at one of these three places, but presumably it's not here. So if this was the dark gray 8, 9, it would put the dark gray 8, 9 exactly here. And so then where would it put the dark gray 8, 9 down here? It would put it there, which breaks. Okay, so this is not the dark gray 8, 9. And so the dark gray 8, 9 can actually only go in one of these two places. And so by the same logic, it's going to happen down here. So this is also going to be an 8, 9. That is going to be the conclusion here. So I guess it also follows that these are from 3, 4, 6, 7. I don't know if that's helpful to note, but we will note it because we can. That's an 8, 9 pair in column 2. Oh, that is an 8, 9 pair in column 2. Thank you, Listesh. That seems very useful. I mean, at least in my fantasies. That might be useful. Okay, so that's... So the dark gray 8, 9 is in this 15 cage. I know that. So the dark gray 8, 9 is either the bet cell, or it's exactly there. Those are the only places in the row for the dark gray 8, 9. So are the other corners. Oh, likewise. Sorry, I keep... your screen names both start with the same letter and about the same length. I should look at the avatar the second time I thank Listesh for something that likewise said. Okay. 1, 2 light gray always has to be in row 9, column 9. 2 light gray. Yeah, I still don't see how that's happening exactly. Row 9, column 2, the same as row 8, column 8. Carl says row 9, column 2. So the same as row 8, column 8. Wait, row 9, column 2. The same as row 8, column 8. Okay, are these two the same? Yes, they are. Okay, so the question is, where does this digit go over in this box? And the only place this digit can go in this box is here. So these two can get... these two can get an orange. Aha! No, that doesn't do anything. Never mind. That tells me that orange is in one of these two places, which tells me that orange is either light gray or dark gray, but I knew that. So, oops. Sorry about that. So we have two different coloring systems for 8, 9s, but what would you expect in a 2 to 10th puzzle? So this is the other 8, 9. It can be black, I guess. Yeah, these two are the same, but what does it get me? I really like the observation that they're the same. Look, it seems very useful, except I can't figure out a way to use it. Where can it go in box 3? Asks the hippo. Okay, so... Oh, this is definitely not your standard puzzle. But still, there is lots of coloring on top of coloring. The coloring of bi values like this is one of my favorite things that you do a lot in your puzzles. Oh, these are 3, 4, 6, 7. Okay, so the hippo asked where I can put this in. Oh, in box 3, Lord. So in box 3, this cell goes in one of these two places. And likewise in box, well, I guess I know that this one goes over there. So am I supposed to now color this one too orange? Because I feel like I have to think about the 1, 2, and the 8, 9 that add together to 10 together. So these are either both light gray or both dark gray. I think Carl has seen it. Uh, oh, oh, okay. No, no, that's not. Yeah, the orange is here in one of these two. Yeah, the black is here in one of these two. Okay, so let's make that the orange 1, 2, that the black 1, 2, because these do add to 10, those do add to 10. Let's see, check the 20 diagonal again. Okay, so likewise suggests that the max we can put on it in box 1 is now 7. What's to stop me from putting a 5 and a 4 on it now? Okay, the setter is encouraging me to try and still think about these 1, 2, 8, 9s and how they're connected to each other. Okay, so these 1, 2, 8, 9s are different. These two 1, 2, 8, 9s are the same. So uh I'm trying to figure out something with this 15 cage because exactly one of these is in the 15 cage. But it's not even clear to me, does it go here? Does it go here? Whichever one that is in there. Okay. Likewise is saying these can't be 5. Not sure I see that yet. Okay, row 2, column 5. And row 8, column 5 is a 4, 6 pair. I did open by saying that this I was doing this against the advice of counsel. So there is that. So likewise says these have to be a 4, 6 pair. Okay, so If this is any flavor of 1, 2, 8, or 9, it's an orange 1, 2, 8, or 9. Okay, so let's test. It must be right that this must be a 4-6 pair. But I'm not seeing how I know that this can't be an orange 1, 2, 8, or 9. Because I do know that. I said list test, didn't I? I meant to say list test. Uh, yeah, so I know that there are two 1, 2, 8, 9s in this 15 cage. One black and one orange. One light and one dark. Something, something, something. So this would have to be an orange 1, 2, 8, 9. If it was something. I don't see it. The orange. Let's see. If row 2, column 5 is, say, an orange 1, 2, where does orange 1, 2 go in box 1? Wow. Yeah, that's nice. Okay, yes. That is sweet. Okay, so this is sort of like a. I think this is the thing I always think of as an empty rectangle thing that's not really an empty rectangle thing. So orange 1, 2 is in one of these two cells. So this is not orange 1, 2. It's also not black 1, 2. And likewise, orange 8, 9 is in one of these cells. So this is not orange 8, 9. It's also not that. So yeah, so that is, okay, so that is very nice. That is a 4, 6 pair. So beautiful. Okay, so this is a 1, 2, 8, or 9, and this is a 1, 2, 8, or 9. And do I know which way they go yet? Should have marked those in the corner boxes. Yeah, we did see that earlier and just not put together the pieces for whatever reason. So those are a 4, 6. So I know all of these are 1, 2, 8, 9s. Okay, so. Oh, you want me to like put a flash in here to say one of these is orange? Okay, I can do that. So one of these is orange. I don't know which one. And one of these is orange. I don't know which one. And so I guess that lets me say, oh, I guess I already knew that this was going to be 3, 4, 6, or 7, didn't I? Oh, yeah, okay. So then vertically, black is in one of these two cells. And black is in one of these two cells. Okay, so we've got those set up. Yeah, so there is either an orange 1, 2 or an orange 8, 9 in this box. If there's an orange 8, 9 there, then that means there's a black 1, 2 there. Oh, the black 1, 2 here can be flashed. Yep, agree. And did I miss a similar one for one of the others? Ah, yeah, the orange 1, 2 here can be flashed. so yeah, the orange 1, 2 is either here or it's over here. Okay, does this find where the other 1, 2 goes in box 4? Okay, so so these aren't 1, 2. That's not 1, 2. So yeah, we get a weird X-wing kind of thing, it looks like, where one of these two is 1, 2. Which is presumably the mirror version of this. Presumably one of these is 1, 2, and one of these is 8, 9. So 3, 7 pair on row 5, column 2. Oh, yeah, okay. So, yeah, so yes, so got it. Okay, so, yeah. So this can't be 5. It can't be either flavor of 1, 2, 8, 9, and it can't be 4, 6. So these are a 3, 7 pair. Good spot, Liztesh. I completely acknowledge that that should have been an easier follow through for me than it was, but hey, we're gonna take it. These can only be from 3 and 7, and that gives a 1, 2, 8, 9 quad in that box. Let's see. So none of these are 1, 2, 8, 9. I'm not sure I see what that box is in this instance. Oh, it's in the row. So now everything in this row that's left is a 1, 2, 8, 9. Okay, so that does give... Okay, I understand now. So yeah, so the row here is 1, 2, 8, 9. So this is gray for sure because it's next to two of the same color. So likewise, this is light gray. This is dark gray. This is light gray. So now these are from, let's see, the 23 clue. The 23 clue. So what can I possibly do with this? This is such a mess. If I know what this is, okay, is it that I'm going to turn out that this is also, that I'm going to learn whether this is light gray or not because I know it needs to sum to 10 with this? Okay, so what is the minimum here? The minimum here would be something like 9 or something like that. So let's see. I want to write in candidates for these just in case it does anything useful. So these are 3, 4, 5, 6, 7. But these aren't 5. Let's see. I'm trying to look for one of these where we've got a lot of oomph to go on. Like, it would be nice if maybe we could disambiguate the one, whether purple and black are light gray or dark gray would be nice to know. But I don't think I can quite see how to do it yet. Not a coloring puzzle. Everything is a coloring puzzle if you try hard enough. So where does this 3, 4, 6, 7 go on the positive diagonal? And the answer is it has to go here or here, which is not super helpful, I don't think. Sometimes puzzles just sort of congeal into being on their own. It is a thing that happens. Oh, I never marked that the black 8, 9 is in one of these cells. I don't know why. Let's see. Okay, so BremSter asks, how can row 2, column 3 or row 3, column 2 be 1? Or are you asking because of the little killers, or what exactly? Oh, because of this whole thing. Yeah. We tried very hard earlier to pretend that we could break this up. Okay, so here's one thing that we could maybe ask. There was discussion earlier about whether this could really be a 5. And so the question was, okay, if this is 7, 7, then we can do this. So can these both be 7? Is that possible? Is there some way that we could know that these aren't both 7? So if these were both 7, what would happen? So if these were both 7, that would be 7. That would be 7. Let's see. Yeah, I don't see why that would break immediately. Let's see. 7 would be in row 3, column 3. Let's see if this is a 7 and that's a 7. Ah, yeah, 7 could only go there. So that's good. That would be a 7. That would be a 7. Yeah, one of these two would be a 7. The 7 would have to go on this diagonal in one of these two places, and have to go on this diagonal in one of these two places. So because the 7 would have to go on both of these diagonal... No, sorry. The 7 doesn't have to go on this diagonal. That was a lie. The 7's already on the diagonal. Yes, and now 7 can't go on the positive diagonal anymore. Ta-da! Was that the intended path? These can't both be 7 because that? Because wow. But yes, Okay, so these can't both really be 7. I don't have a great way to pencil mark that, but we're just going to say it. These two can't both be 7. And so once those two can't both be 7, sorry, that tells me that neither of these can be a 1, because the only way we could possibly use a 1 was if we maxed everything else. So yes, congratulations, BremSter, you win the prize. Who remembers what their bet cell digit was? Let's see. Okay, so one of these is a 1. Does that do me any good? Okay, so does anyone see anything that I can do with the fact that neither of these cells is a 1? Okay, likewise thinks that they can save the day. Oh, okay, so the 22 little killer, I hear stories might be theoretically possible to do at this point. Okay. So these two definitely sum to 3. Let's see. So naively, you could say, okay, well, that's at least 3 plus 3 plus 3 is 9, plus that is 16, which is way too little. But surely... this can't be a 1-2 pair. That's the point, or that's a point. This can't be a 1-2 pair because the ones are on opposite sides. So this is actually at least 4, and this is at least 4 for the same reason. So that is a minimum of 8, 11. And so these need to sum to at most 11. So they can't be 6 and 7. Oh, I have to have a 5 on it. There must be a 5 on this diagonal. Or else the X-wings don't work. I'm so inclined to just believe people, but I being the apparently masochist that I am going to try and understand this. Okay, so there's this double X-wing on 5s that we have. Sorry, I was shaking the camera again. And so if neither of these was a 5, that would put a 5 here and here, which would be a problem for this box, because this box wouldn't be allowed to have a 5 anymore. Okay, yep, agree. So there's exactly 1 5 in here, so let's... So one of these is at least 6. The other is at least 4. That's 10. 13. And so now, these two total at most 8. So we get a digit! Because this can't be a 7 anymore. Woohoo! Okay, and that's the puzzle. I hope you enjoyed this. Sorry. Let's see. So we probably should do that. Okay, so that's a 3. That's a 7. Yeah, and this can be at most 8. So that's a 4, and that's a 6. And so suddenly, like wildfire, we have 5 whole digits. Now, that actually means because these actually sum to 7, we have to be quite close to that minimum. We only have 1 degree of freedom over this being a 5 and a 1 and a 1 and a 3. So there's definitely a 1 on both of these. Wait, no, sorry. The minimum was that these boxes had a 5 and a 1 in one and a 1 and a 3 in the other. There's a 5 and a 1 in one of these and a 1 and a 3, and we have 1 degree of freedom on top of that. Does that actually not rule out a single digit out of these? I think that doesn't rule a single digit out of either of these. So 1 is a 1 and a 3. Yeah, one is a 1 and a 3 or a 1 and a 4, and the other is a 5 and a 1 or a 5 and a 2. I don't think that lets me make any progress on these things. But I can at least go through and clear out some pencil marks. So these aren't 7s anymore. That's not a 7. These aren't 4. That's not 6. Maybe box 2 and the 20 little killer. Okay, so maybe box 2 and the 20 little killer. Who knows? It could be. Okay, so what's happened here? The quest for digit 5 begins. There we go. Got the turtling back. So these sum to a minimum of 9. So these sum to a maximum of 11. Let's see. How about the 54 diagonal? Sure, why not? What could possibly go wrong? Okay, let's look at the 54 diagonal. Okay, so 54 diagonal. Subtract 17. 54 minus 17 is 37. Subtract 9 is 28. So these need to sum to 28. And yeah, that seems like a good chunk of degrees of freedom. We know there's got to be a 5 in there by the same logic that we knew there had to be a 5 before. So the actual maximum would be... So we're going for 28 for these, if I recall correctly. And the maximum would be take a 5 and a 9 and a 8 and a 9. Which would give us 18, 26, 31. Still way too big. The 27 has a 6 and a 7 on it. Oh, that's a good point. This is actually this is now looking interesting. Okay. So 27, 20, 14, 11. These 4 cells sum to 11. Has to have a 5. So the minimum here would be a 5 and a 1 and a 1 and a 3. So the minimum is actually 10. But again, a 5 and a 1 and a 1 and a 3 is exactly the perfect combination to say where there's 1 degree of freedom and I can't make even a single elimination out of these. Can I remove 4s? I thought if... because the 1 and the 3 could be 1 and a 4. Can remove the 4 in row 1. Yes, good eye. Yes, I can remove this 4 because, yes, I could not make either of those combinations there. So, yeah, could I have 2 1s? Okay, so the recommended next step is to see what happens if you put a 2 on the 20 little killer. Yeah, I'm sort of suspicious that maybe I can't have 2 1s, but I'm not sure exactly what problems it would cause, potentially. Okay, so the 20 little killer, okay, so if there's a 2 here, then this would be maximum 7. And so I would need to make these sum to 13. So if there's a 2 here, these would be maximum 7. So these would have to be a 7 and a 6. And that does not work. Because, no, never mind, sorry. I was going to say something dumb. These would have to be a 7 and a 6. That's true. Yeah, so... yeah, because of the X-wing, this would be 7, this would be 6, 7. So this would be a 3 or a 4. Because it would see a 6 and a 7. So ranks did exactly the thing that I always do, which is to say, if this is a 6-7, that rules 6-7 out of those cells, and so 6-7 have to go in here, and so that's got to be both the 6 and the 7. I have done this to myself so many times that I know exactly the thing. Okay, so why is this being a 6-7 bad? So this would be a 7. So where would the 7 go in this box now? So the 7 would go in... Oh, great. This is the hardest step. I'm glad we've gotten past the easy part of the puzzle. It was frankly a little tricky. Okay. So the 7 would be in one of these 2 cells. So the 7 would be over here. I feel like I gotta look at the 6 and the 7 at the same time somehow. Like, if this were a 6 and a 7, that would make this a 3-4. Does that somehow percolate down the diagonal? Keep focusing on the 1, 2, 8, 9 positioning if 2 is one of these 2 digits. Okay, so what happens if one of these 2 digits is a 2? So if this is a 2, it's then this is a 1 and a 9. Yeah, okay. So, okay, so here's an interesting observation. So if this one's a 2 at least, uh then both of these become 1s and become the same. Uh and so light gray and orange become the same is what happens if this is a 2. Yeah, and so okay, so let's see. I'm looking at what Playmaker says. Row 1, column 2 can't be a 3. So it will make row 5, column 8 a 3. Sorry, row 1, column 2. Because it will make this a 3. And now row 4 has no place to get a 3. Good spot. Good spot. I agree. So this isn't a 3. It's a 1 or a 2. Ah! Okay, that's beautiful. Okay. Playmaker has solved the puzzle. Because now this is a 1 or a 2. So this can't be a 2 anymore. It's not black. It's not 2, not 2. So this is really the black 1, 2. So these two sum to 10, these two sum to 10, like before. Okay, so the black 1, 2 down here. So this cell's not black anymore. It sees, no, sorry, that's a lie. It's not a black 1, 2. This feels like it should be so helpful. So could this be the orange 1, 2? So if this is the orange 1, 2, now this is at least 3 and 5. Which would be 8. I would need these to sum to... That still seems very plausible, unfortunately. So where is orange 1, 2 in row 3? It's not... Oh, it could be there. Damn it. Row 3, column 2 can't be 3 by the same logic, right? Question mark? Okay, if this is a 3, that's a 7, that's a 3, and now there's no place for a 3 here. Okay, so this is not a 3 either. This is a 4 or a 5. Okay, making progress, making progress. So one of these... No, not one of those two is a 3, sorry. But that one's not a 3 for the same reason. Okay. Since I've forgotten what purple even means, I'm going to just de-purple the part behind this. Because if I need to use something about purple, it's going to be a while before I get there. Same logic with box 9. Okay, so if this is a 3, that's a 7, this is a 3. Is this cell allowed to be a 3? I don't think I know that this cell can't be a 3. Row 2, column 1 should give the same logic on 4s. In column 6. Okay, so if this is a 4, that's a 6. And that's a 4. Yes, it was absolutely 3's pointing up. Good observation. So I'm not following Eric's point about the same logic. I'm presuming I'm supposed to do that, but yeah, there's already a 6 in this column, and I don't have any restrictions on this cell that I've written in, which doesn't mean there aren't restrictions on this cell. But yeah, I don't see it. Let's put it that way. But this being a 4 or 5, let's see. So yeah, if this were a 5, it would force this to be a 4. Those would total 11. I would need these two to total 9, which would require this to be a 4 and this to be a 5. Is that a problem? If this goes 5, 4, 5 here, 4 here, and then 5 here, 4 here? Not that I see. 4 plus 5 is not 11. Oh, that's a good point. 4 plus 5 is not 11. It's 11-ish. I see something. Okay, Insanity Cat sees something. I think the 4 in row 3, column 2, breaks the 22 clue. Okay, so let's look at this 22 clue again. So, 22, 19, 12. Okay, so these need to sum to 12. And so now the question is, what are these? So one of these has to have a 5. And so if this is a 4, this could be 4, 1, but then this would have to have a 5 and could be 5, 1. So 4, 1 plus 5, 1 would be 11. Did we break it? Let's see. What was the numbers again? I've forgotten the numbers already. 22 minus 10 is 12. So if this is a 4, the main effect is it puts a 5 over here. But it looks to me like we just skate by if these are a 1, 2. Oh, but they can't be a 1, 2. Okay, I think we've got it. I think. Okay, so we have to actually look at the exact sum. We have to look at the exact sum. And yes, Insanity Cat, this is an insane spot. So I'm going to look at this, and I'm not minimizing at all. I'm looking at the exact value. This is a 7, 10. If this, and I'm now hypothesizing that this is a 4. So we're now at 14. This now has to be a 5, because by X-Wing logic from before, this has to be a 5. Don't at me. So we're now at 19. And so these two digits have to add to 3, which would mean they would have to be a 1-2 pair. But by coloring, they can't be a 1-2 pair. They would have to either be both 1, both 2, or one of them could be 1 or 2 and the other could not be. None of those work. And so this is not the 5. Sorry, this is not a 4. Not a 4. So this is a 5. Okay. I'm just curious. Did you submit this to Cracking the Cryptic? Did you try and get Simon to do this? Okay, so that is a 5. This is now a 1 or a 2. I think. We usually only digit dance for the first digit, but I feel in this puzzle we deserve to have a digit dance for our second digit, or our second collection of digits that we've gotten. Okay, so now that this is a 5, this is not a 5, and so this is a 5. And so this is orange. This is not orange. So this is a 1 or a 2. So this is the orange 1, 2. Great. Okay, so the 5 here looks up and sees that this isn't a 5. So this is a 5 now, because it's the only place for a 5. So this is not orange, it's blue. This is not blue, it's orange. And so it's an 8 or a 9. Welcome back, Taipan. Plus, I didn't want to write a solution guide. I do not blame you for not wanting to write a solution guide. Okay. I'm hearing tell that this means that orange is dark gray, but I am now uncertain. Oh no, did we break the puzzle? Let's see. I'm not sure pointing them at this video would be the best way to convince them to do the puzzle. Just throwing that out there. So that's got to be the 5. So that's not black. This is black. So this is an 8 or a 9. Okay, so this is... Sorry, this is black. I don't know why I de-blacked it. I meant to de-blue it. Okay, so... There's my 8 9s. Let's see here. Okay, so... Now 4 in box 4 is restricted to column 2. Now 4 in box 4. I don't see... Oh, let's see. I think I've missed some logic about 4s, if you can see something about 4s. Let's see. 6, 7, 3, 7... 3, 4, 6. I don't think there's a tuple, but maybe there is. The only places for 4s in the column are there. So this is the locked candidate pointing pair thing that I think are maybe similar. But anyway, so one of these is a 4, so these aren't 4s. Yeah, I feel like of puzzles I've made, this is most similar to 2D wave particles, although that was probably the easiest of the solution guides that I've ever had to write because I understood it forwards and backwards by the time I was done studying it. Okay, so this 8 9 is looking up here. Does this 8 9 see any 8 9s? Oh, this sees a green 8 9. I don't think I know what this is yet. Row 2, column 3 can't be 5 for about 8 reasons. I agree, it's not a 5. Do we have all the 5s? We don't have all the 5s. How do we possibly not have all the 5s? Oh, we've got these 2 other X-Wings and 5s that are making our lives unhappy. Let's see. So is the 22 diagonal... this can't be a 5 for, again, some number of reasons that is large. Okay, so let's look at the 22 diagonal now. I think we might be able to do something. Okay, so minus 10 is 12, minus 5 is 7. These need to sum to 7. Yeah, I don't think that actually tells me anything. Well, it does tell me this can't be a 4, I think. Because if this was a 4, I couldn't make these 2 sum to 7. Sorry, if this was a 4, I could do that. So I can rule out a 4, at the very least. But if this is a 3 now... this could be a 1 and that could be a 3, and that's fine. Okay, so I'm hearing that the 54 diagonal is now useful. Okay, so let's look at the 54 diagonal, and let's carefully check Zeta's math as we go along. So we're going to start by throwing away 14. So we're left with these cells need to sum to 40. We're going to throw away 17 more, so these cells need to sum to 23. Yes, okay, so these are 23, which is so I have two orange 8 9s, and I need 23, and I'm going to write down the number 23 because otherwise I will forget it. Okay, so I'm aiming for 23 here. If those oranges were both 8s, that would be 16, and this would be a 7. If those oranges were both 9s, that would be 18, and this would be a 5. And that doesn't work. So, in fact, this is a 7, and these are both 8s. Let me know if people disagree. I think, actually, by this, we did exactly the same thing that someone else did down here, because someone was saying that this not being able to be 7 told me this couldn't be a 1, so it had to be a 2. So I think we got to the same place. Let's see. So this should hopefully clarify some pieces of reality. So that's a 9. That's a 9. That's a 1. That's a 1. I'm assuming in at most a couple hours we'll be done with the puzzle. Let's see. So that's not an 8 or a 2. It's a 1 or a 9. So this is a 2 or an 8. Yeah, this is a 2 or an 8. I don't think I know which one yet, though. Let's see. This 7 looks at this 3, which looks at that 7, which removes a 7 pencil mark there, a 3 pencil mark there. Okay, oh no, we don't have a quadruple. That was excessively optimistic. Let's see. Corner boxes remove 1 and 2 pencil marks. So yeah, so that's not a 1. Okay, so yeah, so these aren't 2 anymore. These aren't, that's not 1 anymore. Column 2. Yes, that's a 6. That's going to help. That's a 4. That's a 3. Yeah, probably I can, oops. That's not what I meant to do. Probably I can just ditch the colors. Although it always takes a second for my eyes to adjust after I delete the colors from one of these things. Okay, so the 6 here is telling me none of those are 6. The 1 is telling me that's not a 1 and that's not a 1. Okay. Row 1, column 8 is a 9. From color? Oh, from coloring. Okay. Okay, so we're going to keep the coloring for a moment. Row 1. Oh, row 1, column 8. Sorry. Yes, because one of these had to be an 8 or a 9. And so that's the 9. Okay, perfect. Okay, so we'll get rid of you. Sorry, you're supposed to get rid of black. You're supposed to get rid of blue. Okay. So that's now not a 9. That's not a 9. And so once this is a 2 or an 8, this isn't a 2 or an 8. It's a 1 or a 9. Don't know which just yet, but we're hopefully getting there. People are suggesting the 27 diagonal is useful, so I'm going to look at that because I trust my chat. Okay, so 27, we're going to take off 13 right away. That's 14. That's 11. That's 10. That's 5. Okay, so these two cells need to sum to 5. So this can't be a 4. So this cell can't be a 4. And this cell can't be a 3. Okay, so this is 2 or a 4. This is a 1 or a 3. Okay, now we've got a 1-3 pair in the box, seemingly out of nowhere. So that's not a 3. That's not a 3. Let's see. Blue and purple meant something hours ago, but yeah, who knows what blue and purple mean? We don't even talk about those anymore. We just go on. So row 2, column 3 is a 4. Wait, I missed a leap here because these... I don't see something about that yet. 4 on the diagonal. Let's see. 4 in this box is definitely on the diagonal. Gotcha. Excellent locked candidate. So these aren't 4. So now 4 can only live in one place. And so now this is a 1. That's a 3. So good progress. So this can be black. This can be purple. Okay. So box 215 has a 6 in it. Yes. Ta-da! Okay, so that's a 6. And so 6 needs to go with two things that sum to 9. So it's not a 9, so it is a 1 and an 8. And so that is a 9. And that is a 2, and that's a 4. Woohoo! Okay, so that is finally going to tell us that the light gray things were 8s, and the dark grays were 9s. And the light gray 1-2s were 2s, and the dark gray 1-2s were 1s. Okay, so that is super helpful. So these aren't 2 or 8. These aren't 1 or 9. Okay, that's not a 1 anymore for multiple reasons. It also tells us that dark gray is black. I'm not sure I'm willing to guess that this is almost there. It could still have several more... I think someone about 2.5 hours in said they wanted to know when I got to the break-in, so we might be almost to the break-in. This has to be a 4 or 6, but it's not a 4, so it's a 6. That's a 4. This being a 6 means that's not a 6 or a 7, so it's a 5. So that's a 6. Yeah, this is the last stream of the year now. Yep. 2, 3, 4, 5, 6, 7. Let's see. 2, 3, 4, 5. I probably should have been able to figure that one out quicker, but also it's been a while since I've been doing this. Let's see. That's a 7. Oh, that 8 is looking at that and says that's a 2 and that's an 8. This 7 is looking down here. That's not a 7. Let's see, this 9 is telling me that's not a 9. So the only place for a 9 in this box is here. AKA Sudoku. If you prefer thinking about things in terms of Sudoku, that is a way to do it. 9, 1. Oh yes, you won the bet. Congratulations. By the way, reminder to those setters in chat: if you've never given me permission to do your puzzles, if you want to watch me, spend 4 hours solving one of your puzzles, you can give me permission to do your puzzles on Discord. Let's see. Something's wrong. Okay, there's not supposed to be a 6 there anymore. Oh, not supposed to be a 6 there anymore either. The 23 diagonal. Okay, so these need to sum to 23. Minus 10 is 13. Minus 4 is 9. So these two need to sum to 9. So that can't be a 7, and that can't be a 7. That can't be a 4, so it is a 3, and that's a 6. So that's a 2. I probably could have done that with coloring if I was paying super close attention. I should be able to figure out what this is. It's a 7. So let's see, that's a 5. Let's see, so that's a 5 while I'm doing it. Okay, so these cells are a 3, which goes there, and a 6, which goes there. These cells, 6, 7. 1, 2, 3. Okay, that's a 4. Okay, there's a 3 down here, so these aren't 3. That one's not 2 either. In fact, that's the only place for a 1 down here by Sudoku. So yeah, there's a 4, 6, 7 triple. Uh-oh, did I break something? Yeah, nice and smooth. I'm curious to see when you start setting something that's not a gas anymore, but I have enjoyed it. Let's see. Let's see, 7. 7 in row 1 is definitely in this box, so this isn't a 7, also known as there's a 7 over there. So that's an 8. Okay, so this is not an 8. These are 3, 6, 7. That one's not a 7 or a 6, so it's a 3. That's a 7. That's a 6. Let's see. This is not a 4 or a 3, so it's a 7. This is not a 6. Deadly pattern resolved by a diagonal-based Y-wing. That really would put the final twist of the knife on there, wouldn't it? 7. Let's see. So this is not 1, 2. It is 3 or 4. It's not 3 either, so it is 4. This is not... Oh, this is 3. To finish the thing. This is 3. And this is 4. There we go. And in only about 4 hours or so, we successfully solved Carousel by 2totenth, which is quite a puzzle, I will say. I'm going to go take a short stretch break. I will be back with what I hope is an easier puzzle in just a few minutes. And then I'll be back. Well, if you want to go back and watch the VOD, Alex, you can watch this. But I really suggest you try the puzzle first. And then after you do the puzzle, then you can watch the VOD of me doing it. It started about half an hour ago. It was really a nice breeze. I'll be right back. Welcome back, everyone. I see people talking about making Sudoku where when you solve the Sudoku, you make a pretty picture, and I can confirm that is a nightmare from the time I did it for my anniversary puzzle, which is probably the most time-consuming puzzle I've ever set. Um, but we have more puzzles. I have no reason to suspect that this puzzle will take 3 hours. Um, but it does look gorgeous, and I have a hard time saying no to puzzles that have Renban and X's. There's even a V here and there. Uh, so, anyway, this is Franz by JoWovrin. Uh, See, I have the advantage over Ranks of doing 8 hour streams that I don't have to do anything anytime in the near future. Like if I had a job that I had to go to tomorrow or whatever, that would be horrendous. And I kind of still can't believe that Ranks even like goes to work on Thursday and then comes home and streams. I think I would go crazy. Uh, Yeah, I mean, you can definitely tell from watching these streams what sorts of puzzles I will gravitate towards. Uh, don't put set in the title. That is another hint. Although sometimes you will put set in the title and then I won't notice and then I will be grumpy, which may have happened yesterday. Um, but that's okay. So, uh, I don't think there's any surprise rules here. These cells sum to 5. These cells sum to 10. These numbers form a consecutive sequence in any order. And these digits are the same digit. Well, not all 4 of them, but these 2 are the same, and these 2 are the same. Really, line constraints in general I find really enticing because they incline me towards geometry. So, here's the fun question. We're obviously going to color this puzzle. How are we going to color this puzzle? Because there's about 6 different ways that I can think of that we might want to color this. Because I might want to color the types of X. I might want to color high, low. Yeah, types of X was my inclination as well. So color individual cells. I like the color individual cells theory. Uh, okay, so uh, this V is going to be purple, and any X that makes, or any high digit that makes an X with a purple V is going to get purple as well. And per Rank's suggestion, we can say those are low and this is high with a splash. So this is the not blue. This is the not blue V. So this is the yellow V. These are, of course, low. Now, this X sees all of the purple V digits, so this has got to be a yellow X. And because both of the blue yellow digits are in this box, this must be a blue yellow digit. Oops. And so this is an orange yellow digit. Row 8, column 2. Oh, let's see. A different color than purple. Are you saying you don't like the choice of purple, or are you saying... right, column... oh, you're looking at these. So, yeah, I currently am like really leaning into multicoloring for the moment. We'll see. I try really hard to avoid using red and green because I know it totally gets a lot of people who are have trouble with color. I know that there's no combination of colors which is going to work for everyone, but I know that red and green are particularly bad. Now, one thing I do know is that Sven was working at one point on really carefully choosing the colors for this app so that no matter what sort of color blindness you had, these colors were different hues or different intensities or whatever, so they would still show up differently. But I think that has not been done yet. So yeah, we can do a different one. We can do, instead of purple, we can do green. Green and yellow, I think, is fine, right? Uh, and yeah, the Ransk is completely right that there's actually an extra dimension of coloring this, which is the odd even dimension we're not yet coloring, but may soon be coloring. Uh, let's see. And for example, this digit and this digit are the same. That is the extra layer. Uh, so that digit's down here somewhere. Did I see your point about the Renbans? Uh, oh, a Renban forces all 4 flavors of X. Oh yeah, okay, so that's interesting. Okay, yeah, the sorry, I read it, but I didn't have time to really parse it. But the point is, there's no there's no 5 on this Renban, and there's no 5 on this Renban. And so if there's no 5 on this Renban, that means it's either 1, 2, 3, 4, or it is 6, 7, 8, 9. So probably there's one of each. Let's see, these two are the same. So yeah, these are all the same high-lowity, as we like to say on the stream. And so these are all the same high-lowity. See. I'm trying to see if there's like some place that obviously sees something that will make my life easier. Uh, but I don't yet see anything. Excuse me. Yeah, I think these are definitely different. Should I maybe start by coloring the palindrome? Okay, so we're going to try coloring this a completely different way. So these are the different flavors of X, as has been pointed out. So, of course, these digits, that digit's blue, that digit's green. So that digit's green, that digit's blue. Okay, I think this definitely looks like it is going to turn out that Ransk was correct about what we were supposed to do with this puzzle. Okay, this is yellow or green, and this is yellow or green, because both of these X's look down at both blue and purple. So this is a yellow-green pair of X's, a phrase that you don't hear that often. And so this is a blue-purple pair of X's. This is, again, yellow or green. because it sees, this cell sees all the blue and purple cells. And it's, of course, a different yellow-green than that yellow-green. Let's see. And this is, by the same logic, this is purple-blue. And it's a different purple-blue than that purple-blue. So Tristan says row 4, column 9. No, row 4, column 9. It has to be green? I'm not sure I see why that has to be green. Oh, yeah, okay, sorry. These two digits are the same. And so where does this digit go in box 6? Tristan is, of course, right? That is green. It's the same digit as this digit. So this X is not green, and it's not this blurple, but it might be that blurple. Let's see. Row 5 tells me the order of blue-purple X's in box 6. Row 5. Okay, so I want to think about, where does blue go? I'm not quite sure. Okay, so I will continue contemplating that. Where does blue go in row 5? Not here. And not there. So yeah, okay, so blue in row 5 only has there and this as places, but there are 2 of them. So that's blue. Okay, very good spot, and very good ranks for explaining it in a way that a Zeta who just did Carousel can understand. Let's see. So the blue down here. Oh, interesting. Okay, this cell has to be blue, because this has a low digit on it, and that low digit is not one of these 2. So the low digit is on this V, but it's not that one, so it's that one. So that's pretty cool. So I can place the last blue in row 4. Ah, yes, I can. Excellent. Good point, Brian. That is a blue. So this blue is that blue. Yeah, so now we can start coloring high-lows of blues. Sure, why not? Although I realize now that by making this blue, I have made coloring for high-low difficult. I'm going to try something wild and try the suggestion from chat that we use the pen tool to color high and low. So O's are going to be low. X will be high. No possible confusion there at all. So that'll be high, low, high. Let's see. Okay, so Tristan is highlighting row 8, 9, column 9. No, row 8. This sees blue and purple and green, so it must be yellow. Excellent. So this sees a blue cell, a green cell, and a purple cell. So this is yellow. I agree. So that makes this green. Hi, and Penguin. Have good sushi. Sushi is a wonderful, wonderful thing to have all the time. So column 5. Oh, this green. No, that's not true. I was going to say this green has to go here in this box, but that's not true. Okay, this domino, where does it go in box 8? Oh, well, never mind. This just isn't green because it sees a green cell. I was going to give a very convoluted explanation, but I don't need a convoluted explanation. That's fine. Good night, Alex. Okay, so now this is the last green digit. Just by Sudoku. There's the blue digits. Where is yellow in box 8? This cell has to be here. Good catch, Barbie, I think. Have fun with Rocky. Don't let him wear you out too badly, Rangsk. Let's see. Color the X pair in box 7. Oh, okay. So this is, yeah, this is not blue. It's not green. It's not yellow. So it is purple. Okay, so there's a purple over is up here somewhere. There's one more blue in column 6. It's very helpful. I can finish coloring row 4. I still need a yellow, which has to go here. And then I need a 5, which can go there. And it could be gray, unless Casey is around. Let's see. And so that's a purple. Let's see. So I need an extra yellow. And an extra purple. I don't think I know which way they go as of yet. Row 5, column 8 can be placed in box 9. Good point, Barbie. So that is blue. I see. So we have Casey's permission to use gray for 5 because we're already using other colors for other things. Okay. As long as you're okay with it. 2 of the 3 corners in this box are yellow, but I don't know which 2 as of yet. Let's see. Blue. Yeah, 2 of these 3 cells are blue. But this cell, whatever it is, it's there. So that's a blue. And it's low. Oops. blue in box 9 is low. Well, one of these is the low blue in box 9, but I don't know which of them it is. Ah, yes, I know that this is high. Ah, so that's going to be nice, because that's going to tell me that those are low, so these are high. Row 9, column 7. I no longer have any idea what we're talking about in row 9, column 7. Get a high blue. Yeah, so now that we have the highs, yeah, so this Renban is high. So that is a good point, Listesh. All of these are, yes, it really was Listesh this time, sorry. All of these are high, because as soon as one of these is high, they're all high. And so now we can start doing Sudoku not just on blue, but on high blue and low blue. And so now the high blue in this box goes here, just by Sudoku. Where is the high blue in row 9? Ah, it has to be there. Yep, it is tic-tac-toe today. I'm hoping that this is going to be a puzzle where we're going to color basically the whole grid before we do anything else, because otherwise I think writing numbers on top of these is going to be horrible. But for now, I think this is a lot better than double coloring with 4 colors. One moment, I'm going to slide my chair. Somewhat successfully. Okay. So yeah, so now we can percolate. That's a low, that's a low, that's a low. So now because this is low, that's high. Because this is low, that's high. Because this is a palindrome, that's low and that's high. So that's high. Okay. Row 5, column 8 is low. Ah, yes. Okay, and that's huge. Okay, so Listesh notes this is low because it sees that blue, and that's huge because it means the whole Renban's low. This then gives us lots more of these things to play with. Okay, so now let's do some more Sudoku with colors and see if we can get anything. Let's see. Purple X goes here. Just by Sudoku. Let's see. I need a yellow. No. Oh, I need a. Yeah. So this is purple. This is purple low. Or purple circle, if you prefer. And so this now is a 5 because I need to put a 5 in the box somewhere. And hence is grade. So now purple low gets placed here. Oops. By, again, Sudoku. This has got to be a right in. This is yellow low. So now yellow low is placed here. So this is now yellow high. So this is now yellow low. Oops. I put an X on the X. like that. Okay, so now we know the color of this cell, because now it's not yellow low, blue low, or purple low, so it's green low. And so this is yellow low. And so now yellow low is placed here in this box. So yellow low is now placed in box 8 there exactly. And so that is going to place a 5 here. And a 5 here. Oops, not that kind of 5. That kind of 5. The gray flavor. Okay, BremSter. Sorry, not BremSter. I had no idea how I misread Listchesh's BremSter. You asked where the yellow high in column 1 is, and it can only go there. So those are both high. So that's the 5 for column 1. No, it's not. That was a lie. That is the green high for column 1. Let's see. Green high in this box goes here. Oops. So this is the green low. This is the green high. This is the green low. Let's see. So that's gray. So that's the 5. Oops. And is gray. Let's see. Yellow low is here. Let's see. Blue X is here. Let's see. Let's see. Where is green low? Oh, it's in one of those two places I don't know yet. Let's see. Oh, yes. This was a naked single, so it's a green X, which is going to place the green X up here in this box there, which is... Okay, what's left? It's only highs in this column. So I need a purple X, but I don't know where it goes. I need a 5, but I don't know where it goes. I need a yellow X, but I don't know where it goes. Let's see, row 3, column 2. Oh yeah, this is a naked single, so I should have been able to fill that one in. Excuse me. This is a low green. Good catch, Ben. So yeah, we've got a low green up there somewhere. Okay, so this, yes, okay, beautiful, beautiful catch, Barbie. This sees all the lows. And so the question is, what is this Renban? Well, it has a low on it, and it has a none low on it. So it has to have a 5 on it, and that 5 can only go there. So that was a beautiful spot. So let's see, does that let us do anything else fancy with 5s? I fear not. Let's see. Let's see. Okay, what do we have left in this column? We need a purple X in this column. It has to go there. We need a no, not a green X. We've got 2 greens, 2 blues. Oh, we need a yellow X, and it has to go there. So let's see, what is missing here? We need a 5 and a purple circle. That's not helpful. Here we need a green circle and a 5. That's not helpful. See. I may have to go ahead and actually resolve what these numbers are, but I like to wait until the end, if I possibly can, to resolve what all the numbers are in these sorts of coloring puzzles. But I may be stuck. So yellow and blue are over here. So yellow and blue are over here, but they're also here, which tells us that they're consecutive. And so yellow and blue are a 2-3 pair. Which tells us that this is a 7-8 pair. Let's see. So this now is a yellow on a Renban with a 5. So yellow has to be 3, and this has to be a 4. So that's a 3, that's a 2. That 2 is telling me that's an 8, and that's a 7. Did I do something wrong? I don't think so. I could have. Who knows? I often do. So this is a 1-4 pair. Okay. So now we can do more with the Xing. This is a 1-4 pair. So this 4 is either a low green or a low purple, but it is not a low green. So it is a low purple by this coloring. And so this is the 4. That's the 1. That's the 6. And so now we can go ahead and grab all. So let's try and fill in all of these things before we get rid of the pencil marks. Maybe we won't be able to get rid of the pencil marks. Those are all 3s. These are all 7s. Okay, these are all 6s. These are all 4s. Let's see, low blues are 2. High blues are 8. Yeah, it's impossible I won't be able to delete all of the pencil marks, but I think we can finish it like this. Let's see. So these are 1s. I believe in us. So these are 9s. Yeah, so let's see. Will it delete the pencil tool stuff if I hit select all? Oh, you can't even hit select all in the pencil tool. Interesting. So I don't think there is a delete all for the pencil tool. So I think the only way out is through, so we're just going to have to just keep doing it. So that's a low. So this is the low 4. So that's the 5 is gray. So that's the 5 and is gray. What happens if you turn the pen tool off? Now, there's an interesting question. What I expected would happen, but it was worth trying. This is a green, and it's low. So that's a 1. Okay. What is this now? Oh, this I needed to fill in. It didn't actually fill it in. Oh, I saw someone saying that I missed a 2. Well, don't worry. It'll be over soon. Okay, the purple 6. Oh, it does work with select all? Okay, interesting. Ah! Thank you, Ben. That I would not have thought to try that, but you are right. Okay, so that is done. Okay, so Ben is the hero of the chat. Let's see. So where else can we start placing things? Yellow 7. Let's see. Okay, there's a 5. Oh, no, there's not a 5 up here. What is up here? Oh, I need a blue 2. So that's a 2 and is blue. And what is this? I should be able to figure it out. That is a purple 6. So now what are these 2 cells? A yellow 7, which I cannot place, I do not think, and a green 1, which I can place. I mean, I think it worked well. I actually thought it was quite efficient using the pen tool in that way to sort of do that rather than doing like coloring in 4 different colors with a splash to then indicate high and low. I guess I could have used like light gray and dark gray, maybe. But it was worth trying. I don't regret it. 3, 7. Okay, so these are both purple. And I don't know the order. These are... there's a blue 2 in here, so the blue 2 is there. So that's the purple 6. Yeah, I'm happy with complicated coloring schemes, but I generally want to make it a little easier than that. So that's a 4, that's a 6. Both are purple. Let's see. And so what colors are these going to be? This is going to be... Oh, you could use pencil marks. That's an idea, Listesh. Did not occur to me. This is yellow. This is purple. So that's a 4, and that's a 7. Hooray! That was a lovely puzzle, Joe. I really enjoyed that one. I'm going to go refill my drink. I will be right back. And we're back. More Renban goodness. This time our Renban goodness also features black Kropke dots. So this is Secret Passage by J.C. Godart. So just like the previous one, these Renban lines just mean that these are consecutive sequence of digits in any order. And the black dots mean there's a ratio of 1 to 2. Not all dots are given, so no negative constraint. And we've got an irregular grid, so you can imagine how well that will go based on if you saw yesterday's irregular puzzle. And you can wave at Tristan in the background. And then we can get started here somewhere, maybe, possibly. I say we can get started, but I don't actually know where we're supposed to get started. Let's see. So often with Renban, the trick is to ask where the digit on the Renban is supposed to go. But I don't see any places where that's especially useful here. Let's see, are there any long lines of Kropke dots that I'm missing? So excuse me. This digit goes here, I am noticing. Let's see. People are suggesting the law of leftovers in columns 6 and 7. Yes, the lesson is don't do puzzles that don't have Renban in them. What's the point? I don't think I quite see... Okay, so I think maybe people are saying take all of these columns. Okay, so the way this works is that often you say, okay, this is a total of 4 regions worth of digits, and then I'm just going to remove 3 regions from it. Like that. And so this is a total of 1 region's worth of digits. And so we're learning that this collection is a set of the digits 1 through 9. Which I do not find immediately useful. Let's see. So Insanity Cat, because the Sudoku community is widely populated by felines, suggests these. So that all goes away. So these 2 digits... oh, that's columns. Oh, you can do it with rows, too. Haha. Whoever thought of that. Okay. Rows. Take 2. So rows 1, 2, and 3. So these are a set of the digits from 1 to 9. And what I suppose this is telling me that's interesting is that these 2 cells are these 2 cells. And so these 2 cells Renban each other. Unfortunately, that they could still be 3, 6, but they can't have an 8 in them. So these are from 1, 2, 3, 4, 6. That is one conclusion of this. So we can't have an 8. And so that comes back to tell us that these can't have an 8. So that is fairly interesting. Let's see. And it does give us 2 Kropke dots in the same region, which is very interesting. So let's see. Do we get a similar thing if we try and do it now with these columns? Because I would love to have a 3rd Kropke dot in this. So that's 3. Pull out those. And so that's going to tell us... Oh, now that's interesting. Okay, so that might be the magic one, because that gives us a virtual string of 3 Kropke dots. Because these 2 digits are the same as these 2 digits. So these 2 Kropke each other, but this digit also Kropkes that digit. And that digit is different than these. So that tells us that these are all from 1, 2, 4, 8. Oops. Ah! Take 2. This is the one that's in the middle, because this Kropke's 2 different digits. So this is a 2 or a 4. If you're curious, by the way, where on earth this came from, this is from understanding the structure of the black dot relationship. So really, you should think of there being 2 strings of black dots. There's the very short string 3, 6, and that's it, because you can't get anywhere from 3 and 6 other than 3 and 6. And then there's a long string 1, 2, 4, 8, and you can be anywhere along that string, and so you can slide up and down a bit. And so if there's 3 different digits that you can put in this sort of Kropke row, then it tells you for sure that that you're coming from 1, 2, 4, 8. Now, here's an interesting thing. I know that there are for sure a 2 and a 4 in a string of 3 Kropke dots. And so there's no 2 and 4 here in this, which I de-yellowed it, but I didn't need to. Now, these 2 Kropke each other, and so they can't have a 1 anymore. And so that tells us that this is a 3, 6. And so the fact that those are a 3, 6 tells us that these are a 4, 5. And now we know more, because now that being a 4, 5 tells me that that's a 2. And so the digits that 2 Kropkes are 1 and 4, but this can't be a 4, so that's a 1. And so that's the 4. And so this is a 1, 2 pair. So that was gorgeous, to say the least. And so now this is a 3, 6 pair as well. I should go ahead and say. Okay, and so now all my coloring can go away because it's no longer useful. So we've got all of that stuff, which is pretty awesome. Okay, now this dot is forced because it looks at a 3, 6. And so it can't be 3, 6. And so, I had 2 and 4 in this column to indicate that I knew I had a 2 and 4 looking at this string. It's because, John, we showed earlier by using some magic irregular geometry that these 2 digits and these 2 digits were the same pair of digits. And so because of that, these 2 had an invisible Kropke dot between them. Why both? Both because any string of 3 Kropke dots has a 2 and a 4 in it. And this was a string of 3 Kropke dots. Yeah, it's this weird sort of secret third digit of the Kropke dot thing, which is sweet. Now, because there's a 4 in this region, this is a 1-2 pair. And by the way, this is just an absolutely gorgeous puzzle, and I've never seen anything like this idea before, but it's very cool. So that's a 1-2 pair, just because it can't be 3-6, and there's a 4 in the box. Okay, so now the 3 is placed in this box of all things, because I can't put a... oh, no, it's not quite placed. The 3's in one of these 2 places. Because I can't put the 3 on this Renban anymore. And I can't put the 3 there. Okay. Ooh, up to 31. That's a new record for the channel. Okay, so let's write in what these are, just because there's so much going on. I'm going to lose track if I don't. Let's see. 1, 2, 3, 4. We need a 5. We don't need a 6. We need a 7, 8, and 9. Okay. Row 5, column 8. Oh, 3 can absolutely go there. I just made that up. Don't mind me. Okay, I know that these are from 1, 2, 4, 8 because there's a 3, 6 pair in the in this thing. So I actually have 3 1, 2, 4, 8s in this column. And there can't be a 1 on this Kropke pair, on this Kropke thing, because of that. So there's definitely a 4 here. So that means there's definitely a 4 in this column down here in one of those 2 cells. Do the bottom 3 rows. Okay, so people are encouraging me to look at the bottom 3 rows. I have a guess as to what this is going to tell me, but let's find out. This is 3 sets of the digits 1 through 9, 2 sets of the digits 1 through 9, 1 set of the digits 1 through 9. And so now these 2 fill out this region. So these 2 are the same as these 2. And so as you might expect, these turn out to Kropke each other. So these are from 4 to 8. Let's see. I'm hearing it must be a 4, 8. It sees a 2. Oh, yes, it sees a 2. Thank you, thank you. I had already completely forgotten that I was looking over here. So that's an 8. Even better. And so these can be decolored. Okay, so this string of 3 digits now can't contain a 4 or an 8. So it could be 5, 6, 7. Except it can't be 5, 6, 7 because there's a 5 in the box. So it's the only other option, which is that it's 1, 2, 3. And that's the 3. Okay. This isn't an 8 anymore for myriad reasons. Let's see. 3 in box 6. 3 in box 6. Okay, so that's not a 3. And so now 3 does in fact go in the place that I said it couldn't before. So thank you, chat, as always, for catching my random errors. So 3 now has to go over in this column somewhere. I don't know where exactly. Let's see. I can place another 3. How mysterious. Let's see. I can certainly write that these are 6, 7, 8, 9. Oh, I got it. Okay. I was thinking like I'm gonna be really impressed with wherever this 3 is coming from, but okay. Sadly, 4-8 doesn't quite look at this whole Renban. It sees all but one of the digits of this Renban. Oh, which is interesting because every length 4 Renban has to have a 4 or an 8 on it, which tells me that this digit has to be 4-8. So if I try and make a length 4 Renban without using a 4 or an 8, I have to choose between 1, 2, 3 and a made-up number, or 6 or 5, 6, 7 and a made-up number, or 9 and 3 made-up numbers. So this digit, being the only one that doesn't see the 4-8 pair, has to be itself a 4-8. That's sweet, which means that this is a 2, a 4, and 8 itself. There's definitely a 4 on here, though, which is going to place the 4 over here. So row 6, column 8 equals 6. Row 6, column 8 is a 6. Let's see. So my 6 is in one of these two places in this region. And if I lock a 6 off the Renban, does it make it impossible to finish? Oh yeah, totally would make it, because if I need an even number on this Renban, and 6 is the only even number available. So that is a 6. So this is a 5 or a 7. This is a 5, 7, or 9, just for the posterity. That's a 5, 7, or 9 too. Okay. So this is quite restricted. Can't get down to 4. Which means it always has a 7 on it. That's not incredibly useful as these things go, but hey, it's true. Let's see. Let's see, what's included here? So we definitely need a 3, a 4, a 5 in this area. That one's not the 5. But that aligns these 4s, which tells me that there's no 4 over here. So there is a 4 up here somewhere. I guess I could have just asked where the 4 in row 1 was, and I could have gotten the same answer. No, I don't know if there's an 8 here or not. Same is true of 3s. 3's a line, which pushes a 3 up here as well, which, again, I could have gotten by asking that. Now, there's no way the 3 goes on a Renban line with a 6 of length 3. 3, 4, 5, 6, that's too many. So these aren't 3. That's also not 3, because there's a 3, 6 looking at it. So one of these two is 3. The only way one of these is 4 is if this reads exactly 4, 5, 6. Is there a reason it can't read 4, 5, 6? None that I can see off the top of my head. Let's see. That's not immediately helpful. I am. I've got another couple hours in me. Then we'll call it we'll call it after that. Okay, 4 and oh yeah, one of these is a 4. Never mind. Renban in box 4 is very restricted. Is it? Yeah, the one from box 2 to box 5 looks very restricted. Let's see. So this one, that cell sees a 3 and a 6. These cells both see a 3, but even okay. So there can't be a 3 on it. That's true. Okay. I now see that these cells see a 3 directly, and then this sees a 3 in this weird sort of way. So this is at least bigger than 3. But it could still have... It still could, looks like to me, be 4, 5, 6... Oh, wait, no, it can't... Oh, okay, interesting. So this cell could a priori be 4 or 6. However, I can't put both a 4 and a 6. Wait, no, I can put a 4 down here, can't I? Never mind. So Ranksk is asking me to look at the first 3 columns again. Minus... so that is going to tell me that these two are the same. They can be green this time. And people think this is going to be helpful. I am told. This cell doesn't have a lot of candidates left. That's probably worth writing down, because this can't be 2, 4, 8, 3, or 6. So this cell is only from gray 1, 5, 7, 9. Now, there's no possible universe that this could be a 1, owing to Ranksk's observation here. Because if this tries to be a 1, now I'm putting a 1 on a length 3 Renban with a 6. That's not going to work well. So this is a 5, 7, or a 9. Okay, so... So I know which cell is which. Ah, right. Okay. Got it. Okay, so, yeah, so one of these is a 5, 7, 9, which can't go on a black dot. So that is a 5, 7, or a 9. So this is a 4 or an 8. So this is not a 3. It is a 2, 4, or an 8. But it's not a 2, because there's a 2 in the box. So this is itself a 4, 8, which says that this is a 2, which says that that's a 4, which says that this is 4, 5, 6. Beautiful. And just for you, chat, I'll fill in that digit instead of leaving it blank. Yeah, that was very nice. This is a great puzzle. Let's see. These aren't 6 or 8 anymore. They're a 7-9 pair. There needs to be a 5 in here, and it can only go there. Okay, then these are a 3-4 pair to finish off the box. Let's see. This 8 is looking over here and saying that's not an 8. Let's see. Oh, this 6, 7, 9 is looking down and saying this is not a 6, a 7, or a 9, so it is an 8. That's pretty cool. So that's not an 8, because it's on a Renban with an 8. So the 8 in this box is placed. It can only go there. And so because this 8 was locked into this spot... Wait, no, I did that wrong. Because this could still be the 8. The 8 in this box is locked into one of 2 cells. So one of these 2 is an 8, but I don't know which one yet. So now we can look at what happens with this. So this is a 3 or a 4. And either way, this Renban needs a 4. But it can't get the 4 there. Okay, just to go over that. If this is a 4, this Renban has a 4 on it. If this is a 3, this Renban needs a 4 on it to connect the 3 and the 5. But the 4 can't go there, so the 4 goes there. And so this is 3 or 6, and it's not 3, so it's 6. That's a 3, that's a 6, that's a 3. This 4 is placing a 4 over here, which is going to make this a 2 or an 8. Don't know which yet. This is not a 5. Oops, not a 5. Let's see. So now 5 is placed here, likewise, I think set. Just by Sudoku, nothing fancy or untoward. Let's see. Oh, this 2 is looking up and giving me that that's a 1 and that's a 2. Okay, this 5, 4 is telling me that these are, let's see. Could be 2, 3, or 6, 7. That one's not a 7 because there's a 7 in the row. This one's not a 2. So that's maybe not the most useful, but I'm keeping it in mind. These aren't 4 anymore. 3 in row 3. Where does it go? Oh, no, there's already a 3 in row 3. Never mind. 3 in row 3 goes here, as it would happen. 3 in this box goes one of these 2 places. I don't know which. See, in fact, I'm going to just fill in the rest of this column because there probably is something laying around. 3, 4, 5, 6, 7, 8, 9. Well, that's not a 7. That could be a 7. That's not a 3. Not as useful as I could have hoped, but what can you do? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nada in here. Let's see. Row 6, column 3 is a 5. That's all yours, huh? The desperate let's fill in some cells and see what happens. I mean, every once in a while you do it and it's just like, oh wow, those things were way more restricted than I thought they were. But then sometimes you do it and it's like, really? Nothing? I get nothing? I don't even get to like pretend I'm busy for a bit? Uh okay. I am told this is a 5. Uh let's see. Okay. Well, what about when there's 4 cells left? If there's 4 cells left, does it still violate your trademark? Uh, okay, it's not 9 because the 9 here is locked into this, so that's not 9. Oops. Where does 5 go in row 6? Any of these places, as far as I can tell. Oh! Yes, there we go. The invisible 5 is telling us that that's actually a 7. 5, 9, so that's a 7. So that's a 9. I don't know why this 5 was impossible to see, but this 5 was impossible to see. So that's not the 7, so that means because this needs a 7, it's there. So this is a 6 or a 9. Let's see. But oh, there's a 9 looking down here, so that's a 3. That's a 7. Let's see. So what's left here? We still need a 1, which has to go there. 2, 3. Yeah, it's got to be 6 and 9 that are left, right? Oops. Yeah, I think the Renban lines are slightly overpowering. I'm not quite sure exactly what to do with it. I think it's because they make the digits show up in this blue rather than a nicer color that's a little more overstated. Yes. Tony, welcome, Tony, by the way, notes that this 7 looks over here. I think Tony's been here a lot of the day, but notes that, yes, I did not see that the 7 looked over here, and so saw that. Let's see. So these are 4, 5, 6, 7, 8, 9. Let's see. I am told this has to be a 7, 8, 9 Renban. Okay, so that's not 4 or 5. That's not 4 or 5. I don't see why this cell can't be the 4 or the 5. I'll get there, I suspect. Let's see. One cell sees 4, 5, 6, 7. Yeah, so yeah, that's a good idea. Let's write in the candidates for this. It sees 1, 2, 3, 4, 5, 6, 7. So this can only possibly be an 8 or a 9. And now there does have to be a 7 on it. It can only go there. So this can't be a 6 either. And so this is an 8, 9 pair. So yeah, that was, I think, the way for zetas to see that, at least, was to note that this cell was super restricted because it was looking at a sched zillion digits and then right in its candidates. So neither of these is a 7. That one's not a 3 anymore. Let's see. Have I eliminated anything else from this cell? I don't think I have. Let's see. So those aren't 7s anymore. So where is the 7 going in this row? It's only going there. Which makes that a 9. Makes that an 8. Makes that a 2, a 1, a 2. Let's see. This is not a 7 or an 8. It is a 5 or a 9. I don't think I know which one it is yet. So let's see what's left in this box up here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's not a 7. That's not a 7, so that is the 7. And that's not a 1, so it's the 9, and that's the 1. Let's see. That's a 6. Let's see. What are these digits? These digits are a 1 and a 2, 4 and a 5. So this is not a 1 or a 2. That is only a 4 or 5, which is going to finish that 4 or 5 pair, but that's not exciting. Let's see. Oh, there is 1 digit here. I probably should fill that in. 2, 3, 4, 5, 6, 7, 8, 9. So that's a 6. That's a 9. That being a 6 means that's a 3. That being a 3 does not actually tell me what that is. But this being a 6-9 pair does tell me what that is. And tells me that this is a 3. Let's see. So that's a 5. Owing to that, that's a 9. That's a 5. Let's see. What are the last 2 digits in this column? 4, 5. Let's see. We need a 6 and an 8. So 6 is there, 8 is there. Last digit in this row is a 7. Last 2 digits in this row are a 1 and a 5. Goes like that. Let's see. Okay, so that 5 fixes that 4 and 5 and 4. And this 4 sees this 4, 8. This 1 and 5 here sees that that's a 2. So those aren't 2 anymore. Let's see. We have an 8 and a 9 to finish the column. But that's an 8. That's a 9. That's an 8. Let's see. And what are these cells so that we can completely pencil mark the grid? They are a 1, a 2, and a 3. Except this one is not a 2 or a 3. So it's a 1. So that's the 9. This 1 sees over, that's a 2. That's a 1. This is a 3. That 1 sees that's a 5. That's a 1. That 9 sees that's a 6. That's a 9. And this is a 2. Very nice puzzle. Yeah, that was a really original puzzle. I haven't seen something like that, but I quite enjoyed that one. Let's see. Up next, let's do another puzzle that I was warned in advance would be difficult, but let's do it anyway. So this is an ambiguity puzzle, I think. This is by Playmaker, by the way, who's in the chat, so everyone wave to Playmaker. So in this puzzle, we have all of these lines, and we don't know what the lines are, but there's a few options for what the lines could be. The lines could be Renban, which you should be very familiar with. So it is possible that this line goes 4, 5, 6 like that. Probably not, though. There is also the parity confetti flavor, which means that all the digits on the line, A, don't repeat, and B, have the same parity. So we could make that a 6 and that an 8, for example. And then the other option is German Whisper, which means that along the line, the digits differ by at least 5. Okay. Oh, and the brown lines are just also lines, but they're just to make it clear what goes where. Okay, so this can't be a German Whispers line. So it is either a Renban or it is a parity. Okay, so the way I'm going to color this is going to be purple for Renban, yellow for, green for German Whispers, and yellow for Parody Party. So this one certainly is not a German Whispers line, because if it was, I would need to put a 9 in 2 places. So it is either a Parody Party or a Renban. Okay. Now, this one can never be a Parody Party line, because if it was a Parody Party line, it would need to have 5 odds on it, and it can't. So this is a Renban, which... Oh, sorry. This also is not a Renban, I should say, because... this is also not a Renban, because if it were a length 5 Renban, it would have to have a 5 on it. So this is a Whispers line. That's the only option for it. Some people are telling me I didn't read the rules right. Parody Party, the digits have to have the same parity. Okay, and they have to form a consecutive list. It's basically a Renban with difference 2. So I could, on a Parody Party line, sorry, I was thinking I could just do that, but I can't. But I can do that, right? This is a valid Parody Party line? I'm pretty sure. I don't think they have to be... It says in consecutive. I don't think it says they have to be in order. Okay. This is not a Renban. And it's not a Renban because if it was a Renban, the digits on it would be 2, 3, 4, which would eat up a total of 3 low digits from the box. And I definitely can't have a German Whispers with 1 low digit and 4 high digits. So this is a Parody Party line. So those are not... Sorry. Okay, so here's our Parody Party. So these are even, and they are from 2, 6, 8. But it actually could go either way, I think. But I probably, if I think about this German Whispers, can convince myself that that's not true. So because of that, there's only... Yeah, so what are my low digits? My low digits left in the box... Oh, wait. Sorry, no, that's nonsense. I definitely use a 6, though. Which is a little bit unfortunate, because 6 is the digit I would like to be on here. 1, 2, 3, 4, 5. Okay, this is 5 long, and C's a 5, so it's not a Renban. So this is either a whispers line or a parody party line. Do I know which one? Let's see. And yeah, Chad is pointing out, and I was going to get here. This has a 5 on it. Okay, so yeah, this is definitely a Renban, because it has a 5 on it, so it's not a German whispers line. And there aren't 7 digits of the same parity in the box, so it has to be a Renban, which means that these here are from 1289. Which sure looks German whispersy as a start to a line. Oh, these can't be, never mind. These can't, for the same exact reason I said for this one, they can't possibly be a parody party line because they would have to all be odd, and there's a 5 in the row. Never mind, never mind. But these are 1289, that I stand by. Okay. Has to be a 5 in this column somewhere. And whichever one it is, it's not on a... That's probably a good idea, actually. Ranks has a good suggestion, which is instead of using yellow for parody party, use blue and orange for parody party, based on whether it is even or odd. So I know that these are even, for example. Let's see. I don't think I know anything about this line yet. Why does this have to be 1-9? So, people in chat are seeing this, and I don't believe it, because the 6 in this row has to go... Oh, the 6 has to go there or there. Oh! Yes, yes. Okay. Thank you, chat. Because the other option... Sorry, my brain had not fully processed this. Okay, yeah. So the other option would be that this Renban was, say, 3, 4, 5, 6, 7, 8, 9, but that's going to be a big problem because that's going to leave me a 1, 2 here, and I definitely cannot put a 1, 2 here. So, in fact, actually, I agree with chat after some contemplation and coercion that yes, this has to be a 1, 9 pair. Which now actually places the 6 in the row. So this is our first digit. That has to be the 6. Digit dance. Because wait. No? Is it not really a digit? Oh, 6 could be in blue. Sorry. 6 is in blue because it's 4. 4 is the correct question. Sorry. 4. Not there. You knew what I meant. That's the 4. That's the 6. Because 4 and 6 can only go next to a 1 or a 9 on a German whispers. And they can't go there because it would have to go next to 2 1s and 9s. Okay. So better. Slightly. Hopefully, fingers crossed. We have restored normality. Hopefully. Okay, so we need a 3 and a 7 in this line. And you can only make a 3 or a 7 work if it's next to 2 things, if it's next to a 1, 9. So 3, 7 goes there, and 3, 7 goes here. And these are 1, 2, 8, 9. So that means that these are 2, 8. In some order. Let's see, column 1 now has a 4 and a 6. Okay, so that is an excellent point, Listesh. So now that 4 and 6 are lopped out, I can't make this a Renban. So this has to be either a really long parody party. In fact, it would be an odd parody party. Or another German Whispers. Okay, so we have a virtual 2-8 pair in this box now. And so the things left are a 1-9 and another 3-7. Oh, and the other 3-7... Oh, the other 3-7 has to go next to... The other 3-7 has to go next to a 2-8. No. The other 3-7 has to go at this end. Okay. All right, this has to be a 3-7. Hear me out. I need to put a 3-7 in this box somewhere. If I put the 3-7 here, it needs to live next to a 1-9 and a 2-8. But that's the 2-8 it wants to live next to. So this is a 3-7. Oops. Or a red-green. Take your pick. So this is a 1-9. Because the 2-8s are gone. Why can't row 2, column 9, row 2, column 9, be a 3-7? This couldn't be a 3-7 because it would have required... Wait, why couldn't that be a 3-7? Did I screw up? It's very possible I screwed up. Yeah, I think I agree. I think Jay is right. That this could have this Okay, now Chad is trying to convince me that I was right before. I have no idea if I was right or not. 3 and 7 have different high-lowity. Well, I mean, I'm not debating. I don't think anyone's arguing with me about box 1. I think people are arguing, why did I put this 3-7 here? I think box 1 is fine. Okay, so... But I think this 3-7 could be over here. So I think this is... Sorry, I think this is actually 2-8-3-7, and this is 2-8-3-7, I think. Yeah, but this I think was all fine. I couldn't put 2 3-7s over here. Yeah, I could not put 2 3-7s over here because I couldn't put them there and there. So yeah, I think. Well, row 2, column 3 does have to be a 3-7. I can't put 2 3-7s over here. There's no universe in which that happens. Are we questioning whether this is I feel like you have to put 2 3-7s in this row. There are 2 of them, and you can't put them both. You can't put them both on this line because the only place you could conceivably do it is here, and now your 3-7s are the same parity. Okay, so this now can't be a parity party line anymore because there are 2 2-8s in this box. So this is either a Whisper or a Renban. Now that would be a lot of whisper. But I don't think I can immediately rule out that this is a whisper, because I do have some 1/9s left in the box. Maybe, possibly. Okay. So... Oh wow, that is genius, Barbie. I am impressed with that observation. This always has a Barbie maybe saw this in a much smarter way than I was about to explain. Uh, but yeah, this has a 4 on it just by Sudoku. So let's see. So can this possibly be a whispers? If it's a whispers, it would go 4, 1, 9, 3, 7, 2, 8 would be fine. I think maybe possibly. Maybe this line breaks it. I don't think I know anything about high-lowness yet. Okay, so if this were... Okay, let's imagine if this is a Renban with a 4 on it and an 8 on it. That just doesn't work, right? Because 4 and 8 are too far apart. So the only way that this works as a Renban is if this is a 2 and it's got a 4, but then we've got to go 2, 3, 4. Yeah, I'm pretty convinced this can't be a whispers, but I'm now worried about the fact that I'm going to eat up all the lows from the box if I make this not a whispers. Let's see. Okay, so the... Okay, in column 1, the short can't be a Renban. Okay, and this is going to be... This is, I think, an observation where we have to think about both possibilities. Either this is eating all the rest of the odds. Oh, this can't be a parity party anymore because of this 3-7. This 3-7 is odd, so the only way this could have been a parity party is if it was a bunch of odd digits that were consecutive, but there aren't enough odd digits that are consecutive. So this just is a whisper. Without a 4 or a 6 on it. Well, while you're on your brother's laptop, go ahead and subscribe. On another account. Let's see. Okay, so now this... I can now argue, can this not be... Well, this definitely has a 5 on it now, because there's no other way. And so what can this be to have a 5 on it? Well, it can't be a Renban anymore, so this is a parity party, and it's an odd parity party. And so this is from 357. Okay. So that is very nice. Okay, so we've got a 357 triple. Yes, Listesh. I also read the rules and did not read that. And then, fortunately, chat was all talking about something about how they had to be consecutive, and I was going back to reread the rules. Despite making lots of puzzles with complicated rules, I really do not read rules very well. Let's see. 1, 2, 4, 6, 8, 9 is what's down here. Our frenemies from Carousel have returned. So we can look forward to their return. Okay. So can I squeeze? Yeah, this could be 4, 5, 6. So, okay, so we're back to trying to convince ourselves that this really can never be a Whispers line, which I really believe, uh, but I want to super convince myself. Okay, so if this is an 8, those are okay. So this has to do something with parity. Okay, so if this is an 8, then the 3, 7. Well, then the 3's around it. So this is a 7. And so this is a 9. Oh boy, this is confusing me. Okay, what's the easiest way to see this? Uh, yeah, let's make, instead of thinking about that, let's punt and go with Listesh's point that this definitely has a 5 on it. And so it is a odd parity party or a Renban. That's not Renban. That's Renban. There's no way that there's a 1 on the brown line in box 3. So if this is a 1, I agree. What if that's a 1? Why can't this be a 1? I would really like to prove this has to be a Renban. But I'm still confusing myself trying to prove it. Okay, so this is definitely not a 1, 2, 3, 4 Renban. Because if this is a 1, 2, 3, 4 Renban, then neither of these can be low, and then we've way broken the world. Let's see. If this is a so so there can't be a 1 on here if there can't be a 1 on here if it's a Renban. If it's a Whispers, then if I try and put a 1 on it, what happens? Okay, so I'm just going to try and write out what happens if this is a Whispers. So if this is a Whispers, that has to be the 4. Then this is the 9. That's an 8. And this is a... this is some other unspecified low digit. It is a something. Okay, but we've now forced this to be a 1. So this is an 8. Because it's the only thing it can be. This is a 7. And so this would have to be the 3. That's the 3. That's the 9. That's the 2. And so now it's supposed to surround the 8. Ah, okay, the 3 here. Ah, the 8 is now being surrounded by 3 2 3s. Gotcha, okay. So if this is an 8, okay, so here's the punchline. Let me try and communicate what on earth I was supposed to see here that I did not see. If this is an 8, these are 2 and 3. So the only digit that can possibly go here if this is an 8 is a 1. But if this is a 1, now that's a 9. Ah, now that's, okay, yes. So now that's a 9, but I need a 9 to go with the 4. Whew, okay. I see it now. Okay, yes. So the 4 is ultimately what breaks. Okay. The 4 with the 9, because I need a 9 in 2 places, and I can't have a 9 in 2 places. So it's not a whisper. Okay. So now it's got a 4 on it. Can it also have an 8 on it? No, because 4 and 8 are too far apart. 4, 5, 6, 7, 8. That's 5. That's too many. So this is a 2. So there is a 3 here. So that's going to come over and see that that's a 7. So that's a 1. Well, we already placed a 4 on here by Sudoku ranks, so it could not be 8, 7, 6, 5. That was how I knew it was not 8, 7, 6, 5. So yeah, so so this is an 8 or a 9. This is a 3. So this is an 8, 9 pair. So that's a 2. So there's a 2 down here. So I certainly need an 8 or a 9. Oh, I need an 8 or a 9 down here because I'm not putting an 8 or a 9 over here, and I need 2 8 9s in the row. So I'm putting an 8 or a 9 down here, but it's not a 9. So I'm putting an 8 down here, and this is a 9, and that's an 8. Yep, got there, Barbie. Let's see. So now 7 we've got. Okay, 6. There's no possible way I get to a 6 on here. Still too far away. 2, 3, 4, 5, 6. That's too many. So there is a 6 over here. So this is 2, 6, and 8. And so this has got to be 3, 4, 5, just because that's all that's left. I think some people were able to see that really easily in their heads, which definitely I was not. But good kudos to those people who saw that. So these aren't 2 or 3, they're 7 or 8. But that one, yeah, this has got to be the 1, and that's the 9. So there we go. Okay, so the triple up here is 3, 5, 7. Okay, so then these I'm just going to write in because I'm going to need them later, but I'm not going to need them now. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I think we've done all we can do over here for now without thinking more about other lines. Okay, so let's look at what that does down here. Yeah, there's a few options here for what this could be. I don't think this can be parity party anymore. Because if this is a parity party line, then we've got to go 5, and we can't go to 3, so we've got to go 5, 7, 9, but we can't. So this is a Renban. Uh, is it going to turn out this is the only parody party line in the puzzle? By the way, that's not 7. No one in chat saw that. I'm certain that's not 7. So we've got to go to at least 6 now because we can't go down to 3. So we've got to go 5. We could go to 4. And so there has to be a 6 on it. And so this is either going to be 5, 6, 7 or 4, 5, 6. So I can go ahead and write these 4, 5, 6, 7 if we want. Let's see. So that's quite interesting. One second. I'm going to take a quick break. I'll be right back. I've drunk a lot of grape-flavored Crystal Light. I'll be back in just a second. And back. This is a very cool puzzle, by the way. This has been very smooth so far. Let's see. So, yeah, so there's got to be a 1 in here somewhere and a 2. Okay, so that's helpful to note. So in this column, we need a 1 and a 2. And so what that means is this is not a 1 or a 2, so it's an 8 or a 9, and that fixes the German whisper. Like that. So that is gorgeous. So let's see. So I want to think about this line. It has a 1 or a 2 on it. I'm trying to decide if this has a 1 on it, can this possibly be a parody party? It definitely can't be a parody party if it has a 2. But I think it could go 1, 7, 9, or 9, 7, put it in the different order. Oh, no, it can't. It can't. Because if this, yeah, okay. So this cannot be parody party. Beautiful, beautiful. Okay, the setup of this is amazing. Just the geometry of this line. And it makes me think that this has to be intentional. So this digit, as Barbie points it out, sees this entire thing. So this can't be parity party. So this is either whispers or Renban, as all good lines are. Now, it also can't be Renban for exactly the same reason. Because the 3-5 sees the whole thing. And so a length 5 Renban with a 1 or a 2 on it would necessarily have a 3 and a 5 on it. So it is another whisper line. Now, one consequence of this is that these can't both be 1 and 2, because that would be very broken on a whisper. So this cell is a 1, 2. Okay, so yeah, this is 1, 2, and something high. Let's actually look at this. Yeah, so what is the something high it goes with? The something high it goes with is going to have to be a 7. So these are from 1, 2, 7. Because 7 is the only high digit that is allowed to exist in this column outside of here, because 6 is included here. So this is not a 7. So this is a 4, 5, 6 triple. Which, conveniently, those are all consecutive. So we'll note that. So now the question is, okay, so one of these is a 7. And so the 7 can't be here, because if this was a 7, I would need to put a 1, 2 here, and it can't be a 1 or a 2. So that's not the 7. So that's the 7. And so we'll go ahead and try and highlight every other term on this. So these are high. 6, oops. They're from 6, 7, 8, 9. These are low. It's from 1, 2, 3, 4. Okay, but I can do way, way, way better than that because it's next to a 7, so it can only be a 1 or a 2. This one's next to a 7, so it can't be a 7. This can't be a 9. Let's see. So we've got our 1, 2 pair here. That's also a 1, 2. So those two digits are the same digit. Whatever. Okay, so what's left in the box? We've got our 1, 2. We need a 4, a 6, an 8, and a 9. Okay. So let's see. Shall we play our game of proving that this can't be a parity party line somehow? It would have to have 1, 3, 5, 7, 9 on it. Is there one of those that obviously can't go on here? Oh, it's too long. It's 6 long. I miscounted the length of this over and over again. So this is again a Renban or a Whisper, because you can't have a length 6 parity party. Now, it being a Renban would be awfully tough because of this Renban, I think. Yeah, so this cell, this 4, 5, or 6, sees all but this cell. And so a 6-cell Renban would need to have 4, 5, and 6 on it. So this, if this is going to be a Renban, that digit goes here on this Renban. Oh, no. No. So, wait. Sorry, so this would not just be any old Renban. This would be a Renban with a 1 or a 2 on it. So this would go, for example, 1, 2, 3, 4, 5, 6 or something. It looks to me like it's just plausible that this could be a 5 or a 6 and go there, and then this could be 2, 3, 4, 5. So I think this can just be a Renban. I think it probably isn't, but I don't think I can prove that it can't be. Yeah, it looks to me like it just barely fits. But okay, so Barbie says this line has to be a Renban. Okay, so why can this not be a parity party? What happens if this is parity party? Then all of these digits have to be even. So this would go 2, 8. Oh, yep, that's a problem. The 4 is on it. That's the point. The 4 is on the sigma. And so this is definitely a Renban because it can't be parity party because the parity would have to be odd. So this has a 4 on it and a 5. Let's see. So it doesn't have a 9 on it, interestingly. So the 9 in this box has to be in one of these two cells only. Because I can't get from 4 to 9. So oh, why is it not a whispers? I think I didn't really think about that at all. So why is it not a whispers? It has to have a 4 on it somewhere. The 4 would have to go there or there. But as soon as the 4 goes there or there, it needs a 9 that would clash with this 9. So sorry, you're completely right. I didn't think about it at all. So you are completely right to ask. But as it happens, I was right. It's a Renban. Okay. Let's see. So, yeah, it can't have a 1 on it because then it would eat up both 1 and 2. So that means it has to have a 6 on it. List hash is all over this. So that means that's not a 6. That's a 7 or an 8. Now it can't have an 8 on it, of course, because then it would eat up both 7 and 8. So the 8 is in one of these 3 cells. Yeah, we already know it doesn't have a 9 on it. The 9s are pencil marked here. So the 9 is down here somewhere. We could pencil mark that as well if we want. So row 7, column 3 can't go in row 6, column 4. Wow. Beautiful spot. Okay. So we were holding on to the faintest hope that maybe this would turn out to be the good kind of line, a Renban. But it can't be, regrettably, because the only way that worked, because this is a length 6 line, it would need to have a 4, 5, and a 6 on it. This cell is a 4, 5, or 6, so the only place it could show up is there. But this can't be a 4, 5, or 6 anymore. So by sheer beauty, this is not a Renban. Okay, great spot, Carl. So this now is a Renban, so we can, sorry, this now is a Whispers. So these are from 1, 2, 3, 4. So in particular, that one's not a 9. These are from 6, 7, 8, 9. Take 2. These are from 6, 7, 8, 9. There we go. Let's see. This one can't be a 6 because it's in a box that's got a 6. This looks like it could be a 4. This one definitely can't be a 6, though, because it would put a 1 on both sides. This can't be a 4 because it would put a 9 on both sides. And that looks... Oh, this can't be a 1 because there's a 1 in the column. Oops. It's a 1 in the column looking at it. This can't be a 4 because there's a 4 in the column looking at it, which would have been a good thing to see. Once this can't be a 1 anymore, this can't be a 6 anymore. We have a 1, 2, 3 triple now in the row, which is interesting. Oh, yeah, okay, yep, good point. Listesh is completely correct. If this were a 7, the only things it could go with would be a 1 and a 2, but that's a problem because that's a 1, 2, so that's not a 7. So that's an 8, 9. That is a good spot. Oh, and T is pointing out that this 9 looks down and sees that that's an 8. So I can just write that in and not debate whether it could be a 7 or not. So let's see, that's not an 8. That's now a 7. So this isn't a 7. Let's see. Ah, yes. And so now because this is a 7, we know exactly what's on the Renban. Listesh is, again, all over it. Because remember we said there can't be a 1 on it, so it can only be 2, 3, 4, 5, 6. That's all that can be on this Renban. So this is a 1 now. So that's a 2, that's a 1. And now the things that are left off are an 8 and a 9. So this is also an 8 or a 9. So so this isn't a 6 anymore because it's now next to a 2. So this is an 8 or a 9. So that gives us an 8, 9 pair in the row, which is interesting. So there's definitely an 8 or a 9 on this somewhere. Let's see. Box 5 can't be 6, 8, 9. I'm not sure what we're talking about. Let's see. Row 7, column 4 is not a 1. Oh, yes, it is not a 1 for the reason that there is a 1 above it. So that gives us a 2, 3 pair. So good catch. Good catch, Carl. So that is now, this is a 1. So that's a 2. Let's see. I see an it has both 8 and 9, but I'm not sure what the it is that we're talking about. I'm confident we will find it. Box 4. Hey, Panthera, welcome. I am in my 16th hour of streaming in these 2 days, so this has been quite an experience. Row 5 line. Okay, so we're looking carefully at what can go on this, I think. Let's see. So it now has an 8-9 pair. Oh, because there's an 8-9 pair in the box. Okay. Alleluia. Okay. So we got there. We got there. Okay. So there was an 8-9 pair in this box that I did not see for however long. So there's an 8 and a 9 over here. Uh, and so that tells us immediately that this is not a parity party line. And so this is either a Renban or a Whispers. And we'll probably know very shortly which one it is. Has the next stream been scheduled yet? The next stream has not yet been scheduled. It'll probably be next Saturday, but you might get one earlier than that, so you never know. Okay. And it can't be a Renban line because there's no 7 on it. And an 8-9 would need a 7. Good catch, chat. Dashing my hopes of a Renban line yet again. So the 8 and 9 can't go next to each other. So the 8-9 can't go in the middle. So we have these two just are an 8-9 pair. Let's see. This has to be a 3 now, because that's the only digit that's left in the row that can go between them. So that's a 5, that's a 3. And so this can be from 1, 2, 3, 4, except it's not a 3, because there's, well, a lot of reasons why it can't be a 3. Okay. Let's see. The 2 is getting pushed into a not too small number of places over here. Where is the 7 in this box? The 7 in this box is down here somewhere. It's not immediately helpful. The brown line can't be a Renban. Yes, it can't be a Renban because of this 7-9. That is beautiful. Okay, so the T points out this can't be a Renban because this 7-9 sees the whole thing. That is gorgeous. Okay, so this is either a parity party or is either a parity party or a Whispers line. I don't know which yet. Let's see. I have a 7-8-9 triple in this column somehow. So that's not a 9. Let's see. Oh, Barbie is suggesting I look at 8 in column 8. So the 8 in column 8 is not in this box because this box has an 8-9 pair in it. It's not there. So the 8's down here somewhere. Let's see. Let's update some pencil marks here. So that's not a 7 anymore. That's not an 8 anymore. I was hoping that that would do a little bit more than it did, I'll be honest. Let's see. The 8's down here somewhere. Don't see a lot going on here. Okay, so that could still be a 4. Okay, so box 7 has a 4, 5, 6. And so Lestesh is saying because box 7 has a 4, 5, 6, this can't be a Whispers. Okay, so let's look at that. So 1, 2, and 3 are gone in the row. So the only thing I could possibly do if I wanted to make this a Whispers would be to make this a 4 and a 9. And so it would have to go 4, 9. and then a low digit here, and then an 8, 9 here. But let's look at 4, 5, 6 in this row. Because 4, 5, 6 can't go here. And so 4, 5, 6 actually is a hidden triple in the row. That's a 4, 5, 6. Okay. Now, as soon as you know that because this is a hidden triple in the row, you need 2 of 4, 5, 6. The only way this possibly works is if this is a parity party line. So this is a blue parity party line. So this is a 4, 6. That's an 8. That's a 2. So that's going to give us, that's a 5. This is going to be a 7 or a 9 to finish the row. I don't know which one. These aren't 5. Let's see. Okay. Looking up and over, that's not a 2 anymore. That is a 9 now. Oh, this should still be half green. So what's going on in this row now? Let's empty out some of this. So that's not a 2 or a 3 or a 5. That's better. Let's see. Good on that. That 8 sees up here that that's a 7, and that's an 8. I'm hearing something about 8s looking into box 2. Oh, this 8 is looking at that 8. Okay, so that's not an 8. So that is an 8. Good. Thank you. Let's see. 8 in box 2. Okay, just got the 8 in box 2. This is an 8, 9 pair here. So this is 7, 8, 9 already gone. These aren't 3. So, yeah. Okay, what is down here? Three, 4, 5, 6, 7, 8, 9. 2 in column 9, I am being requested to think about. It's not there. It's either there or it is there. This is the only place. Okay, so good spot. Hidden 2 in column 9. So that is our little 2 for the column. 7 in box 3 looks down. Yes, it does. Thank you. So that's a 7. These aren't 7. Let's see. Okay. 9 in box 3. Yep. That's not a 9, so that's a 9. Is that the last 9? No, it is not quite the last 9. We have, in fact, several more 9s to feng shui into the grid. Okay. So we have 2 more of these things to figure out. Oh, there's a 1, 4, 6 triple in column 9. That is a good point. Okay, so that's not a 4. So this is a 3 or a 5. And let's write in the candidates for the rest. So 3, 5, 7 is what's left in the column. Are we going to get absolutely nothing out of 3, 5, and 7? Okay, that's not a 3. I can say that much. Oh, that's not a 3 either, for that matter. But I think this can still be anything. 5 can't be on that line in row 9. Oh, you mean 5 can't be anywhere on here? I'm not sure I see what's going on yet with that. Remaining 4 cell line can't be a Renban. So 4 or 6 is gone from this. So if this wanted to be a Renban, it would have to be... Okay, so... Wait, yeah, both 8 and 2 are locked off of this. So that would mean that if this were a Renban, it would be coming from 3, 4, 5, 6, 7. But you'll notice that of those, I'd need a 4 and a 6 always, and I can't have a 4 and a 6. So this is not a Renban. This is either an odd parity party, or it is a Whispers. Okay, now I'm going to write in candidates for this cell because there aren't that many of them, and it is an interesting consideration. Interestingly, this can nominally be a 6, but it can never actually be a 6. Because if it tried to actually be a 6, it would be either on a Whispers line or an even parity party line, which is not okay. So this is at most 5. And it could be... It can't be 4 for the same reason. If it were 4, it would be on either an even parity party, which is wrong, or it would be in the middle of a German Whispers line, which is also wrong. So it's not a 4. It could be a 3. It's not a 2. It could be a 1. Oh, and it's not a 3 because there's a 2-3 pair in the box. So in fact, this is limited to a 1 or a 5. So if it's a 5, of course, that makes this a parity party line. Which would have to have a 9 here. Let's see, so 5 and 9. So there would have to be a 7 on it here exactly. So it would have to go 5, 9, 7. And this would have to be a 3. Which is annoyingly all possible. Oh, it's not all possible because of this. Oh, Lord. Okay, so... Wow. Wow. Okay, so this 3, 5, 7 is lopping off the possibility that this is a parity party line. Because if you have a parity party line, you can think of this as like a Renban, but only on 5 digits. And so your Renban on 5 digits of length 4 always includes the middle 3. And the middle 3 would be 3, 5, and 7. So this is not a parity party. It's a Whisper line again. And so as soon as this is a Whisper line, it doesn't have a 5 on it. This is a 3 or a 4. So this is an 8 or a 9, but it's not an 8, so it's a 9. This is a 7 or a 6. I don't think I know which one yet. Okay, and so now that's not a 9. Okay, so what's left in the box? We still have a 4, a 5, and a 6 and a 7. Not a 4. There's a 4-6 pair in the box. I'm not sure what we're talking about. I definitely don't think there's a 4-6 pair in this box, but I suppose I could be wrong. Oh, in box 9. In box 9. Okay, yes, this is a 3 because there's a 4-6 pair. Okay. That's a 3. Good. Okay, so now looking at this. So thankfully, we know this can't be a Whisper line. We've had enough Whisper lines. So this is either a parity party or a Renban. So it is either... Well, it can't be a parity party for even. Because if it was a parity party for even, it would have to be 4-6, which would break this cell. So it's either a 5-7 for the parity party, or it's a Renban, which has like any combination of these digits on it. Oh, but interestingly, this definitely has a 4 on it. And so because this definitely has a 4 on it, it can't be a parity party. It has to be a Renban. It definitely has a 4 on it just because of Sudoku plus the column. So that's a 6 because there's a 4 on this. So this is not a 6. In fact, the 6 is placed here. That's a 4. Now this really is a Renban. And this is a 4-5 Renban. So that's a 7. So that 7 is going to look up here and see that. This 3 is going to look over here, which gives us an 8-9 pair, which is going to give us a 3 there. Let's see. What's left? Oh, this 9 sees over that that's an 8. So that's a 9, that's an 8. That's a 9, that's an 8. That's a 9. Let's see. There's a 6 down there now, so that's a 2. That's a 6. There's a 3 and a 2, and that 3 sees up. That's a 5. That's a 3. That's a 7. We are in very good shape on a lot of this Sudoku stuff anyway. So these aren't 6. So they aren't 3 either. So they're from 2, 4, 5. That one's not a 2. That one's not a 2. This one. Oh, that one's not a 2 either. So 2 is actually placed. It can only go there. There's a 4, 5, 6 triple, so 3 goes there. Okay, 4, 6 pair, 4, 6 pair. Let's see, this box is done. So yeah, looking all over there. Down here, this isn't a 3 anymore. So it is a 5 or a 7. That's a 5, 7 pair, which looks up to see that that's a 3. So that's not a 3. Let's see, what's going on now? What's left in this row? Still need a 1, 4, 5, 6, and not a 7, 8, or 9? Yep. I may know absolutely nothing about any of those digits, actually. Let's see, 8 in box 9. Yep, 8 in box 9 is there. Thank you, chat. Let's see, what all is left in this box? We still need a 1. Oh, and the 1 goes there, even. We don't need a 2. We don't need a 3. We don't need a 4. Oh, and we still need a 5 and a 7, I guess. Yeah, this is a gorgeous puzzle. Let's see. This is from 4, 5, 6, 7. I really like ambiguity puzzles usually. I think they're a lot of fun. So that's not a 1. Ah, that's a 6. There we go. That's a 1 from the column. That 1 sees up. So that 1 sees down. That's a 4. So that's a 6. That's a 4. This 4 sees over, so none of those are 4s. That's a 5, 6 pair, so that's a 1. This... Okay, that's not a 4 either. Oh, that's not a 4 either. That's a 5, that's a 4. That, this 5 sees that's not a 5. Oh, sees that that's a 7, that's a 5. That 7 sees up there. That's a 6. That's a 5. That's a 6. That's a 4. That's a 5. That's a 7. And that's a 5. That's a 4. That's a 6. And that's a 4. Woohoo! That is a gorgeous puzzle. Highly enjoyed. Okay, let me see what I have in my remaining list of puzzles I have pulled up that looks like I can do in a reasonable amount of time. Let's see. We're going to try this one to finish off the stream. This Glum Hippo puzzle. We will possibly or possibly not regret it. We'll see. We won't regret it because it'll be a great puzzle. We will regret it if we're still doing it in 4 hours. So the first thing I'm going to do on this puzzle, which is a standard XV little killer puzzle, which may give me slight flashbacks from earlier, but we'll try and do it anyway. So is mark that all of these digits are low. So, oh yeah, not all X's and V's are given. Not all little killer clues are given. So, yeah, so... Okay, so let's try and find some high digits. So that digit is high. I think that's the one chat noted. This digit's on an X, and it sees 4 low digits. So that's low. Oh, bet cell? Yeah, we can have a bet cell. We're going to circle the bet cell. The bet cell is going to be up here. It is going to be row 1, column 9. Go wild with your bets. Okay. Low, low, low. Eight, perhaps. It could be. It might be an 8. Okay, so this 31 diagonal little killer is already actually a little suspicious. Because these two sum to at most 7. So these 3 digits need to sum to, at the very least, 31 minus 7 is 24. So if, say, 2 of them are 9, that would be 18. So these are always high. That's the moral of the story. The lowest any of them could be is a 6. And so they're always high. And so we get some more of those floating around, some more lows to accompany those highs. Let's see. Should I start trying to keep track of cells that are the same? Like that one's the same as that one. Because it's got to be up there. Same with the 31 little killer. This is an if like the 19 little killer, effectively 2 little killers. Okay, so now the question is, okay, so these sum to at least 4. Have a great day / night, Playmaker. Oh, now I can calculate the 31 sum differently. Oh! Yes, yes. Okay, that's gorgeous. Okay, so I should yellow this as well. So the yellow, the yellow blue and yellow orange add to 10. Great. So these add to 21. And the only way that you can get to 21 with these is if that's a 4 and this is an 8-9 pair. So that's a 1-2 pair. Okay. Thank you, chat, for spotting that. I will also do my best to note that that is a 1. So yellow isn't 1, at the very least. Let's see. So what can we do now? I should probably play more games of the form, where is this cell? Well, this has got to be a 1 or a 4 because it sees the XV with the yellow. Yeah, so I should label this. This is a 2-3V. So this is a 7 or an 8. And so that is a 2 or a 3. So this is a 1 or a 4. So this is a 6 or a 9. Let's see. Did I label that right? Yeah, this is a 6 or a 9. Okay. Let's see. Oh boy, did I not do well at trying to pick one that I could do in 15 minutes, Glum Hippo? That would be regrettable. Let's see. So this 7-8 on this 19 little killer is very suspect. So these need to sum to at most 12. Let's see. So these sum to at least... Oh boy, this one's got to be at least 5. Okay, so because all the lows are gone. So now, if I look at the 7, 8, and this 5, 6, 7, 8, those sum to at least 12. So in fact, these 3 cells sum to at most 7. Well, this one's at least 2. So now these 2 sum... No, sorry, this one's also at least 5. Okay, this is insane. Okay, so this is now looking impossible. So the minimum these 3 cells sum to is in fact 17. So the maximum these 2 cells sum to is 2. So they have to both be 1. Exactly. So that's a 4, that's a 6, that's not a 9. Take 2, that's a 4. These were both 5s, and that was a 7. That's a 3, that's a 2, that's a 3. That can be blau. Let's see. What's left in this box? 6, 8, 9 is all that's left. I mean, we've got way more digits than we did in Carousel at this point, which will probably be true for most puzzles I do on the stream. I'm going to take a guess. So box 6 is done. Oh, yes. That 1 looks over there, sees that's a 2, that's an 8, that's a 1, that's a 9. So this is, of course, a 2, 3 sort of V. So this is a 4, 6 now. This is not a 4, 6, but I don't know what it is yet. So let's see. This is a 5, so the rest of these are high. And the rest of... Yeah, so these are 7, 8, 9. I'm trying to keep my candidates updated just so that when I look at little killer clues, the things go. The XV dominoes along little killer clues. It's the XV dominoes sum to 50. Okay. Yes, okay. So, yeah, so those cells... I see this. Okay, these cells... yeah, I see Andrew's point, but there is this one extra cell that is making life difficult. It's a little bit sad. Okay, So this is not a 7 or a 1. So this is either 2, 8 or 4, 6. I don't know which one yet. This is not 2 or 4. So these are either 1, 9 or 3, 7. This is not 1 or 8. So these are either 3, 7 or 4, 6. Let's see. These aren't 4, 6, or 5. None of those are helpful. Let's see. This 19 is slowly, I think, growing into its own, because that 4 there pushed it up. Let's see, but I don't think I'm quite there yet, because this could still be like a 2 and a 1, and then still be fine. Let's see. I don't know why I'm trying to look at this little killer clue. I'm just imagining that there's a little killer clue along here that's summing to 20 or something, like in the earlier puzzle. I'm kind of surprised that I decided to go with a little killer puzzle that has X's and V's in it, but what can you do? Let's see. Our row 8, column 5 is not 8 because of the 19 diagonal. Okay, so this is a 19. So these sum to at least 6. I'm sorry, so these sum to at least, actually, these sum to at least 8. So these sum to at most 11. So I get that these sum to at most 11. But if this was an 8, oh yeah, okay. Yes, okay. That is well spotted. That requires one more step of look ahead than I was doing at the moment. Okay. The 2's already gone in this box. So these sum to at least 8. So that means these sum to at most 11. Well, if this was an 8, I could get to 11 if I made a 1 and a 2 here, except I've already used the 2. So that's not 8. Oops. So that's not 2. So we have some discussion about where 1s go in row 6. 1 goes in one of these two places in row 6. And because of that, that's fascinating. That is a beautiful catch, Ben. No matter which of these is a 1, it tells me this can't be 1, 9. Because if this is a 1, well, it can't be 1, 9. If this is a 1, now this is a 9, and this can't be 1, 9. That is very well spotted. So that is, in fact, a 3, 7 domino. Does that do anything? I would like it if that did something. It was a very good spot. I'm really impressed that someone saw that, which makes me think it probably does something. I can see that's not an 8. So one of these is an 8. So there's an 8 in here somewhere. Region forcing chain. Oh, that just sounds very approachable. Let's see. 3 degrees of freedom on the 19 little killer. That's a lot of degrees of freedom. Merry Christmas, Jessica. Nice to see you. Yeah, I said I'd do one more puzzle because I had 15 minutes left, so I decided to try and do this puzzle in 15 minutes. As long as I can do it in about negative 30 seconds, I'll have succeeded in making the goal. Oops. These are 5, 6, 7, 8, 9. Okay, so that's not a 7. That's not a 5. Please don't cough your lungs out of your body. That sounds very unpleasant. On the bright side, my bet cell is holding up very well. Much better than in the previous puzzle. So there's 5, 6, 7, 8, 9. That's not 8, that's not 9. See, row 7, column 5 is not an 8 for the other 19 diagonal. It's not an 8 for the other 19 diagonal. Row 9, column 7. Okay, yeah, so let's look at this one. Okay, so these sum to 5, so we're now down to 14. So let's try and make this an 8. If this is an 8, we are now down to 6. This could be a 3. We're now down to 3. And I cannot do that. Okay, yep, agree. So this is not an 8. Good catch. So that makes this a 4, 6, which makes that not a 6. Okay, so progress. So this is either 1, 9 or 2, 8. Don't think I know which one it is yet. Same for the 5, 7. Same for the 2, 7. Are we saying this can't be a 7? I think we might be trying to say this can't be a 7. So let's try that. Okay, so we're going to try the 19 diagonal, and we're going to try making this a 7. So if this is a 7, we're down to 12. We're now down to 7. We're now down to 3, and we can't do it. So this is a 3. That's a 7. This is not a 3, so it's black. Okay, so now I'm going to bet we can't make this a 9 or an 8 either. So let's try making this an 8. Because I'm going to bet we can't do it. So I'm going to make this an 8, which is going to leave us with 11. Take away 5. We're going to be left with 6. Take away 3. We're going to be left with 3. And we now need to make these 3. Okay, yeah, so this is never going to work. So this is not an 8 or a 9. So that's not a 1 or a 2. Let's see. Okay, so that's way better. 4, 6 pair in row 8. Oh, nice. Sees this. Good catch. 7, 3. Okay, so that's good. That's good. Okay, so now let's look at this. This diagonal is getting really, really, really congested. So let's look. What's the bare minimum? So 5, and then a 2 and a 1 would be 8, and then a 4 would be 12, and then a 3 would be 15. So this is at most 4, and so it can only be 1 or 4. Those are the only options for this digit, because it sees a 2 and a 3. Did I look at row 9, column 7? I just did look at row 9, column 7. I don't know if the coloring is doing anyone any good. But we're going to do some of it anyway. Okay, so this isn't a 7 anymore. There is a 7 up here somewhere. Not sure if that's helpful. Let's see. If this is a 6, that's a 1. Let's see. Okay, so let's see if we can play with any more experiments. So if this is a 4, then we would go 4, 3 is 7, so it'd be at 12. 8, 7. And so we'd need these to sum to exactly 7, which would only work if this was a 4, this was a 1, and this was a 2. Can these all be minimum simultaneously? Let's see. There's a 3 in box 7. Ah, yes, there is a 3 in box 7. The 3 can't go on the X because that would put a 7 there and can't. So that's a 3. Sadly doesn't, I don't think, answer my quandary, but it means there's a 3 up here, so that's a 3. So we've got... This can now only be 1, 2, or 8, 9. So 2 there, 1 there, 4 there. Does that break for some reason? I don't think so. Let's see, 4 there, put 6 there, puts 4 there, put 6 there. Yep, so that's consistent. I was just looking at what does 4 here do? Because 4 there puts 6. Sorry, puts 6, 4, 6, 4. So it actually, putting a 4 here actually forces this to be low. Oh, is this? Oh, no, never mind. What about this little killer clue? I think I know, like, literally nothing about this little killer clue, don't I? As close to nothing as it is possible for a human to know about this little killer clue, that is what I know about this little killer clue. Let's see, there does have to be a 1 and a 4 up here. So if you bet 1 or 4, it's looking good. That's not a 1. So maybe we should ask the question, what happens if this is a 1? If this is a 1, then these add to 9. And so we would need these 3 cells to add to 10. And the only way to make these add to 10 is with a 6 here. So these would need to add to 4 and be either 2, 2, or 3, 1. Aren't there 3? Because can't this be either 2, 2, or 3, 1? Yeah, so I think there are 3 viable configurations. Yeah, there's probably something else that I should look at. I don't know where the thing is I'm supposed to look at or what the thing is I'm supposed to look at, but there are, I think, 3 different possibilities that all seem to work for this little killer. And then this little killer seems like it could be literally anything. No one has any ideas. The other one has to be all minimum? Really? Okay, let's try it. Okay, so the minimum here would be 3 and 4. So it would have to look exactly like that. It would have to be a 4 here, a 3 here. So that would be 8. And now this would be... This could be a 1. And that could be a 2. And that could be a 4. So that was 8 plus 7 is 15. I think I'm way under it having to be minimum. But I'm probably missing something. But it looks to me like this could go like this. 4 there. 4 here, 3 here. No, sorry. 3 here, 4 here. And then there could be a 1 along here and a 2. So yeah, I think there's still some consternationing to do, as they say. And so, yeah, this could be a 1 and a 2, as far as I'm able to tell. Of course, is the 1 in box 5. So Ben is looking at, okay, does this box 5, 1, 2 high? This is a 1, this is a 1, that's a 9. Okay, so this is an interesting point. Okay. Good night, Ambrose. It's been a pleasure having you here. If I don't make row 9, column 4 a 2, what do I make it? Okay, so if this is not a 2, what's the second highest thing it can be? Oh, that is a good point. The second highest thing this can be is an 8. Because what are the candidates for this cell? Well, it could be 1 or 2, I think. But then it can't be 3, 4, 5, 6, 7, and then it could be an 8 or a 9. But I'm pretty sure if this is an 8, that's way, way, way over our allowance. But let's check it real quick. So this was a minimum of 8, plus 4 is 12, plus 8. Yeah, that's too big. So this can't be an 8 or a 9. So this is a 1 or a 2. That's good to know. So that's a 1-2 pair in the column. If I make this a 1, what does it make this? So now, if I make this a 1, now this suddenly can't be 2, 3, 4. It could be 5, 6, 7, 8, 9. But now, if I make this a 1, then this is a 4, and this is a 5 at minimum. That's 10. Plus, it looks like I could still make this work. Just barely. That places a 4 in column 4. The 1 sees 1, 4, so that one cell isn't a 3 or a 4. Oh, okay, so yeah, this 1... Oh boy, yeah, okay, this is a somewhat complicated thing. If this is a 1, what happens? Then this becomes a 4, and so that already pushes this up 1. So then this has to be at least 5. But this being a 4 also makes that a 6, makes that a 4, makes that a 6. So if this is a 1, it actually makes this a 6 and makes this a 5 at least. And now I think we're at too many, because now it's 1, 6 is 7, and 5 is 12, and 5 is 17, 18, and we're broke. So this actually can't be a 1. It actually literally does have to be a 2. It's the only possibility. So that's a 1, that's a 9. That's not a 9. Oops, not a 9. That's not a 9, that's not a 9. Okay, so that is very interesting. Okay, so now that 9 has made an appearance on this. No, that 9 has not made an appearance on this diagonal. Okay, so now, yeah, I can unpencil that. Probably a good idea. So now this one. Yeah, that was very that was an interesting and surprising interaction here. Okay, so that's 6, 9. So I need these to total to 10. So if I need these to total to 10, what ways are there to do that? Let's see. 4, 4, and 2 works. Or 3, 1, and 6 works. Okay. So unfortunately, I think all of those ways work. Column 4 does some work now, so let's fill in the candidates in column 4. Per Loretta's suggestion. By the way, welcome, Loretta. I think this is the first time I've seen you in chat. 4, 5, 6, 7, 8. Okay, that's not an 8. It's not a 6. That, I think, could be any of those things, but this can't be a 4 or a 6 or a 7. Oops. Can't be a 4 or a 6 or a 7. Okay, so that's an 8. That's great. So that's a 6. This is not a 6 or 8. Very nice. Okay, so suddenly that did a whole lot of Sudoku-y goodness. So there's a 4-7 pair. Okay, so... Okay, so Glum Hippo's pointing out if this... No, row 9... Yeah, row 9, column 4. Oh, yeah, okay. This is talking about how if this had been a 1, it would have completely broken everything over here. The 4s have been placed in that column for a while. Yes, 7, 4. Good. Oh, that 1 says that's not a 1. So where is the 1 in this box? The 1 in this box is here. So what digit is this? That's a 5. Let's see. What are these digits? Are they going to do magic too? I would appreciate if they did magic. Let's see. 1, 2, 3, 4, 5, 6, 8, 9. Okay, well this isn't 6 or 8, so it's looking promising. This isn't 5 or 9. This cell has let itself down. Oh, something's up here. Okay, this is not a 6. That's an 8 or a 9. So the 6 is definitely in one of these two cells. Where are 1 and 9 in box 7? Ah, gotcha. Okay, so the 1 got placed over here by Sudoku, so that is now a 2, 8. That's a 9. Nice catch. Let's see. So what's left in here? We need a 2 somewhere. 4. We need a 5 somewhere. And a 7 and an 8. That one's not a 5. Sorry, I said a 7 and an 8. What did I actually put in? I put an 8 and a 9. There we go. Let's see, the 8 in row 9 is now fixed. It has to go there. So that's not an 8. So 8 is up here somewhere. Okay, and so we've fixed... Chat is telling me this little killer clue now. I would believe that. Okay, so now 19 minus 5 is 14, minus 1 is 13, minus 3 is 10. So I need these 3 cells to sum to 10. This looks exactly the same as it did before. Let's see, 4 here would work with a 2 and a 4, or a 6 here would work with a 1 and a 3. So I think this is still all on the up and up. Let's see, what can this cell be? Let's see, it looks like it could be a 1, can't be a 2, 3, could be a 4, can't be a 5, could be a 6, can't be a 7, 8, could be a 9. Oh, but it can't be a 1 because there's a 1 in the column. So this is a 4, 6, or 9. Hey, Raph, Penguin U2. Let's see. Yep, I eventually got that it couldn't be a 1. It just took a while. Let's see, yeah, the 1 over here is not quite restricted enough to be useful. It's getting close. Let's see. For those of you who come here for grid coloring, I will grid color. just in case it makes anything jump out. We could inspect row 5, column 7. Why don't we do that? So what values can this cell have? It can't be 1 or 2 or 3. It could be, no, it can't be 4. It can't be 5. It could be 6. It can't be 7. And it could be 8. No, it can't even be 8. It just is a 6. So that's an 8. Good spot, Mr. Cat. So that means that this is a 5. So this is now just, it's not a 5, it's not an 8. I think this is the 6. So let's see, what is left in this box now? 3, 4, 5, 6, 7, 8, 9. That's not a 4. That's not a 7. Okay, what is left in here? Two, 3, 9. That's not a 9. That's not a 2. Let's see. That did do a lot of good, though. Have I missed a pencil mark here? Yeah, that's not a 5 anymore. Box 6 needs an even and an odd on the little killer. Ah, okay, yeah, there we go. So I've somehow completely forgotten that this 19 diagonal exists. But if I look at it, this is an excellent point. So the sum of this is always odd. And so the sum of these digits has to be even, which means that it has to be 2 odds that appear here. I think I got the opposite parity that you claimed, but I think this goes even, even, odd. So this is odd in total. So this has to be even in total. So I think this can't be even. So I think this is a 3, 5, or a 7. So speaking of, since I've completely forgotten that this diagonal exists, let's see if this diagonal does anything good now. So 2, 1, 1 is 4, so we need these to sum to 15. What did I do wrong? I certainly added this wrong, so I did not math that correctly. Let's try again. Oh, did I just not see this cell? That's probably what happened. Okay, so even, even, odd, even, odd. So this has to be even. Okay. And so it has to be a 4. So that worked out way better than it did originally. So that's a 1. Finally, we get that digit. So these aren't 4. We were forced to wait for that one for a long time. Okay, so that now I think tells us what happens here. So for the last time, 5, 6, 10 means I need to make these two add to 9. So that's a 6 and a 3. So that's a 2. I'm being encouraged to note something about the existence of 3s somewhere. But let's not dwell too much on the existence of 3s because I noticed that this is almost done. So that's a 7, 11, 12. So that needs to be a 7 in order to work. 9, 3. That's a 2. No, it's not a 2. Try again. That's a 9. Better. Let's see. This is not a 7, so that's a 3-5 pair. There's a 9 over here, so that's a 7-8 pair. Let's see. I think we have all the little killers done now, right? I'm not missing one. Fortunately, scanning is often something that that chat is very helpful with, because if something is hard to see and it's scanning, usually someone in chat can see it. And so I actually think scanning heavy puzzles are quite often good puzzles to do on stream because the chat is very helpful. Okay, let's see. Did some Sudoku there. Let's see, this 5 sees that that's a 3 and that's a 5. This is not a 9. See, that's, oh, that 1 sees over there that that's a 9 and that's a 1. Let's see. This is not a 7. So this is a 2 or an 8. That's a 2 or an 8. So yeah, we can just decolor the whole grid if people will like that. I am proud of myself for this bet cell. I think I did well with picking the bet cell. These are not 7. Let's see. Something about a 7 in box 3. Yep, that's the 7 in box 3. So now that lets us do 8 in box 3, which is now there, which lets us do that 5, and that 2, and that 8. And so these are not 8. That's a 2-5 pair, so that is a 7. That's an 8. These 2 digits are a 6 and a 9, and I know the order. That's a 6, that's the 9. Let's see, that 4 is looking over and seeing that 6 and that 4, and that 6. Over here, we have 2. We still need 3. Let's see. Yeah, so we still need 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's not the 9. That's not the 2. Is that also a 5 or a 9? Looks like it. So that's the 2. The 5, that's the 2. That 5 tells me that's a 9 and that's a 5. 1, 2, 3. Okay, so this has got to be the 4, which popping up here tells me that's the 4, which tells me that's the 2, which tells me that's the 6, which, drum roll please, tells us that that's a 1. So if you bet 1 for your bet cell, good job. Alrighty. That's going to wrap it up for the stream for today. Thank you for joining us if you stopped by. Happy holidays. Enjoy the rest of your Christmas. We'll be continuing to stream regularly, so pay attention, subscribe for updates. We'll definitely do more. That was a very cool puzzle. I definitely enjoyed that. I'm going to go eat some curry now. But have a lovely night, and penguin, penguin, penguin.